In this video, I'll describe the basics involved in the FSD development methodology. A full-stack developer is a developer who has a wide knowledge of technologies required to build an application with specialties in several different concepts. Specifically in web development, a full-stack developer is a person who specializes both in the server-side backend code as well as the client-side front-end code. Full-stack developer job openings have been increasing numerously over the past 5 years as companies are realizing the cost savings as well as the effectiveness of having a single individual work on both the front end and back end of a web application. First of all, we'll start off by talking about front-end development from a full-stack developer perspective. Front-end development can be broken down into several components. These include front-end frameworks, HTML, CSS, JavaScript, jQuery, Ajax, user interface design, and user experience design. HTML, or Hypertext Markup Language, is the standard markup language used to display documents in web browsers. HTML pages are made of HTML elements such as images, paragraphs, and input fields. CSS, or Cascading Style Sheets, is often used alongside HTML to help organize the visual presentation on an HTML document. JavaScript is used alongside HTML and CSS and allows web pages to be interactive, allowing actions such as going to another page if a button is clicked, or displaying a text prompt on login. jQuery is a JavaScript library commonly used to simplify HTML document traversal and event handling. Ajax allows a web application to communicate to a server and update a page without the need to reload it. Front-end JavaScript frameworks such as React, Angular, and Vue help in better organizing and speeding up the development of the front-end functionality and the look and feel as well. User interface design deals with designing what the user sees, such as menus, graphics, and logos. User experience design deals with how the user interacts with the website and how intuitive it is to accomplish a task from the user interface. Backend development deals with the server-side and data creation, updating, and management tasks of a web application. There are several components to backend development. These include languages and frameworks, databases, server management, as well as APIs. Languages and frameworks are what the backend server-side code is written in. Examples of these include Python and the Django framework, Ruby on Rails, and Ruby, and JavaScript with Node.js. Some backend frameworks like Ruby on Rails use the MVC or Model View Controller architecture to separate user data from controller logic and the user interface. Databases are used to store data. The two types of database systems are relational, like MySQL or PostgreSQL, and non-relational, like Mongo. Relational databases store data in tables with rows, while non-relational databases store data in collections, for example with Mongo of JSON documents. A web application needs to run on a web server, such as Apache, in order to be able to handle requests and display itself to users. Servers can either be run locally or through a cloud platform like Heroku or Amazon Web Services. APIs specify how various components of an application or various applications should interact. An example of this can be an API which gets called from a user request at the front end to create a resource which gets saved in the database backend. A popular example of a HTTP-based web API is the REST API, or Representational State Transfer. With the REST API, an application can send requests such as GET, PUT, and POST to other web services using HTTP in order to establish communication between applications. SOAP, or Simple Object Access Protocol, is a protocol used for web communications that has more security as well as a retry logic for messaging compared to the REST API. As I mentioned, there are relational SQL databases or SQL databases such as MySQL, which store data in tables, as well as non-relational or NoSQL databases such as Mongo, which store data in JSON files. SQL databases are better for structured data, while NoSQL databases are better able to handle loosely structured or unstructured data and have better performance on large data sets such as those used with big data web applications. To sum it up, a full-stack developer needs to not only have expertise in front-end and back-end development, but also in front-end and back-end frameworks, jQuery, Ajax, responsive design, user experience, databases, web server and cloud deployments, options, and APIs, just to name a few. Given this extensive list of knowledge required to successfully operate as a full-stack developer, it is no surprise that full-stack development will continue to be an in-demand field in the future. In this video, I'll describe the fundamentals associated with the Agile development methodology. Agile software development is a methodology for managing software development projects and teams, and it differs from Waterfall software development. The Agile Manifesto was written in 2001 by a group of 17 software developers in an attempt to promote lightweight software development methods. The Agile Manifesto has 4 core pillars or values for improving the software development process. The first pillar is that individuals and individual interactions between team members over processes and tools. This basically means that people are the core value of a software project, and that if these people are forced to conform to certain processes or tools, that they will lose creativity and problem-solving abilities. The second pillar is working software over detailed documentation. This basically means that an emphasis should be placed on developing software that works over detailed documentation, as working software is more critical of the two. The third pillar is customer collaboration. This basically means that the initial contract signed between two parties means less than the work done afterwards, and that instead of blaming one another for mistakes, it is better to work together to come up with an optimal solution. The fourth pillar is embracing and responding to change. In most software products, customers don't really know exactly what they want until a working product is presented to them, so the agile methodologies and values embrace change to make a better product. Aside from the values listed in the Agile Manifesto, there are also 12 Agile principles which follow the manifesto values and which also explain in more detail how Agile operates at the ground level. Agile methodologies are the actual methods that can be used to implement the Agile values and principles. Examples of the Agile methodologies include Scrum, ASD, and Crystal. As I mentioned in the previous slide, there are 12 principles which underlie the 4 Agile Manifesto values. The first of these values is continuous delivery. This basically means that software has to be shipped out early and in stages to the customer and not in just one big batch once everything is done. Preparing for change is the second principle, in which processes need to be able to deal with the change requests from customers in order to develop a better product. Similar to the first value, software which works needs to be delivered at a frequent time interval to get constant feedback from the customer. The fourth principle is that developers need to work and communicate with business people on an ongoing basis to ensure all requirements are met. The fifth principle is to work with motivated individuals and to accommodate any requests that these individuals may have in terms of their work environment. The sixth principle deals with the value of face-to-face interactions and having them as often as possible during a software project. Principles 7 to 12 deal with using working software to measure progress, enabling a constant, sustainable pace of development over rushing things, paying attention to technical design and detail so that no architecture mistakes are made, valuing simple design and self-organizing teams where basically everyone has a say in what goes on and they're not bossed around by management, and reflecting on past behavior and implementing a plan in the future to improve processes and increase productivity. As I mentioned, Agile methodologies are the actual ways that Agile can be implemented to support the values and principles of Agile. Some popular Agile methodologies include Scrum, Kanban, XP, Crystal, RUP, and FTD. Different methodologies work better for different companies and projects, and there is no one Agile methodology which is best. Scrum is a framework to use Agile to get teams to work together. It values things like continuous improvement, learning from mistakes, and using self-organizing teams. Scrum teams work in sprints, which are short timeframes to complete a block of work. Kanban is a lean software development methodology and is structured similar to an assembly line where the number of items that enter are equal to the output of completed items so that a team can deliver at a constant rate. XP, or Extreme Programming, is designed to produce better quality software with things like dynamically changing requirements and small remotely located development teams. The Crystal Agile methodology is designed to concentrate on the people and their interactions in order to make a software project successful. RUP, or Rational Unified Process, divides software development into 4 phases, including inception, or the idea for the project, elaboration, which is the architecture design, construction, which is the development, and transition, which is the release to the public. FTD, or feature-driven development, is an agile methodology which focuses on lightweight, iterative software development processes with a high input level from the client or customer. In this video, I'll distinguish the major differences between the waterfall and agile development methodologies. Unlike agile software development, where software is developed in increments, The more traditional waterfall method follows a sequential design process. There are 5 basic phases to the waterfall method, and these are requirements, design, implementation, testing or verification, and maintenance. Each phase has to be complete before the next phase is started. In the requirements phase, meetings are held with customers to figure out what they want developed. Once scattered, the architecture of the product is designed by the software architects. After this phase, the actual development is done. Once the development is complete, the QA teams does the testing, and then the product is shipped to the customer. Once in the customer's hands, any maintenance or modifications are done afterwards. There are several advantages to using the waterfall processes over Agile. Ease of management is an advantage because each phase is clearly defined and there is no progress to the next phase until a phase is completed. Waterfall works well with projects that have simple requirements which can be established at the start of the project. Delivery of waterfall projects is quicker because there are no iterations from client demands until the project is fully completed. Documentation can also be more easily organized with a waterfall project as everything runs in a predictable fashion. Waterfall projects are also more adaptable to new or changing team members as each feature is well documented and there is groundwork in place to continue working on the feature. Dependencies are also more easily managed as things don't change nearly as quickly as in Agile. There are also several limitations or downsides to waterfall projects. Waterfall processes are not effective for projects with complex or poorly defined requirements, as there is no iterative development done and modifications are only done once the final product is delivered to the customer. The ability to change requirements is also more difficult as the whole process runs in a sequential fashion and previous phases are already defined and take more work to redo. Testing also becomes potentially more expensive and time-consuming, as bugs are often not surfaced until the end of a project, which makes fixing errors more difficult. Similar to the waterfall process, the Agile process still needs to define the project goals, gather requirements from the customer, and plan the product architecture. The difference with Agile is that the process of doing these initial steps is not as detailed and consumes less time than in the waterfall software process. This is because the development or implementation phase of the Agile process reiterates requirements, project goals, and architecture plans. By developing software in an iterative fashion with the customer in the loop and testing done concurrently with feature development, it becomes easier to change requirements and architecture later on. One of the major advantages of Agile is that it focuses on the client and having them constantly in the loop so that when they give advice, they could get exactly what they want. The Agile process gives teams a self-organizing capacity, giving ownership to individuals for features, which increases the level of motivation amongst employees, and that often leads to a higher end product quality. Since testing is done alongside development, quality is maintained and bugs are fixed throughout the whole software development lifecycle. All features are developed incrementally in the Agile process so that everyone associated with a project knows which feature are done, and this also increases the transparency to the client so they could know what still has to be done and what's complete. Similar to the waterfall process, the Agile process has its own downsides. It is not particularly useful for small projects or projects where requirements are extremely simple and well defined at the start, as the waterfall process produces quicker results in those cases. The cost of implementing an Agile methodology is higher than with other projects, as there is a certain amount of setup and training required. If customers don't want to show cooperation or don't have a clear vision of the end product, Agile can cause unnecessary time overhead and still lead to an unsatisfied end client. The experience for team members undertaking an Agile project also has to be higher than with the waterfall process. This is because ownership and responsibility of an entire feature is often delegated to an individual developer, and that developer may need to make architectural decisions, which is not easily done by novice programmers. In this video, I'll recognize the influence that Agile development had on the full stack methodology. Agile methodologies are the actual ways that Agile can be implemented to support the values and principles of Agile software development. Some popular Agile methodologies include Scrum, Kanban, XP, and FDD. Different methodologies work better for different companies and projects, and there is no one Agile methodology which is best. Scrum is a framework to use Agile to get teams to work together. It values things like continuous improvement, learning from mistakes, and using self-organizing teams. Scrum teams work in sprints, which are short timeframes to complete a block of work. Kanban is a lean software development methodology and is structured similar to an assembly line where the number of items that enter are equal to the output of completed items so that a team can deliver at a constant rate. XP, or extreme programming, is designed to produce better quality software with things like dynamically changing requirements and small remotely located development teams. FDD, or feature-driven development, is an agile methodology which focuses on lightweight iterative software development with a high input level from the client or customer. One of the major goals of Agile is to have short iteration periods or sprints of work where features can be developed, tested, and reworked rapidly. Thanks to cross-platform frameworks for full-stack development such as React Native, NativeScript, Flutter, Xamarin, and Accelerator Titanium, rapid prototyping is possible. With React Native, a combination of JavaScript and React can be used to build cross-platform mobile application using reusable components in a short time frame. Similar to React Native, NativeScript uses Angular, Vue, TypeScript, and JavaScript to make cross-platform mobile apps. React Native generally has better performance over NativeScript, and since it's developed and maintained by Facebook, it also has a wider set of plugins and community support. Flutter is an open-source framework designed to use the Dart language to develop cross-platform native apps. Dart was developed by Google and supports features such as a native UI, hot reloading, and fast performance. Xamarin is built by Microsoft and uses C# as the main language, and developers can build across platform applications for Android, iOS, and Windows using a single .NET codebase. Titanium is an open source tool which allows developers to build cross-platform compatible applications using JavaScript. Cross-platform APIs are provided in order to access native user interface elements and to access various device operations such as the network and file system. Various web frameworks enable agile methodologies to be supported when building web apps. These include React, Angular, and Vue.js, Meteor.js, Ember.js, and NPM. React.js is designed to help speed up and simplify the design of a frontend using JavaScript, reusable components, and virtual DOM, along with declarative programming. Angular is a JavaScript framework built by Google and is designed to help single-page web applications to be designed by adding components onto HTML in order to build dynamic web pages. Vue.js was created by an ex-Google employee and uses JavaScript, HTML, and CSS and reusable components in order to create dynamic web pages with optimal performance. Meteor.js is open source and it's used to aid in building full-stack applications across web, mobile, and desktop. Vue, React, Angular, along with MongoDB, NPM, and Cordova are all integrated together in order to speed up development in Meteor.js. Ember.js is an open-source JavaScript model view model framework which allows developers to create scalable single-page web apps with minimal code. NPM, or Node Package Manager, is the most popular package manager for JavaScript. It enables developers to incorporate reusable packages into their web applications. HTML, or Hypertext Markup Language, is the standard markup language for documents in web applications. HTML is often used alongside CSS and JavaScript to make dynamic cross-platform frontends. There are various frameworks available to speed up the writing of HTML code. Ionic is a cross-platform HTML framework which combines HTML and CSS and JavaScript along with Cordova and plugins that support hardware features such as camera support. Ionic is used to speed up the process of creating cross-platform mobile and web apps. OnSend UI is based on PhoneGap and Cordova, and it is an open-source framework for UI development for mobile apps. It supports HTML5, CSS, and JavaScript. Apache Cordova is a mobile app development framework which extends the functionality of HTML, CSS, and JavaScript to work in a mobile app on a device. Cordova applications are hybrid, meaning that they are not fully native mobile apps and not fully web-based either. Framework 7 is an open-source HTML framework for creating iOS and Android hybrid apps with a native functionality and appearance. It enables developers to quickly prototype mobile apps using HTML, CSS, and JavaScript. Using online integrated development environments or IDEs speeds up the time to get started coding because there's no need to install and update software. Cloud9 is a web-based and cloud-hosted IDE designed by Amazon which contains a code editor, window, command line, and debugger. It allows developers to write, execute, and test code in the browser and supports languages such as Python, PHP, and JavaScript. Code Anywhere is a fast-loading IDE which supports over 72 languages and allows developers to collaborate across multiple devices as well as to edit files across multiple storage systems such as Dropbox and GitHub. CodeEnvy by Red Hat allows developers to build, edit, run, and debug code in the browser and supports one-click Docker setup and shared environments between OSs. REPL.it is one of the most simple web-based IDEs, and it supports Python and various other languages as well as hosting of websites. Coding is an online IDE which works well for collaboration and full-stack apps as it allows integration with other services. Orion is a cloud-based open-source coding environment which can be deployed by developers, and it supports JavaScript, HTML, and CSS. Serverless computing allows applications to save time and resources by instead of using a native web server, they can instead call third-party servers hosted by companies such as Google or Amazon. These servers run applications and auto-scale them up or down depending on demand. Firebase by Google allows developers to quickly build apps without worrying about managing the infrastructure. Firebase provides real-time analytics, crash reporting, and performance metrics for an application, which can all be viewed through an easy-to-use web dashboard. It also offers multiple useful services such as machine learning toolkits, real-time database functionality, cloud functions to run backend code in the cloud, hosting, and a simple authentication framework, all making it quicker and easier to develop a full-stack application. In this video, I'll describe the advantages and disadvantages associated with using the FSD methodology. A full-stack developer is a developer who has a wide knowledge of technologies required to build an application with specialties in several different concepts. Specifically in web development, a full-stack developer is a person who specializes both in the server-side backend code as well as the client-side front-end code. In the case of a JavaScript full-stack developer, they also have to be familiar with both front-end JavaScript frameworks such as React and Angular.js, as well as backend frameworks such as Express.js. A full-stack developer also needs knowledge of web services such as REST and SOAP in order to successfully transfer data from the server to the client and vice versa. First, we will start by talking about front-end development from a full-stack developer perspective. Front-end development can be broken down into several components. These include front-end frameworks, HTML, CSS, JavaScript, jQuery, Ajax, user interface design, and user experience design. HTML, or Hypertext Markup Language, is a standard markup language used to display documents in web browsers. HTML pages are made of HTML elements such as images, paragraphs, and input fields. CSS, or Cascading Style Sheets, is often used alongside HTML to help organize the visual presentation on an HTML document. JavaScript is used alongside HTML and CSS, and it allows web pages to be interactive, allowing actions such as going to another page if a button is clicked or displaying a text prompt on login. Backend development deals with the server side and data creation, updating, and management tasks of a web application. There are several components to backend development. These include languages and frameworks, databases, server management, APIs, and operating systems. Languages and frameworks are what the backend server-side code is written in. Examples of these include Python and the Django framework, the Ruby on Rails framework, and JavaScript with Node.js. Some backend frameworks, like Ruby on Rails, use the model view controller architecture to separate user data from controller logic and the user interface. Databases are used to store data. The two types of database systems in use are relational, like MySQL or PostgreSQL, and non-relational, like Mongo. Relational databases store data in tables with rows, while non-relational databases store data in collections of JSON documents, for example, in Mongo. A web application needs to run on a web server like Apache in order to be able to handle requests and display to users. Servers can either be run locally or through a cloud platform like Heroku or Amazon Web Services. APIs specify how various components of an application or various applications should interact. An example of this can be an API which gets called from a user request at the front end to create a resource which gets saved in the database on the back end. Lastly, the operating system for the web servers, such as Ubuntu or Windows Server, determines the setup and performance of the web server. Similar to the waterfall development process, the Agile process still needs to define the project goals, gather requirements from the customer, and plan the product architecture. The difference with Agile is that the process of doing these initial steps are not as detailed and consume less time than in waterfall software development. This is because the development or implementation phase of the Agile process reiterates requirements, project goals, and architecture plans. By developing software in an iterative fashion with the customer in the loop, and testing done concurrently with feature development, it becomes easier with Agile to change requirements and architectures later on. One of the major advantages of Agile is that it focuses on the client and having them constantly in the loop so that they get exactly what they want. The Agile process gives teams a self-organizing capacity, giving ownership to individuals for features, which increases the level of motivation amongst employees and often leads to a higher quality end product. Since testing is done along with development, quality is maintained and bugs are fixed throughout the whole software development lifecycle. All features are developed incrementally in the Agile process so that everyone associated with a project knows which features are done and which features are going to increase the transparency to the end client. Similar to the waterfall process, the Agile process does have its weaknesses. It is not particularly useful for small projects or projects where the requirements are extremely detailed and the user knows exactly what they want. Because in that case, it's actually going to take longer with Agile to produce an end product. The cost of implementing an Agile methodology is also higher than with other projects, as there's a certain amount of setup and training required at the start. If customers don't want to show cooperation or don't have a clear vision, Agile can cause unnecessary time overhead and still lead to an unsatisfied end client. The experience for team members undertaking an Agile project has to be higher than with waterfall processes. This is because ownership and responsibility of an entire feature is often delegated to an individual developer, and that developer may need to make architectural decisions, which is not easily done by novice developers. Front-end JavaScript frameworks such as React, Angular, Ember, Backbone, and Vue use reusable components in order to help better organize and speed up the development of front-end functionality, which aids in a quicker prototyping of an application. React.js is designed to help speed up and simplify the design of a front-end using JavaScript, reusable components, and virtual DOM, along with declarative programming. Angular is a JavaScript framework built by Google and is designed to help create single-page web apps by adding components onto HTML in order to build dynamic web pages. Vue.js was created by an ex-Google employee and uses JavaScript, HTML, and CSS reusable components in order to create dynamic web pages with optimal performance. Ember.js is an easy-to-learn front-end JavaScript framework which offers two-way data binding similar to Angular to keep synchronization between views and models. Backbone.js is a popular front-end framework which uses the MVP or Model View Presenter architecture and incorporates a REST API, and it specializes in creating single-page web apps. In this video, I'll describe the various components involved in the FSD methodology. In the previous videos, I had mentioned that a full-stack application is composed of various parts or components. These include the front-end components such as HTML, CSS, and JavaScript, the backend server-side and database code, the web server, as well as any APIs linking different pieces of the application together. We will first start by going over front-end components. In previous videos, I mentioned several front-end JavaScript frameworks such as Angular, React, and Vue.js, which were designed to follow Agile methodologies and help in more quickly and efficiently developing front-end functionality for a full-stack application. There are also several CSS frameworks available which can be used with JavaScript frameworks such as React and Angular in order to design a responsive user interface with consistent look and feel across various device types and screen sizes. The most popular of these CSS frameworks is Bootstrap, which is a framework designed to work with HTML, CSS, and JavaScript to quickly build responsive front-end user interfaces which scale across multiple device types and screen sizes. Since it is the most popular CSS framework, it contains the greatest amount of plugins and the best documentation. Foundation by Zurb is a CSS framework which offers similar benefits to Bootstrap with a wide variety of included templates. However, it is more complex and offers more customization options compared to Bootstrap. Semantic UI is a framework for using HTML, CSS, and JavaScript user interface themes designed to build fast and responsive mobile apps and websites. Pure by Yahoo is a lightweight CSS framework designed for mobile, which offers small and responsive CSS modules that can be included in any web or mobile project. Backend JavaScript frameworks run on the server side and do things such as setting up URL routes and interacting with databases. Some common JavaScript backend frameworks include Node.js, ExpressJS, Koa.js, and Happy.js. Node.js is a JavaScript runtime which is open source and allows JavaScript code to be run from outside a traditional web browser on a web server. Node.js supports asynchronous input-output or I/O and has an event-driven design. It includes extra modules for I/O, networking, and data streaming, to name a few of the most important ones. ExpressJS is the server-side framework of choice for Node.js. It is an open-source framework, and its intended design is for building the backend of web apps and APIs. Koa is built by the same team as ExpressJS, and it is meant to be a more modern, lightweight, and better way to build APIs and web apps. Koa makes writing web servers easier by removing callbacks, which are currently present in ExpressJS, and by supporting asynchronous functions. This also improves error handling. Happy is an open source framework designed for building web applications and APIs. It was built by Walmart Labs and initially used the Express framework. However, the architecture has since moved away from Express in order to better support bigger applications. The goal of Happy is to reduce the time spent building infrastructure by instead allowing developers to build reusable application logic. Data for full-stack applications is stored in databases. There are two types of databases available for a full-stack developer: SQL or relational databases such as MySQL, which store data in structured tables with rows and columns, and NoSQL databases such as Mongo, which store partially structured and unstructured data in document files such as JSON types. SQL databases use SQL statements to query the database and add or get information from it. The database data in SQL databases is structured, and each table has a schema with set data types for each column. SQL databases are vertically scalable, meaning that to improve performance, resources such as RAM, CPU, and storage can be added. Another advantage of SQL databases is that they are ACID or autonomosity, consistency, isolation, and durability compliant, meaning that the integrity of the database is protected by controlling interactions with the database. On the other hand, NoSQL databases are better suited for flexible, less structured data, which requires fast processing speeds. A good example of this is with big data applications, which often store petabytes of data in databases and need to be accessed quickly. This is why Mongo, the most popular open source NoSQL database, is the database of choice with many of the hottest startups working on big data applications. SQL databases are more generally used with traditional industries where data integrity is vital, such as in banking. While SQL databases are vertically scalable, NoSQL databases are horizontally scalable, meaning that to increase capacity, more servers can be added. Oftentimes, NoSQL databases and their storage is hosted in the cloud to make scaling more efficient. When looking at the different types of SQL databases available, there are a few popular choices, including MySQL, SQL Server, Oracle, Sybase, and IBM DB2. MySQL is the most popular open source RDBMS or relational database management system. It is used with blogging platforms such as WordPress and social media sites such as Facebook. It is also a part of the LAMP web application stack, which stands for Linux, Apache, MySQL, Perl, PHP, or Python. MariaDB is built on top of MySQL and is compatible with it, but includes a new storage engine. The Oracle database is a database designed for use with online transaction processing or OLP and data warehousing. Differing from other databases, it has a multi-model data storage architecture, meaning that models such as document, key value, relational, and graph are all supported against a single backend. The Oracle SQL database is written in C++ and comes with solid customer service and good reliability for enterprise applications. SQL Server is an RDBMS developed by Microsoft, which can run either locally or be accessed across the network, or it can be accessed via the cloud in Microsoft Azure, for example. IBM DB2 is a relational, and recently they offer non-relational databases for data management products offered by IBM. DB2 specializes in data management and analytics and works with big data applications. Sybase was the first enterprise-grade relational database for the Unix operating system. As I mentioned, there are also NoSQL databases which store unstructured and partially structured data in document stores. Popular NoSQL databases include MongoDB, Apache, CouchDB, HBase, IBM DB2, and Apache Cassandra DB. MongoDB is the most popular open source NoSQL database management system. It uses JSON files to store data in its database schema. It is horizontally scalable, distributed, and meant to run on the cloud. It is ideal for modern big data applications and is used by companies such as Facebook, eBay, and Google. Apache CouchDB is an open source NoSQL database written in Erlang. Similar to Mongo, it uses JSON files to store data, JavaScript along with MapReduce for queries, and an API which uses HTTP. CouchDB supports multi-master replication, meaning that data can be stored by a group of servers and updated by any server in that group. HBase by Apache works alongside Apache Hadoop for big data processing and runs on top of the HDFS or Hadoop distributed file system. It is modeled after Google's Bigtable and written in Java. It is a good way to store large amounts of data containing a small amount of important data points. IBM DB2, as I mentioned in the previous slide, is a set of data management and analytics tools offered by IBM. Recently, NoSQL support was added to DB2 and non-relational structures such as JSON and XML are now supported. Apache Cassandra is a distributed NoSQL database meant to run across the cloud and to store data across multiple servers without a single point of failure. It supports clusters across multiple data centers and allows for a low latency experience for all users. It is a wide column store database, meaning that it uses rows and columns like in SQL databases. However, these rows and columns can have varying forms and names across different rows within the same table. In this video, I will describe some of the most common stacks used with the FSD methodology. When a client needs a full-stack application, they're usually more concerned with what the application does and how it performs, and not so much with the technology used to build the application. The reality, however, is that certain technology stacks better suit different applications in order to get optimal performance. A technology stack is basically composed of components such as frameworks, web servers, and operating systems, which work together to create a full-stack application. As I mentioned in previous videos, an application is composed of the front-end code using technologies such as HTML, CSS, and JavaScript, and the backend, which includes things such as databases, operating systems, web servers, APIs, and backend programming frameworks. Some common stacks used in full-stack development include LAMP, Python, Django, Mean, and MERN. We will go over each one of these in more detail in the next few slides. LAMP is one of the legacy technology stacks and is still the most popular backend stack used across web applications. The 4 letters in the LAMP stack stand for L is for the Linux operating system, A is for Apache HTTP web server, the M for the MySQL relational database, and the P for the PHP programming language. LAMP is very stable, secure, and highly customizable, and even though it is meant to run on the Linux OS, it can also be used on Windows or the Mac OS. For Windows, the installation of LAMP is known as WAMP, and for Mac OS, it's MAMP. The LAMP stack is used to host various website frameworks and builders such as WordPress. Some of the components of the LAMP stack are interchangeable with newer technologies. For example, the Apache web server can be swapped out for Nginx, MySQL can be replaced by PostgreSQL or Mongo, and PHP can be replaced by Python or Perl. Python Django is a stack which uses the Python high-level object-oriented programming language, the Django web framework, the MySQL database or PostgreSQL database, and the Apache HTTP web server. The Python Django stack is popular because Python is relatively easy to learn to program, and a lot of developers know how to use it. Python Django also offers an MTV or model template view architecture, and because of this, it becomes easy and quick to prototype complex database-driven web applications. Django is built to reuse code and use existing plugins so that web applications can be developed with minimal new code. Django officially supports MySQL, PostgreSQL, and Oracle as the database technologies. Django is commonly deployed with the Apache HTTP server and the Nginx server for serving static files. The Mean stack uses the NoSQL Mongo database, the Express Node.js backend framework, AngularJS for the front end, and Node.js for the application runtime. The Mean stack is different from Django and LAMP because it incorporates both a backend and front-end architecture with the inclusion of AngularJS. One advantage of the Mean stack is that it uses JavaScript on both the front end and back end so that the learning curve for the developers is reduced. The Mean stack has good overall performance due to the use of the Mongo database and Node.js with its asynchronous calls, as well as scalability and flexibility in applications that can be prototyped quickly, is one of the main advantages of using the Mean stack. It also runs very well in the cloud, and because of this, it's one of the reasons why the Mean stack is quickly overtaking the LAMP stack in terms of popularity in recent years. The MERN stack is similar to the Mean stack, except that it uses React Redux on the front end instead of Angular. Generally speaking, the main difference between doing a project with the Mean stack or the MERN stack is the preference of using Angular or React for the front-end framework. The difference between Angular and React is that Angular is a MVVM or Model View View Model framework with more structure and less flexibility than React, which is a JavaScript library. React, on the other hand, is easier to learn and provides better performance than Angular due to its virtual DOM, but also it's less structured and developers have to make more of their own decisions with the architecture of the In this video, I'll identify factors influencing which full-stack technology option is best for your business. Choosing the right technology stack for a full-stack application is crucial in determining the success of the application and the type of developers needed to be hired in order to build an application. There are various things to consider when making a decision on which full-stack technology to use. These include project size, performance requirements, time to market, scalability, team member expertise, user requirements, backend server constraints, front-end framework constraints, and the type of data stored in the database. There is often more than one technology stack which can work with a project. For example, a large project can be completed with Angular and Node.js, Python and Django, or Ruby on Rails. Oftentimes, the end client doesn't have a preference which stack is used as long as their application gets completed on time, on budget, and performs as expected. We'll start by taking a look at some front-end components for the technology stack. As I mentioned previously, the front end uses technologies such as HTML, JavaScript, CSS, jQuery, and Ajax. These days, a front-end framework is a necessity with any full-stack applications in order to speed up the development and better organize functionality. If we are to look at the stacks that support a front-end framework, we would easily see that the Mean and Mern stacks both offer front-end solutions by offering either Angular in the case of Mean, or React in the case of the Mern stack. Another advantage of using the Mean or Mern stack is that they have both their front-end and back-end code written in JavaScript, so a single developer can work on both. The Python, Django, and Lamp stacks are back-end stacks, however they can also incorporate Angular or React on the front-end, however the integration isn't as seamless as with the Mean or Mern stacks. Another disadvantage is that in the case of Python, Django, or the Lamp stacks, there need to be multiple programming languages used, potentially raising development time and developer costs, because we would have to use either Python or PHP for the backend and then JavaScript for the front end. In terms of picking a stack based on backend requirements, things like the operating system it runs on, type of data stored in the database, and web server performance requirements come into play. For example, if you want to build a scalable application which will store and process large quantities of unstructured data in the cloud, either the Mern or the Mean stack would be best, as Node.js is very well built for scalable applications in the cloud, and the Mongo database is good for storing and processing large sets of unstructured data. If, for example, your web app needs to access and query a legacy MySQL database and run on the Apache web server in a Linux operating system environment, the Lamp stack may be best, as it would be able to achieve these goals. Small, minimum viable prototype or MVP applications are best designed with Python, Django, or the Mean stack, as these stacks enable the quickest development and time to market for a smaller application. Larger applications often combine components from various stacks in order to get the best performance, reliability, and scalability. For example, Facebook has a PHP backend, a Cassandra NoSQL database, and a React frontend, and a Linux and Apache web server. As I mentioned in the previous video, the four major full-stack development stacks are the Mean, Mern, Python, Django, and Lamp stacks. Smaller and mid-sized applications may stick to one stack entirely. However, for large applications, mixing and matching of stacks often provides the best performance. For example, eBay uses a Node.js backend with both Oracle SQL databases and NoSQL Hadoop and Cassandra databases for storing and processing less structured big data. They also use the Apache Tomcat web server and the Marco JavaScript UI library. A mid-size or smaller applications would be a good candidate for the Mean or Mern stack. One of the main decisions on which technology stack to use lies with the experience of the developers working on your team or the ones you plan to hire. As I mentioned, the perfect technology stack is different for any given project. Some of the factors which influence which technology stack to choose includes the project type and size, time to market, scalability, and cost of development. For a smaller project, it would be easier to use a full stack framework such as Mean or Mern, and even Python Django would work in order to reduce the development time, and most developers are actually familiar with either Python or JavaScript, so that's why these frameworks may be a good choice. For very small projects, a CMS builder such as WordPress or Joomla may suffice in order to get a prototype out quickly if you just need a landing page, for example. For applications which interact with legacy databases or applications primarily meant to run on the Apache web server in Linux, the Lamp stack would be the best option. Time to market basically means how long an application takes to get out to the end client. The technology stack affects time to market because things such as the availability of plugins, reusable components, as well as integration between components of the front end and the back end all affect the timeline to release a product. Another aspect of time to market is developer knowledge. If the development team is familiar with a certain stack, their time to market will be reduced. Finally, proper documentation plays a role in time to market as it helps shorten the developer learning curve. Both Django and PHP are examples of technologies with good documentation. Scalability is another thing to look at when starting a project. An application can scale either vertically or horizontally. A vertically scaled application can increase performance by adding resources such as memory, disk, storage, and CPUs. This is typical for legacy LAMP stack type applications. A horizontally scaling application increases performance by adding more machines or clusters in the case of a cloud deployment. Modern web applications are often written using the mean stack, as Node.js has proven to be a very scalable web application framework. Finally, cost of development is a factor to consider as well. One side of this is the cost of actually using the stack. For the most part, all popular stacks use open source software and are free to use, so that's usually not an issue. Where the costs come in is the developer salaries. Different programming languages command different salaries. With Ruby development, for example, the cost is the most per hour and PHP is the least, and Python and JavaScript are somewhere in the middle. The other thing to consider is how many developers are actually available. Ruby developers command a high salary because there aren't nearly as many of them available compared to JavaScript or Python developers. Overall, the best decision lies in the intersection between developer salaries and developer availability. In this exercise, you will describe FSD methodology basics, describe Agile methodology fundamentals, compare the Waterfall and Agile methodologies, describe the pros and cons of the FSD methodology, describe some common FSD technology stacks, and determine the best technology stack for your project. Now pause the video and perform the exercise, and I'll get back to you with my solution. A full-stack developer specializes in several different concepts. Specifically in web development, a full-stack developer is a person who specializes both in the server-side backend code as well as the client-side front-end code. An application front-end is built using JavaScript, HTML, CSS, jQuery, and Ajax. There are several JavaScript frameworks such as React, Angular, and Vue.js, which speed up the development of the front end. There are also frameworks for CSS such as Bootstrap to get a uniform user interface across different device types. Backend development deals with the server-side code, databases, APIs, and data creation, updating, and management tasks of a web application. Languages and frameworks are what the backend server-side code is written in. Examples of these include Python in the Django framework and Ruby on Rails and JavaScript with Node.js. APIs specify how various components of an application or various applications should interact. A popular example of a HTTP-based web API is the REST API, or Representational State Transfer. With the REST API, an application can send requests such as GET, PUT, and POST to other web services using HTTP in order to establish communication between applications. Databases are used to store data. The two types of database systems are relational, like MySQL and PostgreSQL, and non-relational, like Mongo. Relational databases store data in tables with rows and columns, while non-relational databases store data in collections of documents. Agile software development is a methodology for managing software development projects and teams. The Agile Manifesto has 4 core pillars or values for improving the software development process, and these are individuals and interactions over processes and tools, working software over detailed documentation, customer collaboration, and embracing and responding to change. There are 12 Agile principles which follow the manifesto values and which also explain in more detail how Agile operates at the ground level. These are continuous delivery, frequent delivery, prepare for change, collaboration, motivated team members, face-to-face interactions, working software, velocity, attention to detail, simplicity, self-organizing teams, and continuous improvement. Agile methodologies are the actual ways that Agile can implement to support the values and principles of Agile. Some popular Agile methodologies include Scrum, Kanban, XP, Crystal, RUP, and FDD. Unlike Agile software development, where software is developed in increments, the more traditional Waterfall method follows a sequential design process. There are 5 basic phases to the Waterfall method, and these are requirements, design, implementation, testing, or verification and maintenance. There are several advantages to using waterfall processes over Agile, including ease of project management, better for projects with simple defined requirements, and quick delivery time. Downsides of using the waterfall method include more difficult to change requirements and more potential testing costs. Agile follows an iterative process where each feature is developed and tested in a block of time, and requirements are more flexible to be reworked during development. Advantages of Agile include having the client in the loop, self-organizing teams, and lower testing costs. Disadvantages to Agile include higher startup costs, longer development for simple projects, and higher experience levels required by the development team. In web development, a full-stack developer is a person who specializes both in the server-side backend code as well as the client-side front-end code. Front-end components include front-end frameworks such as React, Angular, and Vue.js, HTML, CSS, and CSS frameworks such as Bootstrap, JavaScript, jQuery, Ajax, user interface design, and user experience design. There are several components to backend development. These include languages and frameworks, databases, server management, APIs, and operating systems. Examples of these are the Linux operating system, REST and SOAP APIs, Node.js and Express, Python, Django programming languages, SQL Server and Mongo databases, and the Apache web server. The Agile model works well with complex full-stack projects or projects where the customer has loosely defined and constantly changing requirements. It doesn't work as well in projects with simple, well-defined requirements or in the case that the end customer doesn't want to provide continuous input on development processes. Picking a technology stack depends on the type of application being built. Various technology stacks better suit different applications in order to gain optimal performance. LAMP is one of the legacy technology stacks and is the most popular backend stack used across web application. It stands for the Linux OS, Apache web server, MySQL relational database, and the PHP programming language. Some of the components of the LAMP stack are interchangeable with newer technologies. For example, PHP can be switched with Python or Perl. Python Django is a stack which uses the Python high-level, object-oriented programming language, the Django web framework, and the MySQL or PostgreSQL database and the Apache HTTP web server. The main stack uses the NoSQL Mongo database, the Express Node.js backend framework, AngularJS for the front end, and Node.js for the application runtime. It offers a JavaScript everywhere approach and its good performance and scalability due to the Node.js backend. The MERN stack is similar to the mean stack except that it uses React Redux frontend instead of an Angular frontend. The choice between the mean stack and the MERN stack generally lies with the developer preference for using Angular or React. Choosing the right technology stack for a full-stack application is crucial in determining the success of the application and the type of developers you need to hire in order to build an application. A modern-day full-stack application in most cases needs to incorporate a front-end framework. In terms of true full-stack technology stacks, the mean and MERN stacks both offer either Angular or React front-end JavaScript frameworks. The Python, Django, and LAMP stacks could be incorporated with a front-end framework. However, they're primarily back-end stacks, and the integration for Python, Django, and the LAMP stacks for a front-end framework isn't as seamless as with the mean or MERN stacks. In terms of picking a stack based on backend requirements, things like the operating system it runs on, type of data stored in the database, and performance requirements all come into play. Node.js is very well built for scalable apps, and the Mongo database is good for storing and processing large sets of unstructured data. For Apache, Linux, and MySQL applications, the LAMP stack is best. Python, Django, or the mean stack is good for prototyping small applications, and many larger applications like Facebook use a mix of stacks to get the best performance. The four major full-stack development stacks are the mean, MERN, Python, Django, and LAMP stacks. Smaller and mid-sized applications may stick to one stack entirely. However, for larger applications, mixing and matching of stacks often provides the best performance. As I mentioned, the perfect technology stack is different for any given project. Some of the factors which influence which technology stack to choose may include project type and size, time to market, scalability, and cost of development.
In this video, we'll consider front-end languages and frameworks. Full stack refers to a hybrid combination of front and back-end development. Front-end frameworks are the visual aspects of a web app, while the back-end refers to the plumbing, the what's under the hood components. For example, databases. What we have here are some of the most popular JavaScript front-end frameworks. They include Ember, Backbone, React Angular, and Vue.js. They all offer something similar, but they all have their own unique selling points as well. And we'll be covering these more as we go along in this course. CSS front-end frameworks typically use a responsive CSS to ensure that a web app looks great on virtually any platform. The attraction of these frameworks is that they provide a consistent UI experience and save time that would otherwise be required to do it yourself. Bootstrap, for example, is an open source toolkit for developing responsive apps with HTML, CSS, and JavaScript. Foundation by Zurb is a series of responsive front-end frameworks for developing responsive apps with HTML, CSS, and JavaScript again. Semantic UI is another development framework that helps create responsive layouts using more people-friendly HTML. Pure is a set of small responsive CSS modules. It's focused on minimal footprint with beautiful UI components. And UIKit is another lightweight framework, a lot like Bootstrap and Foundation, where you build UI components with reusable classes. It is very simple by design. That's its forte. Now, considering the mobile frameworks, Node.js. Node.js is an asynchronous, event-driven JavaScript runtime with many thousands of packages and is commonly used for running server-side JavaScript as well. It works with tools like Express. Express is a minimal and flexible Node.js web app framework. It offers a proven set of features for web and mobile apps. Happy.js is another minimal and flexible Node.js web app framework for building web apps, APIs, and services, while Sails.js is a popular MVC framework for Node.js. Building an app on Sails means building entirely in JavaScript. Sails is also front-end agnostic. Continuing on with mobile frameworks, PhoneGap. PhoneGap is an open source distribution of Adobe's Cordova framework. You build hybrid applications with HTML, CSS, and JavaScript, supporting multiple platforms with a single code base. PhoneGap claims to get to mobile quicker than Cordova. And Cordova supports mobile apps with HTML, CSS, and JavaScript. It targets multiple platforms, again, with one code base, and it's free and open source. React Native lets you build mobile apps using only JavaScript. It uses the same design as React, letting you compose a rich mobile user interface using declarative components. Meteor uses the same code base across platforms for web, iOS, Android, or desktop. Now, you have multiple deployment options, and this is not a comprehensive list. Nevertheless, here's the list. So first, DigitalOcean. DigitalOcean is a platform as a service and also works with containers and Kubernetes clusters. Amazon Web Services offers another option to DigitalOcean and others, and is a comprehensive solution. Heroku is a cloud platform as a service for quickly deploying web apps. So you deploy your web apps on these platforms. Some other linked technologies include Apache Subversion. It's an open source software versioning and revision control system. NPM is Node Package Manager. It's used for managing Node.js packages. Babel is a JavaScript compiler. Babel is essentially a toolchain that is typically used to convert ECMAScript 2015 Plus into a backward-compatible version of JavaScript. Bitbucket offers Git code management and offers the ability to plan projects, collaborate, test, and deploy all in one place. Yarn is supported by Facebook, Google, and others, and is basically a JavaScript package manager, and it's an alternative to Node Package Manager. In fact, it was developed to address some issues that were seen with Node Package Manager, or NPM, namely installation performance and security issues. And Webpack is a static module bundler for modern JavaScript applications. In this video, we'll consider JavaScript front-end frameworks. These front-end frameworks, React, Angular, Ember, Vue.js, and Backbone.js, are some of the most popular JavaScript front-end frameworks for building the visual aspects of a web app. Let's take a look at some of the details of each. First, React. React is supported by Facebook, and as the name implies, it's a reactive framework that propagates data changes to front-end components. Therefore, it's a component-based architecture. React uses a JavaScript superset, JSX, for components. JSX stands for JS-XML and is essentially an XML, HTML-like extension to JavaScript. React uses the Redux library to manage and communicate with components, and a React component has state and props special objects because a React component is a stateful component. Input data is accessed via props, and the component maintains internal state data via state. When state data associated with a component changes, the rendered markup is updated. It keeps state out of the DOM. React is one of the most powerful and popular JavaScript front-end frameworks for creating advanced user interfaces. Angular is supported by Google and is a little bit of a special case. AngularJS, which is Angular 1.x versions, were MVC apps and competed with Backbone, but became less special and lost some ground to React. So we're focusing on the present and future, and that means Angular 2+. Angular 2+ utilizes a component-based architecture. So the app you're building is broken up into components that themselves have child or nested components. Angular uses TypeScript, CoffeeScript, and other languages. Components use services, which provide specific functionality not directly related to views. Service providers can be injected into components as dependencies, and this makes code more modular, reusable, and efficient. And attribute directives change the appearance or behavior of a DOM element. Vue.js is similar to Angular and React, borrowing some concepts from both. Like Angular, Vue.js has HTML attribute directives, but they are much simpler than Angular's. It's a component-based architecture, and one of the major differences between Vue.js, React, and Angular is that with Vue.js, you don't use a JavaScript superset like JSX for React or TypeScript for Angular. It uses JavaScript for components. Vuex is Vue's library for managing state and communicating with components. It's similar to React's Flux. And state and props are also present, similar again to React. Ember is a component-based architecture. It's a JavaScript front-end using a pseudo MVC framework, pseudo in that the C controller is replaced with other components. It uses the Handlebars templating engine for DOM manipulation, and Ember.js uses the Ember object class, which extends JavaScript objects to provide the core framework functionality. Ember objects can be watched for changes. Backbone is what's considered a model view whatever framework. Backbone View listens for changes and renders the UI. The Backbone model coordinates data and business logic. A collection helps with the management of groups or collections of related models. Backbone events give objects the ability to bind and trigger events. Backbone Router includes methods for routing and connecting client-side packages to actions and events. And for API integration, Backbone comes pre-configured to sync with a RESTful API. In this video, we'll look at CSS frameworks. Bootstrap, Foundation by Zurb, Semantic UI, Pure by Yahoo, and UIKit by UTheme. These are some of the most popular CSS front-end frameworks, each with relative strengths and weaknesses. These frameworks allow us to provide a consistent UI experience and save time that would otherwise be required to do it yourself. Many of these frameworks are modular, which means that you can deploy and use only the components that you actually require. Let's look at some detail about each. First, Bootstrap. Bootstrap offers responsive CSS for responsive web design. It's mobile first, which really means that the priority is mobile when hard decisions need to be made about content. Bootstrap provides a Sass preprocessor to convert Sass to CSS, and Bootstrap has been around since 2011. It's tremendously popular, and with that enjoys a large user community and support. Foundation by Zurb is another responsive CSS framework. It offers a number of unique components like icon bar, flex video, pricing tables, to mention a few. It includes the Foundation icon fonts for an icon set, and Foundation also provides a GUI customizer that allows one to pick and choose the features to use. Semantic UI is another responsive CSS framework. It uses natural language principles in an effort to make the code underpinning web apps more people-friendly, that is, readable and easily understood by humans. It includes the Font Awesome icon set, and it also provides a number of unique components such as divider, flag card, and others. Pure by Yahoo is another responsive CSS framework. It offers a modular framework, and it's very lightweight. It's focused on minimal footprint. It doesn't have a specific font set, but you can use Font Awesome icon set with Pure. Pure offers basic GUI customization, so you can choose, again, those modules that you absolutely need. And UIKit by UTheme. This is another responsive CSS framework with customizable components. It is mobile first. It offers less and Sass preprocessors and comes with a native SVG icon system and library. In this video, we'll create an Angular project. I've opened my browser and I've navigated to angular.io. Locate Get Started and click on it. And in the left menu, you have access to all the information about using Angular. You want to click on Setup in the left menu. And Setup describes how to set up a local environment and a workspace. So you've got prerequisites, which includes Node.js. Then you install the Angular CLI, create a workspace and initial app, and then run the app. Now, with prerequisites in mind, Node.js. Go to nodejs.org, download the latest LTS version. That's what I typically use, is the LTS version, unless I'm working on something that absolutely requires some feature in the current release. But for our intents and purposes, the LTS version is the best one to use. Now I'm including Git here. That's at git-scm.com. Now it's not technically a prerequisite. However, when you create a workspace with Angular, it not only generates a new application skeleton, but it also initiates a Git repository. Now you can tell it not to, but I like to work with Git anyway, so I'm suggesting that you may want to consider installing Git. Okay, recall in setup, I indicated that Node.js was a prerequisite. And we use npm to install the Angular CLI. So let's go and do that. So I'm going to click Visual Studio Code on my taskbar to start Visual Studio Code. I'll close the welcome page. Now I'll open Terminal with a quick Control backtick. And I'm at my PowerShell prompt. And to install it, I type npm install -g @angular/CLI. All right, now that that's done, clear the screen by typing CLS and pressing enter. So now you can create a new Angular application by typing ng new. So ng new and the name. I'm going to call this ANG app, and I'll press enter. Would you like to add Angular routing? I'm going to say yes here, so I'll type Y and press enter. And the style sheet format will just use CSS, so I'll just press enter with CSS highlighted. However, notice you've got SCSS, Sass, Bless, as well as Stylus. So I'll just choose CSS and press enter. So now Angular creates the workspace folder, generates a new application skeleton, and we'll go and have a look at that. In fact, right now, if I go over to Explorer in Visual Studio Code and expand project, I'll see that I now have my ANG app workspace folder. Expanding that shows a number of subfolders and files. And now the project has completed. And you'll see the last line successfully initialized Git. Okay, so now let's clear the screen. And now at this point, we're ready to start working with our application. I'm going to start the development server with the application. So I'll cd into my working directory, my workspace. I'll clear the screen. And now I'll type ng serve. And that starts the development server with my app running. All right, and now a live development server is listening, and it listens on port 4200. So I need to go to localhost port 4200. So over to my browser, click to open a new tab, and I'll paste that URL in, and here's my Angular app. All right, now I'm going to dock this on the right-hand side, and I'm going to select Visual Studio Code for the left side. I'm going to expand my code working area. And now, under the SRC directory, so expand SRC, expand app, and locate app.component.ts. And click on it to open it in the editor. Now it's open in the editor. You can see in the tab that it's in italics font, which means it's not open until you actually do something. If you double click, that will open it directly. Okay, so now it is fully open. Now in the class app component, I've got a property title, and it's ANG app. And you can see that in the application on the page, ANG app. Well, I'm going to change that and demonstrate how we work with this. So I'm going to specify my Angular app for my title. Now, when I press Control S, keep your eye on the right side on the browser, and it updates dynamically. Okay, so that's a quick look at creating an Angular project. In this video, we'll generate a React app. I've opened my browser and I've navigated to reactjs.org. This is the homepage for React. I'll click on Get Started, and on the Getting Started page, I can quickly see that there are several ways that I can work with React. I can use sandbox sites. I have an HTML file that I can download and start working on directly. And there are other options as well. To get started really quickly, I'm going to use the npx utility, and that's Node's package runner tool, and it can generate the React app for us. Now, obviously, because we're using npx, that means we have Node, right? So clicking on the Node tab, I'm at nodejs.org, and I can download the current or LTS version. So I would download and use the LTS version, typically. I've already got that installed, so I won't do it again. But I'm going to go over to Visual Studio Code. So on the taskbar, I'll click Visual Studio Code, I'll close the welcome page. And a quick control backtick opens the PowerShell terminal. I'm going to make that a little bit larger. Okay, and now I'll clear the screen. CLS, press enter. The npx utility can call create-react-app to create the app for us. Keep in mind now you cannot use capital letters for React app names. So I type npx create-react-app my app. That's the name of my app. Press enter. And npx is installing React, React DOM, the scripts that we need. Created a new folder under project called my app. All right, that completed. And we have some success messages and some hints on how to get started. npm start to start the development server, npm run build, npm test, and so on. So now let's make that terminal a little bit smaller again. So let's go up in Explorer and expand my app. There are a number of node modules that it installed. Several, in fact. And from here we can access our code in Explorer. Now, app.js, that is the entry point for our application. This is the default app. And in this file, if we make changes and then save it, then the app will be reloaded. So let's go and try that. First, down in the terminal, CLS, and now cd into my app and npm start. All right, there we are. Now, if we go back to Visual Studio Code and we modify app.js, and press Control S, that will reload. And now if we go back to the browser, we'll see that it now says Master React. All right, so that's how to get started working with React by creating a React app. In this video, we'll create a Vue.js project. I have opened my browser and navigated to Vue.js.org, the homepage for Vue.js. Locate Get Started and click on Get Started. That brings us to version 2 guide. If I scroll down in the left pane, under Essentials, click Installation. And now some compatibility and release notes, as well as some news on Vue DevTools. And we can quickly see that there are several ways that we can work with Vue.js. We can simply download and include it within a script tag. We can use Vue's official CLI. We also have Node Package Manager. We can install Vue that way. And for our purposes, we're going to include the CDN, particularly the prototyping CDN. Okay, on the taskbar, I'll click Visual Studio Code. I've got Visual Studio Code open with my project. Now my project is in a folder called Vue App. I've got 3 files, an index.css, .html, and .js file. So what are we doing in all of these? First, let's look at index.html. In the index.html, we're referencing the CDN within script tags. And again, the CDN is good for prototyping. Inside the div tag named ID, I have my app defined. And just before the closing body tag, we also reference index.js inside script tags. This is where we write our app. So Vue.js simply allows you to declaratively render data to the DOM, and the templating syntax is pretty straightforward. Okay, let's go and take a look at index.js. Okay, and first we create a new instance by declaring new Vue in line 2. And when a Vue instance is created, it adds all the properties found in its data object to Vue's reactivity system. When any of these properties change value, the Vue will react and update to match the new values. In other words, Vue will re-render that component, node, or element. So here our app has one data object with one key, and that's message. And the message currently is hello. In essence, what's going on here is that the data for this element in the DOM is linked to the data in index.js here. So if we change the value of the property, then the DOM is updated accordingly. And this is the reactive behavior of Vue.js. Okay, in Visual Studio Explorer, I'll right-click on index.html and select Open in Default Browser. And there you can see hello is rendered as expected. Okay, I'm going to dock the browser window on the right side, and I'm going to select Visual Studio Code for the left side. So what do you suppose will happen if we change any of the values in the data object? Okay, well, outside the definition on line 9, I've got app.message equals goodbye. So I'm changing the value of that key. So if I uncomment that, press Ctrl S to save my changes and refresh, then I'll see the new message is rendered. All right, so that's a quick look at how to create a Vue.js project. In this video, I'll configure Bootstrap in a project. To get started, I've opened a browser. I've opened Node.js website, that's nodejs.org. You should likely download the LTS version if you're going to follow along, and right now that's 10.16.0. I'm also using Express.js, and that's just expressjs.com. In the top menu, hover over Getting Started and navigate to Express Generator and click on that. And that tells you how to quickly get an application skeleton up using Express Generator and the npx utility from Node. So you'll need Node greater than 8.2. And of course, on the Bootstrap tab, Bootstrap. Clicking Download on the Bootstrap page opens the download page. There's compiled CSS and JavaScript. There's the source files in case you're going to build your own. There's the Bootstrap CDN, and that's what we'll be using in this demo. There are also other ways that you can download Bootstrap. Okay, so we're going to use the CDNs. Over to the taskbar, I've got Visual Studio Code open, and I've started a terminal in Visual Studio Code, and I'm sitting at C:\project. Now I've got no project here at the moment. And to get started, what I'm going to do is I'm going to use npx express generator to generate an app. So I'll type npx express-generator, and I'll specify the name my app. Press enter. Okay, so the app's been created. The directions tell us to cd into my app and install the dependencies, so that's what we'll do. And then when we want to start it, we'll just type npm start. Okay, so cd my app and then npm I, or install. I'll just use I for install. You can ignore the deprecation warnings. Okay, and now that's done. So let's type npm start. Okay, and the server starts, so we should have an application running on port 3000, the default port for Express. So let's go back to the browser. So on the taskbar, click the Firefox browser icon. Let's go to the tab where it says Problem Loading Page. Because the server wasn't running before, I was unable to connect. So now I'll refresh. And I have a pretty simple front page. All right, back to Visual Studio Code. And I'll press Control-C in the terminal, and Y to terminate the batch job, and that closes the app down. Now I'll type CLS and press enter to clear the screen. And going forward, I won't keep saying I'm going to clear by typing CLS and pressing enter. I'll just type CLS and press enter. Okay, so first I'm going to get rid of the My App directory because I don't want to use that app. I've got another version of My App in which I've created a couple of extra templates and modified the templates heavily to use Bootstrap. So let's go and have a look at that. I'll back up one directory and I'll type rmdir myapp, press enter, and I'll type A, and that's yes to all. I want to clear everything. Now if I do an ls, which is an alias for dir, I'll see that I don't have any folder named myapp any longer. I have myapp.zip, which is my archived version of myapp. So on the taskbar, click File Explorer, right-click myapp.zip, click Extract All, and I'm extracting it to C:project myapp. Click Extract. Okay, and it's done. So now let's go back to Visual Studio Code, expand myapp, and the views, and now I've got a footer, header, index, layout. And the footer and header, I've added index and layout, I've modified heavily. First, let's look at layout. So I'll click to open it in the editor. And on line 10, that's my Bootstrap CDN reference to the minified Bootstrap CSS. Then lines 12, 13, and 14 reference the minified JavaScript that's required with this version of Bootstrap. In index.jade, this is my template. I'm using a number of different elements, including Jumbotron here, from Bootstrap. In fact, all of these elements are directly from Bootstrap. Header, same thing, only this time I'm using the navbar element to create a navigation bar at the top of the window and a simple footer. All right, down in the terminal, I'm going to cd into my app. Then I'm going to install dependencies. So npm I, and done. Now, one last thing. To start my app, I've modified the package.json file to have watch under my scripts. So I'm going to type npm run watch, and that uses nodemon to start the server, and it will restart it every time a file changes. So now I type npm run watch, press enter. Now the app is running, so if I go back over to the browser, refresh, there's a vastly different looking front page. I've got a nav bar at the top. I've got search capabilities, some buttons, the Jumbotron, and a row of columns, as well as my footer. Because we're using Bootstrap, it's a consistent experience for the user. Okay, so that's how to configure Bootstrap in a project. In this video, we'll configure Foundation in a project. I've opened a browser and I've navigated to foundation.zurb.com. On the Foundation homepage, click Download Foundation. Okay, and that gives us several options from complete, and there are other options as well. And scrolling down, even a customize function where you can pick and choose what you want and then download the custom build. That's one way to work with Foundation. The other way is to take advantage of the command line and install the Foundation CLI. We can use the Foundation CLI along with Git, Node, and Gulp, and some additional Node packages to generate a build process, essentially an automated Gulp workflow. and it's very simple and easy. Before you get started, prerequisite is Node.js. That's at nodejs.org. You should probably choose the LTS version. And Git, that's at git-scm.com. Get the latest source release for Git, install it. Okay, let's open Visual Studio Code now, and we'll open the terminal in Visual Studio Code. On the taskbar, I'll click the Visual Studio Code icon. I'll close the welcome page, and I'm in the project folder by default. That's where I typically work. Now, open a new terminal in Visual Studio Code by pressing Control backtick, and I'm going to make my terminal a little bit bigger. And now, at this point, I type npm install global foundation-CLI. Press enter, and you can ignore any deprecation warnings. Okay, and once it's done, now you have the option to create a new website framework. We're going to work with the basic template, and again, it actually comes with an automated gulp workflow. So we'll take a quick look at that after we install it. So first I'll clear the screen by typing CLS and pressing enter, and now install a site using the basic template. I type foundation new -- framework sites -- template basic. Press enter, and now when it asks for the project name, I'll specify my FDN app. And now the CLI goes off and downloads the project template, installs dependencies, and sets everything up for us. Okay, excellent. So that finished. All the dependencies were installed. I'll just make the terminal a little larger, and you can scroll up and you can see many of the Node packages that were installed. Gulp to browser sync and so on. With that, we now have a project that we can work with. So I'm going to clear the screen again, typing CLS and pressing enter. Now inside my project folder, the root of my project, I can type foundation watch. So cd my FDN app and foundation watch. Press enter. Okay, so it set everything up and it launched browser sync to synchronize the site, and that's why the browser popped up like that. So welcome to Foundation. Now if I go back over to Visual Studio Code, so I'll click Visual Studio Code on the taskbar, the watch process reports that a gulp workflow started, SAS was compiled into CSS, the server was started, and browser sync was started. And now any SAS files that I change, and they're located in the SCSS directory, once I save those changes, that will kick off a new SAS compile process. Essentially, the gulp process will run through each time that happens. And now at this point, we have a little gulp process. It's nothing spectacular. I'm just going to open the gulp file. I'll make the terminal smaller again. Okay, so in gulp, basically what we're doing is we're compiling SAS and starting the server, and then using gulp watch. So it's that simple. It's a nice little process. Okay, so now at this point, we also have an index.html file. And again, if we go and make any changes in the SCSS folder, so let's go to the app.scss file, double click to open it. Okay, locate grids, and I'm going to uncomment line 14. Now, watch the terminal as I press Control S to save. Okay, and it kicked off that build process again. So you can see that it recompiled the SAS. Now let's go see the result of the change that we just made. Okay, and you can see that this is kind of jumbled up a little bit. So that's not a good change. Let's go back to Visual Studio Code. And why did that happen? Because we're only supposed to choose one type of grid. So I'm going to recomment that out. Now, the build process will start again if I press Control S to save, and the SAS compile happens again. So let's go and take a look at the browser and see that it now looks fine again. Okay, so that's how to configure Foundation in a project. In this video, we'll consider the concept of responsive web design. An effective responsive design displays equally well on any platform from desktop to tablet to mobile device. There are three considerations that we need to make in order for this to work. 1. The responsive design, that is the way the page should appear for each layout, should be considered and created in mockups. 2. The CSS rules that will implement each layout need to be considered. And 3, the media queries to apply those CSS rules need to be created. Best practice means we separate content from presentation, and that's the essence of HTML and CSS. The HTML defines the structure of the document. The presentation and appearance are handled separately in CSS. In Visual Studio Code, I have 4 files open: index.html in the design folder and styles.css in the design folder. These two are related and work together. The index.html is a very simple blank HTML document. In other words, there's nothing in the body content. And styles.css, here I'm using media queries to implement my responsive design. Lines 10 through 14 implement the mobile only, and this has a media query that uses only screen as the media type, and the media feature is the max width of 360 pixels, and the background color is green. From lines 17 through 21, that implements the tablet, and 24 through 28, that's the desktop. Let's see how this works. So over in index.html, I'll right-click the tab, select Open in Default Browser, and it opens in the mobile view. So there's less than 360 pixels of width here. As I resize, however, so I'll drag the window to the right. As I resize, once it surpasses 360 pixels, watch the color change to pink. And there it is. So this is the tablet layout. Now the tablet layout is good up to and including 800 pixels. Once I surpass 800, then that's the desktop screen layout, and the background will turn blue here. And there it goes. All right, and that's simply implemented using these 3 media queries. Okay, the other 2 files on the right, index.html in my responsive app folder and styles.css in my responsive app folder. These are vastly different. So in the index.html file here in the document, I've got a new value in the meta tags on line 5, and then I set up some sections: page to menu, header, content, action, and 3 features. I've used the concept known as mobile first. In fact, it's considered best practice to begin with the mobile layout first, then work up to the full desktop version. Now, examining the styles.css file here, I've got a universal selector rule, which is there to reset margins and padding. Then I've got my base styles. My base styles are set up in such a way that they configure my mobile first. Scrolling down, all of these styles reflect my mobile content first, which means that the code here from lines 52 through 57, I can highlight and delete. They're not necessary. But I do, however, need to change my mobile first layout to accommodate tablet and then desktop screens. So for tablet, here I've considered that with my tablet layout, I want the feature and action sections to form a 2x2 grid. Then with the desktop layout, I don't want to allow the page to expand infinitely, so I give it a fixed width and I center it with an auto margin. I'm also using reordering because when I considered this layout, I want the action and content sections to appear after the features sections. So all of that with the desktop layout is happening on line 63 through to 83. Okay, let's see this in action. I'll right-click index.html, select Open in Default Browser, and there's my mobile first design. So each section comes one on top of the other. All right, now let's drag the window and make it larger so that we exceed 360 pixels and see that it changed the layout. So in fact, in this tablet layout, we have the action and 3 features as a 2x2 grid as we designed. Expanding further to get to the desktop, we have the features coming before action and content, again, as designed. Now, one other thing. First, I want to resize this window so we can look at the code. In index.html, note line 5. On line 5, I'm disabling viewport zooming. This is necessary because before responsive design became important, mobile devices had just the desktop layout to display the full web app. To accommodate, the entire desktop layout was zoomed out to the width of the screen, which allowed users to zoom in as required. What an ugly solution. And it also prevents mobile devices from using any mobile layout that you've designed. So we add this one element to the head of our HTML document to disable viewport zooming. In this video, we'll look at serverless integration using Firebase. Serverless computing is a cloud service. It's generally seen as consisting of 2 principal service models: Backend as a service and functions as a service. When we speak of Backend as a service, we think specific cloud services like file storage, data management, messaging, and so on. All the day-to-day operational tasks like upgrades, maintenance, security, and so on are all part of the service. Very convenient. Backend as a service offerings provide developers with methods and means to connect web and mobile applications with these cloud services using convenient APIs and SDKs. The management of the service is performed over a web-based interface, although many of these services also provide a CLI for performing many tasks. Functions as a service offers on-demand functionality. Essentially, customers are provided with a platform for developing, executing, and managing an application's functionality while not having to worry about the complex infrastructure. The servers or infrastructure are entirely abstracted away. Developers can leverage the service to generate functions, for example, an action or business logic that interacts with a number of backend as a service endpoints. Functions typically are triggered by events like a request arriving from a client app. Firebase is an example of one of the finer functions as a service offerings. Firebase offers Cloud Functions Service with an intuitive and easy-to-use web-based interface. Firebase is actually Google's comprehensive mobile development platform, so it benefits from Google's excellent infrastructure, including an excellent Firebase console for setting up Firebase projects and connecting apps. Overall, Firebase is easy to configure, and the intuitive interface is easy to use. Firebase uses a simple dashboard with analytics and access to real-time data, as well as multiple back-end services. Some Firebase features include authentication, real-time database, and hosting services. Users, for example, may be authenticated and managed without server-side code. Cloud Firestore is a real-time database that is managed and scaled automatically and offers powerful query capabilities. Firebase Real-Time is Firebase's original database. With hosting services, one can provision and deploy web and mobile web apps very quickly. We're talking on the order of seconds. Firebase Authentication provides services for authenticating users. The Firebase UI library is built on the Authentication SDK with simple drop-in UI auth flows. Firebase UI libraries include support for development frameworks like React Native, supporting iOS and Android. And various authentication methods offered include authentication from a number of identity providers like Facebook and Google, for example, and also includes email password, phone authentication, GitHub, and others. Firebase Real-Time and Cloud Firestore database offerings are NoSQL databases. They both store data using JSON objects or objects very similar to JSON objects. I'll focus on Firestore here though, since it is recommended by Firebase for most new projects. A document is Firestore's unit of storage, and Firebase guides say you can treat documents like lightweight JSON records, so a set of key value pairs. You organize documents inside collections, which you can think of as document containers. So you have data inside a document and a document inside a collection. Firestore also has expressive and powerful query capabilities for specifying which documents to retrieve from a collection or collection group. In this video, we'll consider container integration using Docker. We'll focus on Docker containers here, but other container runtime environments like Rocket and Mesos are becoming increasingly popular, so just something to be aware. A container is a logically packaged standard unit of software, complete with all necessary code and dependencies like libraries and software versions. This makes containerized applications run very quickly and reliably in a consistent environment, regardless of the actual computing environment the application is deployed on. Containers can be run almost anywhere, supporting, for example, Windows, Linux, and Mac operating systems, on virtual machines, in the cloud, almost anywhere. Containers offer logical isolation from other applications, offering developers a way to standardize the software as a logical unit. It might be instinctual to think of containers as virtual machines, but they are vastly different. One major distinction is that containers virtualize resources at the operating system level, whereas typical virtual machines virtualize hardware. Containers use certain Linux kernel features together to isolate processes from each other. These include namespaces. Namespaces limit what containers can access in the underlying Linux system. Examples include PID, networking, and mount namespaces. Control groups, or C groups, limit an application to a specific collection of resources, for example, limiting memory a container can access. Docker containers use Union file system. This is essentially a stackable file system. Each instruction in a Docker file adds a new layer to the container image. It's a lightweight and powerful construct, very fast and resource-friendly. With Union file system, duplication of complete file sets is avoided, and layers are segregated. When an image is changed, only the layer that was changed gets updated. All this adds up to make containers very fast and very efficient while maintaining process isolation. Such an important and powerful construct for developing, deploying, and maintaining applications. Now, some Docker advantages. Docker is just easy to use. Developers, sysadmins, and others can rapidly build and test portable applications, for example, on a laptop, and then deploy them as is on the cloud or even on bare metal. As I've mentioned already, Docker containers are fast, efficient, lightweight constructs that are easy on resources, particularly when compared to full-on virtual machines. Anyone or any organization using Docker can take full advantage of Docker Hub. This is a rich ecosystem that offers tens of thousands of predefined, publicly available Docker images. And another advantage is that using Docker images to break out an application's functionality into specific containers not only makes an application more modular, but Docker containers are highly scalable. Now, consider the Docker components. Docker runs on a layer called the Docker engine. The Docker client is what the end user uses to communicate with Docker. The Docker daemon is the component that executes commands for the Docker client. You use a Docker file to write the instructions for packaging up a Docker image. And the Docker image. An image is a sort of template that defines what a packaged application consists of along with its dependencies, and also defines what processes to run when it's launched. There are several continuous integration platforms supporting Docker. CodeShip, CircleCI, Worker, and Shippable are hosted continuous integration platforms. Some aspects of these services common to all of them include their simplicity, efficiency, speed, and image customization. Each has its own advantages and feature focus, but essentially they all make deploying and managing Docker containers fast, easy, and efficient. In this exercise, you'll practice what you learned about front-end languages and frameworks. You will identify front-end languages, identify front-end frameworks, describe responsive web design, describe serverless integration, and describe containerization services. Now pause the video and perform the exercise, and when you're finished, come back here for my solution. Okay, front-end languages. Simply JavaScript and CSS. That's what we're focused on. Now, front-end frameworks supporting JavaScript. We have Ember, Backbone.js, React, Angular, and Vue.js. For CSS, we have Bootstrap, Foundation by Zurb, Semantic UI, Pure by Yahoo, and UIKit by Utheme. For front-end frameworks supporting mobile, we have Node.js, Express, Happy.js, and Sales.js. We have Cordova, PhoneGap, React Native, and Meteor.js. Now, responsive web design. Responsive web design means a design that displays equally well on the desktop, tablet, and mobile, virtually any platform. There are three ingredients: a mockup, CSS rules, and media queries to apply the rules. When considering layouts with respect to responsive design, we need to be aware of two: fluid and fixed width. And best practice dictates mobile first, then work your way up. You should disable viewport zooming, and for desktop, you use fixed width and auto margin. You don't want to let it expand forever. Serverless integration is a cloud service. Service models include Backend as a service and functions as a service. Firebase is one of the finer functions as a service offerings. It offers cloud functions and is actually Google's comprehensive mobile development platform. It allows you to set up projects and connect apps. With Firebase, you have a management interface that provides analytics, access to real-time data, and backend services. Features offered by Firebase include authentication, real-time database, and hosting services. Container services consist of logical packaging of software, known as a standard unit of software. Container services offer apps a consistent environment to run in and can run almost anywhere. They also offer a powerful process isolation capability. Containers also use OS-level virtualization, which is markedly faster and more efficient than hardware virtualization. Kernel features enable process isolation, and this includes namespaces, control groups, and union file system. Now, Docker components. Docker runs on a layer called the Docker engine. The Docker client is what end users use to communicate with Docker. The Docker daemon is the component that executes commands for the Docker client. The Docker file is used to write the instructions for packaging up a Docker image. And an image is a sort of template that defines what a packaged application consists of, along with all its dependencies, and it also defines what process to run when launched. Now, Docker advantages. Docker is easy to use. so anyone can rapidly build and test portable applications and then deploy them on the cloud or even on bare metal. Docker containers are fast, efficient, lightweight constructs that are easy on resources, and particularly when compared to full-on virtual machines. Using Docker to break out an application's functionality into specific containers can make an application more modular and also make it totally scalable because Docker containers are very highly scalable. And Docker Hub is a rich ecosystem offering tens of thousands of predefined publicly available Docker images. Continuous integration platforms supporting Docker include CodeShip, CircleCI, Worker, and Shippable. Something common to all these services include their simplicity, efficiency, speed, and image customization. Each has its own advantages and feature focus, but essentially they all make deploying and managing Docker containers fast, easy, and efficient. In this video, we'll explore backend development languages and technologies. Node.js is a very common runtime environment for JavaScript. Node provides features that make it useful on both front and back-end development. Here, we're focusing on how to use it on the back end. Express, Koa, Happy frameworks, these are all JavaScript web application frameworks for Node. First, let's take a closer look at the Node framework. Some things that Node can do as a runtime environment include pre-processing on the server to generate dynamic page content, accessing files on the server. So that means creating, opening, reading, writing, deleting, and closing files. Node.js can be used to gather form data, and it can also be used to access databases for data management. Now, this is not a comprehensive or extensive list of the things that Node can do, but it gives you some idea. Express is a minimal and flexible Node.js web app framework that is built on the V8 JavaScript engine from Chrome. It offers a proven set of features for web and mobile apps. Express uses Node's createServer method to create an HTTP server object, and Express supports routing functionality handling GET, POST, PUT, HEAD, and DELETE HTTP request methods. Express is excellent for generating REST APIs. For example, one line of code mounts the router as middleware at the API path. Koa is another Node.js framework designed by the people responsible for Express. Not surprisingly, Koa uses Node's createServer method to create an HTTP server object. One of the differences between Koa and Express is that Koa uses ES6 generators for routing. When used in routing, and I'm including REST APIs, using ES6 generators allows Koa to leverage async functions, and this reduces the work required in handling callbacks and also improves error handling abilities. Happy.js is another minimal and flexible Node.js web application framework. Happy has its own server object that gets initialized when invoking Happy's server method. Happy supports routing functionality, handling GET, PUT, POST, HEAD, and DELETE HTTP request methods. It, like Express, is adept at generating APIs. To improve error handling, if a route not defined in the REST API is attempted, Happy returns a JSON object with error details. In this video, we'll look at Enterprise Service Bus. Enterprise Service Bus is a software architecture connecting all services together using a bus-like infrastructure. Typical uses of Enterprise Service Bus include as a transaction manager, as a security manager, as a proxy service, and as a gateway to the world. As a transaction manager, Enterprise Service Bus, or ESB, is capable of coordinating distributed transactions, communicating with multiple services, and rather than having the client coordinate transactions where multiple distributed services must participate, ESB takes care of that, but the client may still be required to demarcate the transaction's beginning and end. As a security manager, ESB can centralize authentication and authorization. ESB can securely manage LDAP access and the integration of third-party identity management, validate inbound requests with SAML 2.0 federated identity standards, and provide SFTP, or Secure File Transfer Protocol, over SSH. As a proxy service, ESB can forward messages to an endpoint without any processing. It can use web service security to process incoming requests as a secure proxy, use WSDL from an existing web service as a WSDL-based proxy, log all requests and responses as a logging proxy, and as a transformer proxy, transform incoming requests using Exalt transformations. As a gateway to the world, ESB can connect to other networks. It can also run services on other networks. It can coordinate and manage data communication and forward data packets to the gateway. In this video, we'll look at JavaScript Middleware Framework. A middleware framework is any software between an application and the network. It's an important layer of web application software that keeps everything connected and working together smoothly. It's essential for handling client-server connectivity, for managing requests and responses between client-server, for data integration, as well as error handling services. The application stack in our context flows from application to middleware to operating system and hardware. Koa.js is a JavaScript web application framework that provides some essential JavaScript middleware functionality. At the functional layer, it can smooth communication between application and network. At the abstract layer, it provides transparent functionality to an application. And since it standardizes development, new components can easily be added to middleware without having to tear it down and rebuild it. Node.js made JavaScript a front and back-end framework, so applications can use JavaScript entirely to build applications on the mean stack. So that includes the MongoDB database, Express.js web application framework, and Angular framework. These are all based on the Node.js development environment. Express and Node use callbacks, which can run synchronously or asynchronously, but for several reasons, callbacks are not optimal. With Koa, there are no more callbacks. Instead, Koa uses generators, giving Koa middleware async capabilities without the headaches of callbacks. Koa uses component building blocks using existing Node modules and is itself a module. Cascading middleware, such as Koa's, offers better stream handling than Node or Express, and Koa provides a built-in catch-all for better error handling capabilities than Node itself. In this video, we'll compare SOAP versus REST. First, let's look at what APIs consist of. API components include shared assets. These refer to virtually anything that an organization wants to share internally or externally, including, for example, software, services, and data. The API itself is another component, and it offers an entry point for consumers of the API and can act as a filter against those shared assets. Typical consumers of an API are not your normal end users, they're typically developers, creating software, services, or applications based on the shared assets. Overall, end users still are the ultimate beneficiaries since, for example, APIs enable the use of social profiles with third-party applications and provide the ability to access multiple applications between devices. One thing to keep in mind though, SOAP is actually a protocol. REST represents an architectural approach or style. Since REST APIs are based on HTTP protocols, they are relatively simple constructs. They can provide communication in a client-server capacity. They offer a single, consistent interface. They're web-optimized. And REST APIs provide performance and scalability that is pretty hard to match. SOAP APIs offer improved, tighter security than REST. Web service security and SSL support are built-in standards. Because of built-in successful retry logic, SOAP provides more reliable end-to-end functionality than REST. And SOAP is also ACID compliant, so it naturally can safeguard data integrity by defining exactly how a transaction may interact with the database. Now, features of REST API. REST API is an architectural style. APIs access a predefined resource for data and can accept HTML, XML, and JSON. REST APIs support HTTPS and SSL. And with the REST API, the API calls can be cached for performance improvement. SOAP API. First, SOAP is a protocol. And SOAP APIs are function-based. That is, the APIs perform some operation. SOAP APIs only use XML. However, SOAP supports web service security and SSL built in. However, API calls on SOAP cannot be cached. In this video, we'll compare SQL to NoSQL databases. Let's start with some SQL database advantages. First, they're accurate. Data is only stored once. Data is easy to modify or even delete, and tables linking to data show any change in that data. SQL databases provide flexible, powerful query capabilities. Typical relational databases easily support thousands and many thousands of concurrent users working simultaneously with the same data. They're trusted. Relational database technology is very mature, and SQL, structured query language, is a fairly expressive language, so it's well understood and it's supported by many, many thousands of developers. SQL databases are secure. In fact, with most relational database management systems, you can perform very fine-grained security control based on user, group, or even role. Popular SQL databases include MySQL. MySQL is the open source, very popular relational database developed by Oracle. Then Oracle has its own enterprise class relational database, very reliable, very secure, very fast. It supports both SQL and NoSQL. Microsoft SQL Server, which is Microsoft's mature, powerful, enterprise class relational database. It also supports both SQL and NoSQL. And Azure. Azure Relational Database is a cloud-based relational database, and all the other big cloud providers have their own incarnation of the same. And then there's IBM DB2. This is another enterprise class relational database, well known for handling big data and analytics. Now let's consider types of NoSQL databases. First, key value store. This type of NoSQL database sees data stored in a schemaless manner. The data consists of keys and values with the keys indexed. Column store, also referred to as wide column store, has data tables that are stored as columns rather than rows. A document database is similar to key value, but here a document holds a set of key value pairs, and each document has a unique key. And graph databases use graph structures for powerful semantic queries. Graph databases are designed to store, navigate, and take advantage of relationships. Popular NoSQL databases include MongoDB. This is a popular document database, along with CouchDB by Apache, another document database. HBase is an open source column store database. It's part of the Apache Hadoop project. There's also Oracle's NoSQL version and Apache's Cassandra DB, which is built for scalability, availability, and performance. It's known for replication capabilities across data centers. Considerations when choosing SQL versus NoSQL databases. First, with respect to SQL databases, they're based on relational set theory. What that means is that operations like union, intersection, difference, as well as select and relational join, and others are supported. So if those are needed, then that would indicate using SQL database. Defined relationships are established between tables, providing a complete picture of the data in a SQL database. They're also ACID compliant, safeguarding the integrity of the data. Typically, SQL databases are used with structured data. They are, after all, optimized for structured data. And SQL, Structured Query Language itself, is a very mature, powerful, and well-known language for database interaction. NoSQL database. A NoSQL database may be indicated when you have extremely large volumes of data. NoSQL databases are designed for unstructured data. There are many flexible and powerful cloud storage and cloud computing environments available with very flexible licensing terms. For rapid development, consider that NoSQL databases have a flexible structure that require no downtime whatsoever when they're changed. So developers can keep developing in short iterations via Agile, for example, knowing that the changes in data structure won't impede progress at all. In this video, we'll configure Node.js. To get started, open a browser, navigate to nodejs.org, download the latest LTS version of Node.js. Then, once it's done downloading, install it. It's a very simple, straightforward install these days, even on Windows. Okay, the other tool that you're going to require is a text editor. For coding, I use Visual Studio Code for a number of reasons. It's an excellent environment. So I have that open right now. I also have a terminal prompt, actually a PowerShell prompt open. That's one of the nice benefits of using this tool. Okay, so once you're done installing Node, you can check the version of Node that you're using by typing node-v. My version is reported as 10.16.0. Similar to that, type npm-v to find out what version of npm that you have running, and I have 6.9.0. Okay, I'm going to clear the screen by typing CLS and pressing enter. I won't say that every time, I'll just type CLS and press enter to clear the screen going forward. Okay, first thing to do is to create a folder named myapp under my project directory. So I'm going to type mkdir myapp, press enter. I'll cd into myapp, and here I am. Now in Visual Studio Code Explorer, I'll right-click myapp, select new file, and now I give it a name. I'll call this node demo.js. Press enter, and it's saved. Now I have to initialize any Node app this way. So in the root directory of the application, I'll type npm init. I'll specify the -y flag, and that will accept all the defaults. And this will initialize my Node app. And now I can see that a package.json file has been deposited with an object describing my app at this point in time. Okay, back to node demo.js. Now I'm going to paste the code in, and then we'll examine it. Okay, so here's our code. I'll press Control S, and let's examine this code, starting with line 1, which is a comment. And it just tells me that I require the HTTP module. And if I'm going to use create server, I need the HTTP module to create a server on this machine. So that's what I've done. So const HTTP equals require HTTP. Then I create a host name and I create a port, and those are both constants. Then I create a server object by calling the create server method. It takes two parameters, request and response. Then down in the body of the function, I specify the response will have a status code of 200. I'll set the header content type to text plain, and I'll end it with a message, hello world. On line 16, the comment says, tell the server to start listening, and that's exactly what I'm doing here. So I invoke the listen method, I pass in the port, the host name, and I'm just going to run console.log at this point and specify server running at the host name and port combination. So that's what I should see on the console when I run this in Node. However, in the browser, I should see hello world, right? Okay, so let's go down into terminal. I'll type Node and the name of the app, which is nodedemo.js. Press enter, and there's my console message, server running at http://localhost:3000. Over to the browser. Now let's click on problem loading page tab. Now I'll refresh, and we should see hello world. And we do. Okay, so that's a quick look at how to configure Node.js. We created a small app that generates a message in a browser, hello world. In this video, we'll configure Ruby on Rails. To get started, open a browser and navigate to rubyinstaller.org. This opens to the downloads page. The version to install is the recommended version, and at the time of this writing, we're talking Ruby plus DevKit 2.5.5-1 x64. I'm on a 64-bit system. Click to download the binary. Click Save File if you get an opening dialog. Once that's done downloading, go and start the binary by clicking on it. Now when the Ruby setup wizard appears, accept the license and click Next. In fact, you're going to click through all of these and just accept the defaults. But make note of this. On Select Components page, you've got MSys2 Development Toolchain. You do need that, so just make sure that that's selected. Click Next, and Ruby installs. Now, this installation can take a couple of minutes. I'm going to fast forward through it because of the magic of video. But just be aware, if you're following along, that this install can take a couple of minutes. Okay, now that part of the installation has completed. At this point, when you click Finish, the Ruby setup is going to run an ridk install command in a command prompt. This will set up MSys2. So go ahead and click Finish. In the new command prompt that appears, type 3 and press Enter. And this install can also take a couple of minutes, so just be aware. Okay, so that succeeded. Close the command prompt. And I'll click on the SQLite homepage tab. So navigate to SQLite.org. On the page, locate Download, click on it. And on the download page, scroll down, locate SQLite Tools-Win32-x86 under Precompiled Binaries for Windows. Click on it, and then if an opening dialog appears, make sure that Save File is selected and click OK. Now, depending on your browser, for me, I'm using Firefox, I can click the download icon in the toolbar and go into the directory where that was downloaded. You can do the same. You may have a different browser. It just depends on what browser you're using, how you get there. In any case, my downloads are in my downloads directory. So I'll click the folder icon, and that opens with the file highlighted in the downloads directory. Right-click the file, select Extract All, click Extract. Now, drill down into the extracted directory. I'm going to highlight, press Control-C on these files. I'm going to copy them over to the project directory. So I'll open the project directory, Press Control V to paste those in. Now I'll click the address bar, press Control C to copy that path. And now on the taskbar, click Start, begin typing environment. And when Edit the System Environment Variables appears, click it. In the System Properties dialog, click Environment Variables. In the Environment Variables dialog, under System Variables, locate Path, click on it, click Edit. In the Edit Environment Variable dialog, click New, and press Control V to paste that path, C:\project in, click OK, OK one more time, and OK again to close those dialog boxes. And now at this point, if we open a command prompt, we should see that we have a Ruby version installed, and SQLite 3 should respond with the version it is using as well. So I've got my command prompt pinned to the taskbar. Typically, you can get there by right-clicking, Start, and selecting Command Prompt. So I'll do that this time. Okay, so now Ruby-V, and that tells me the Ruby version, and now SQLite 3-version. Press Enter, and that tells me the version of SQLite 3 installed. So now type CLS and press Enter, and now we can install the Rails gem. First, I'm going to navigate to my project directory. Clear the screen, and now I'll type gem install Rails to install Rails. In the Windows Security Alert dialog that appears if one appears for you, click Allow Access, and let the install continue. Now, this is another installation that can take a couple minutes. I am going to fast forward through it, but just be aware this can take a couple of minutes. Okay, and now that part's complete. I'll clear the screen, and now let's check the version of Rails. So I'll type Rails -- version, press Enter, and it reports Rails 5.2.3. Clear the screen one more time. And now Rails includes several scripts called generators. Generators can make things really easy for us, especially when first starting out. It creates everything required for a specific task. We'll use one such generator, the new application generator. This will set us up with a fresh Rails project, including the directory structure and required files. To use this generator, type Rails new and the name of the app. I'll call mine Web App. Press Enter, and now while that's installing, and this installation can take a couple of minutes as well, while that's installing, just a heads up that sometimes Rails new Web App can fail. And this is due, in many instances, to the SQLite 3 gem not being installed properly. Sometimes the SQLite 3 gem needs to be installed manually. And you'll see at the end of this installation, it may report that there was problems installing that particular gem. If so, we'll have to install it manually. Okay, and SQLite 1.4.1 failed. So we have to install it manually. So I'll type gem install SQLite 3-V 1.4.1. Press Enter. Okay, done. So now let's cd into our web app. So cd web app. I'll clear the screen. I'll type dir, and here's our directory structure and all the required files. So this was generated for us by new application generator. One last step. We have to bundle install because some gems may have been missed due to the error. So let's bundle install, press Enter, and it's complete. Now, when we used the generator, it actually created a functional web app for us. However, in order to see it, we have to start the server. Now, because we're on Windows, we have to pass the scripts under the bin folder directly to the Ruby interpreter. So first, I'll type CLS, press enter to clear the screen, and I'll type Ruby bin/Rails server. Press enter. And the server is listening on port 3000. Let's go over to the browser. Click the problem loading page tab. I ran this before the server was running, and it was unable to connect because there was no server listening on port 3000. But now there is. So if we refresh, we should see the Rails default information page. And we do. So we've successfully configured Ruby on Rails on this Windows 10 development machine. In this video, we'll configure Django and Python. To get started, open a browser and navigate to python.org/downloads. Download and install the latest version of Python 3. So I'll save the file in my downloads. I'll click to launch the executable. I have to ensure that Add Python to Path is checked, and then click Install Now. Click Yes if you encounter a user account control dialog, and the setup proceeds. This setup can take a few seconds, so I'm going to fast forward to save us some time. Okay, that's complete. Setup was successful. Click Close. Now let's go over to Visual Studio Code. I'll close the welcome page. Control backtick to open a terminal prompt. And now we'll install Django. And that's just pip install Django. Okay, that's done. Now let's clear the screen. And now we can use Django admin to start a project. I'll call this portfolio. So that's Django admin, start project portfolio. Okay, so now that's done. I don't like the folder structure of portfolio. So I'm going to open File Explorer and explain why. If I go down into project, I'll see I have portfolio. Then underneath portfolio, I have another portfolio. And then the py files make up my project. So I'm going to highlight these files, Control X to cut them back to the parent portfolio directory, Control V to paste those in, and now manage.py, I'll grab that and drag that to the project folder. I'll click portfolio and delete it. Okay, and now my structure is set. Back into terminal prompt, CLS to clear the screen. Now at this point, I can create an app, and I'll call that app Hello. So that's Python, manage.py, start app, and the name of the app is going to be Hello. Press enter, and that's done. Now, under portfolio, so expand portfolio in Visual Studio Code Explorer, locate settings.py, click to open it. And now we have to add a line to tell our project that our app exists. Scroll down under installed apps. We're going to add an app here. New line, hello. And that's good. So Control S to save that. Okay, so now that it knows that that app exists, we need to find the views.py file in the hello directory and create a hello function. It's a view function. So let's go over to hello, expand hello in Visual Studio Code Explorer. Click to open views.py. We'll start a new line here, and we're going to define hello, and we'll return render request hello.html, open curly braces. Control S to save that. So in this code, we've defined a view function called hello, and when it's called, it renders an HTML file called hello.html. Now that we've created the view function, we have to create the HTML template. Render looks for HTML templates inside a directory called templates in your app directory. So let's create that templates directory and a file named hello.html inside it. So we'll right click, select new folder, call templates. Now let's right click templates and select new file. And the name of this new file is hello.html. Let's add some pretty simple code to it, just one line. So just hello Django inside h1 tags. Control S to save that. And now we hook up the URLs so that we can visit the page. So the project has a module called urls.py. So locate that, click on it, and on line 17 from Django URLs import path, we also need to import include. And we're going to define one more URL pattern, and that is our root path. And here we'll include hello.urls. Okay, so now this looks for a module named urls.py inside our app and registers any URLs found there. So whenever we visit the root of the URL, the hello app's URLs will be registered. The hello.urls module doesn't exist yet, so we'll need to create it. So right click hello, select new file, urls.py, press enter. And now I'll paste some code in here, right click, select paste, and here's my code. So basically what I'm doing is I'm importing path from Django URLs, hello from views, and one URL pattern that's my root path. Okay, so Control S to save. Okay, and now in terminal, I'll clear the screen, and now I'll start the server. And that's done by typing python manage.py run server. Press enter. Okay, and that starts. Now let's go over to the browser. Click the problem loading page tab. Earlier I tried connecting on port 8000, but no server was running, so it was unable to connect, obviously. But now I've got my Django app running. I'm going to refresh. And there's the hello Django message. So we've successfully created a Django app. In this video, we'll work with Docker containers. To start, navigate in a browser to hub.docker.com. If you don't have a Docker Hub account, you can click Sign Up for Docker Hub. Follow the instructions, and you'll be signed up for a Docker account. I've already got one, so I'll click Sign In. And I'll click Sign In on the Docker Sign In page. And now I'm signed in. Locate Get Started with Docker Desktop. Click on it. This starts a 5-step process where you can download Docker Desktop for Windows, install it, and then perform some pretty simple activities. We'll download it, and then we'll perform our own activities. I'll click to download Docker Desktop for Windows. Click Save File. Now this is a rather large file. It's 541 megs. So depending on how fast your internet connection is, it may take a while. Mine's fairly quick, so it's coming down very fast. Okay, and it's done downloading. I'll click on the Docker for Windows downloaded executable to start the installation process. If user account control dialog appears, click Yes. On the configuration page, leave the defaults and click OK. And the installation proceeds. Okay, the installation is complete and was successful. Now, in order to run this, you have to close and log out. You can do that by clicking Close and Log Out. So I'm going to do that. Now I'll log back into my account. You should notice that a Docker desktop icon appears on the desktop. That was one of the options that I selected. you'll see a notification indicating that Docker Desktop is starting. The first time you run Docker Desktop, you may see a Docker Desktop dialog similar to this one, indicating that Hyper-V and container features are not enabled. And do you want to enable them? Click OK to enable them. Your physical machine will restart a couple of times. And this is necessary in order to enable Hyper-V and containers features. So let's go ahead and click OK. The machine subsequently restarts and enables Hyper-V and container features. Okay, a notification tells us that Docker Desktop is starting. In the notification area, you can see the Docker icon, and evidently it's still starting. If you right-click, you'll see a number of different options here. Okay, and once it's finished, a notification tells you that Docker Desktop is now up and running. I'm going to close the notification, and I'm going to click on my PowerShell icon in the taskbar. I'll maximize this window. And now I'll navigate to my working directory, that's C:\project. I'll create a Docker directory here and cd into it. To get started, now that everything is up and running, let's type Docker version. So that's Docker -- version to see what version we have. Okay, and it tells us that it's 18.09.2. Now we can pull the Hello World image from Docker Hub and run the container. So I'll clear the screen and I'll type Docker run hello-world. Now first, Docker attempts to find the image locally. It won't be able to, so then it pulls it from Docker Hub. And this is the result. You see this message from Docker. This message says that your installation appears to be working correctly, and it gives you some additional information. If you want to try something more ambitious, you can run an Ubuntu container with this command. And there are other commands. Let's go over a couple of other commands. Okay, at this point, I want to run an interactive Ubuntu bash shell. So I'll type Docker run --interactive --tty Ubuntu bash. And again, Docker attempts to find the image locally. It won't be able to, so it pulls it from Docker Hub. And now this is running. And from the prompt, you can tell that I'm on the interactive shell of this Ubuntu machine. So if I type ls, I'll see the file system on this machine. To exit it, just type exit, press enter. And there we are, back in Docker again. I'll clear the screen. And now to list all the Docker containers, type Docker container ls --all. And this lists all of the images on this machine running or not. Okay, so that's a quick look at working with Docker containers. In this video, we'll work with a Firestore document database on Google Cloud Platform. To get started, navigate to cloud.google.com/cloud_platform in a web browser. If you don't have an account, this is the perfect place to start because you can click Try it for free and you'll receive a 12-month free trial with a significant amount of credit with your account. Now, I already have an account, so I'm going to go up to the menu bar at the top and click Sign In. It's cached my email and my password, so I'll just click Next on each. And now I'm logged in. I'll click Go to Console. And here's my Google Cloud Platform console. I've got a couple of projects already One of them's named K8s project. Let's work with a Firestore document database. So let's click the navigation menu, scroll down, and under Storage, locate Firestore and click on it. Okay, now the first thing you have to do is choose what mode you're going to use, native mode or data store mode. In native mode, the API is a Firestore API, whereas in data store mode, it's a data store API. There are other differences between the two. For example, scalability scales out according to concurrent clients for Firestore native mode versus millions of writes per second in data store mode. App Engine is supported. There's a limit on the maximum writes, real-time updates, and mobile and web client libraries with offline data persistence capabilities with native mode. With data store mode, no offline data persistence. So let's click Select Native Mode. Now, for a location, click the drop-down, and I'll select NAM5, that's United States. Click Create Database, and Google Cloud Platform goes off and creates our Firestore document database for us. Be aware that this can take a few seconds. Okay, the database is ready. Now, to get started, we'll add some data. Click Start Collection. And now if you click in the collection ID field, we can give the collection an ID. It's a descriptive ID that describes the documents that we'll add with this collection. We'll specify users. Now, the first document, if I click in Document ID, Google Cloud Platform automatically creates a document ID for me. I can overwrite this, but I'll leave that as is. Field name, I'll specify first name. And the field value, I'll specify my name. I'll add another field. This one will be role. And the field value will be instructor. Okay, so let's click Save. Okay, and now that data is stored in my Firestore data store. So I've got my collection, there's documents in my collection, and there's data in my documents. So the data consists of first name and a value, and role and a value. Now, with Cloud Firestore, you can integrate it into a web-based application using a variety of languages. For example, there's Swift, Objective-C, Java for Android, Kotlin for Android, Java, Python, Node.js, Go, PHP, C#, and Ruby. Okay, so that's a look at how to configure a Firestore document database on Google Cloud Platform. In this video, we'll configure an ASP.NET MVC application. For this demo, I'm going to be using Visual Studio 2019. I have Visual Studio 2019 pinned to my taskbar. I'll click on it to launch Visual Studio 2019. And to get started, under Get Started, I'll click Create a New Project. And recent project templates that I've used include the ASP.NET Web Application.NET Framework, which is exactly what we're going to use, but you can also find it in the list on the right if you scroll down. ASP.NET Web Application.NET Framework. You can also search for it in the search field. I'll just click on it, and I'll click Next. In the Configure Your New Project page, I'll give the application a descriptive name. I'm going to call it My MVC App. .NET Framework 4.7.2 is chosen by default. I'll leave that as is and click Create. Now, I have several choices. I have an empty project template that I can choose, web forms, MVC Web API, and single page app. And we'll choose MVC because that's what we're going to be working with. On the right-hand side, we've got authentication options, adding folders, core references, advanced options like configure for HTTPS, Docker support, which requires Docker Desktop. You can also create a project for unit tests. I'll leave the default selections as is and click Create. Now, Visual Studio goes off and creates my project and then comes up with the project. Now, right out of the box, we have an application that is a full-fledged MVC application. And to debug it or view it in a browser, all we need to do is click IIS Express Firefox. And we have other options that we can choose. If we point to web browser, we've got a number of different options like Edge, Explorer, Google Chrome, and so on. We'll just leave Firefox selected. And now to start debugging, again, I can either click the arrow beside IIS Express Firefox, or I could also just press F5. So I'll press F5 on my keyboard. Now that fires up, and as you can see, a potential security risk ahead because we're using HTTPS, and this browser doesn't like the self-signed certificate. So I'll click Advanced to continue anyway. Scroll down, click Accept the Risk and Continue, and momentarily my MVC app will appear. And there it is. When you close it down, it goes back to Visual Studio 2019. We can start exploring aspects of our application. For example, in Solution Explorer, under My MVC app, I've got all of my application data, structure, and resources, including, of course, my controllers, models, and views. In this exercise, you'll practice what you learned about backend development and tools. You will identify backend development frameworks, describe Enterprise Service Bus, describe middleware frameworks, compare the REST and SOAP APIs, and compare SQL and NoSQL databases. Now pause the video and perform the exercise, and when you're finished, come back here for my solution. Okay, backend development frameworks. We looked at Node.js, which is an integral backend development framework because it also works with Express, Koa, and Happy.js to facilitate backend development. Now, Enterprise Service Bus. It's a backend technology that connects services together using a bus-like infrastructure, and it has multiple uses. It can be used as a transaction manager, as a security manager. It can also be used as a proxy service or as a gateway. Middleware frameworks are essential for client-server connectivity. They also provide the management of client-server request and response, as well as data integration service, and they also provide error handling services. Now, REST versus SOAP. REST API is an architectural style, whereas SOAP is an actual protocol. REST APIs access predefined data resource, whereas SOAP APIs perform some operation. REST supports HTML, XML, and JSON, whereas SOAP is XML only. REST supports HTTPS and SSL, while SOAP supports web service security and SSL. REST can cache API calls, but SOAP cannot cache API calls. Now, SQL versus NoSQL. First, SQL. SQL is based on relational set theory, so if you're using queries that require operations like union, intersection, and so on, then SQL is your tool. SQL uses defined relationships between tables. They're ACID compliant, safeguarding the integrity of the data. Relational databases typically use structured data. That's what they're optimized for. And SQL as a language. It's very mature, powerful, and well known. Now, NoSQL. NoSQL is indicated when you have extremely large volumes of data, and this is unstructured data, typically. That's what NoSQL databases are awesome for. There are many powerful cloud storage and related cloud computing options available with very flexible licensing terms. And NoSQL databases have a flexible structure, and they require no downtime when the structure changes. So developers can develop in short cycles or iterations, for example, like in Agile, without having to worry about the data structure impeding progress.
In this video, I'm going to discuss the three main parts of any full-stack developer's environment. These are the three main core knowledge areas that any full-stack developer in any track would need to know. So it doesn't matter if it's web development or Microsoft or Java or even Oracle. We need to have these three layers or the knowledge in these three layers as much as possible. So for a web developer, we would have the client side. This is the customer-facing interface or set of interfaces. And at least in web development, when we talk about the client side, we're talking about things like HTML. HTML will give structure to the documents that appear on a browser screen. Then we will talk about the look and feel of that HTML document. So CSS would apply coloring, and it would apply a lot of the positioning and layering, etc. on that web page. Then once we have those two things in place, we may or may not introduce some JavaScript. JavaScript would allow the user to have a better experience with your website, with your web page. It provides activity, it provides interaction, and it gives some feedback in certain situations. So these are the three main areas of the first layer, the client side. But of course, there's a lot more to these three core layers and, in fact, these three parts of the client side. There is also multimedia. So the part of your knowledge bank should involve working with images, working with audio files, video files, and a little bit of animation. Now, once we have that first layer down, then we have to move on to the second layer, which involves the business logic. This is where most of the programming will take place. And when we work with the second layer, the business logic, we're actually working with physical machines. We're working with servers here. And these servers will then communicate with the front end. There's a back and forth that happens between the browser and the server. So sometimes developers will refer to this second layer as the development environment, although the entire three layers together is the main development environment. So one of the main features of the second layer is to provide support for that front end layer, that client side layer. But it also means that the second layer communicates with the third layer. That third layer is the layer that handles things like form data. It handles other data as well, from maybe it's coming from a third-party application. So the idea with the third layer really is to take all of this data and do something with it. In other words, this layer should persist the data or any changes to that data that happens on the front end. So we're talking things like having knowledge of some database, like MySQL, for example, as an open source database. We may also need to know about SQL and stored procedures, database functions, and transactions, and that sort of thing. So with these three layers combined, we can now build a robust and a full functioning application. It's sometimes referred to as a monolith application. Now, of course, and as a full stack developer, this is not the end of the story. There are a lot more technologies out there a full stack developer would at least need to be aware of. But these three layers form the core of any application. And if you have knowledge in these three layers, then you can definitely build an application, a full functioning application, and then work with the other components as time go on. In this video, we're going to look beyond the core three layers, the front end, the middleware or the logic area, and the database. So during development, developers are always thinking about how to improve the entire process, how to build faster, better, safer. They think about testing, quality assurance, and deploying, how to deploy their applications easier. Large projects do take a lot of time. So if we can employ build tools, automated testing, for example, these will all play a part in making or in bringing down that time. And yes, there are a lot of tools out there that would help with these things, these build tools. But of course, if you're on a sophisticated IDE like Visual Studio, like NetBeans, etc., then you don't really have to worry too much about these various tools. They're already built in to the IDE. But if you're a standalone type of developer, or if you're developing open source, then you have to look for these various build tools. Things like, in terms of testing, there are lots of tools like Sauce Labs, BrowserStack, and Selenium. But the most popular build tools are actually Gulp and Grunt. A build process works with project files by running tasks. They also help compile and test the code. Now, for simple HTML and CSS, the best place to start testing would be the modern browser itself, something like Firefox, Chrome, Edge, Opera. These all have what are called developer tools. So testing at the HTML and CSS level is really very subjective. It actually does go hand in hand with the specifications. As long as your code meets the specifications, then you have tested it. In fact, most of the testing at this level will be syntax or syntactical testing. There's also cross-browser testing, where we look at the page that you've developed in different browsers and make sure they look the same. There's also regression testing at this level, where when the user performs a certain action, then you need to make sure that once that page is refreshed, it looks exactly like the page was before the action was performed. QA testing is almost synonymous with regular testing at this point. The QA tester will look for things like how accurate the design is compared to requirements. And he or she may look at running that code on various viewports. They look for behavior, certain behavior, and of course the look and feel and performance and things like that. Now, fortunately, developing at the front end is sort of easy, I would say. In most cases, it's really just a matter of compiling all the files together and uploading to some live site, or maybe passing on to another department to do further work with, or even FTP to some live site again. But it also means that you may have to minify or compress your code, and sometimes it includes source maps. So again, there are tools to help with this. In large-scale projects, there may be dedicated deployment servers like Jenkins or Travis. Once you have all of your files ready to go and you're not deploying to a company system, then you may have to look into things like hosting and DNS services and that sort of thing. So fortunately, it is easier now than when the web first started, because all you really need to do is access a company like GoDaddy, and they will do pretty much all of the work for you. You just have to tell them what you need to have done. But once all of your work is finished, then you will realize that you're going to have to make changes and updates to that application. And this is where tools like Grunt and Gulp come into play. These kinds of tools help manage those changes and updates. But like most, these tools will need to find where your code is sitting. And a lot of developers would use things like Git and GitHub to deploy their code and to manage those changes to that code. So Git and GitHub will host your code, and they will make sure that any changes to that code is merged properly. And you can even go back to a previous version if necessary. So once all of these changes start happening, you will soon realize that you're in some kind of an iterative process. So perhaps it's the best time to start talking about an agile approach to development. Agile suggests that development happen in small increments. This prevents you or the developer doing too much coding before some change is made, and we have to reverse everything that we've done already. But once development, testing, and deployment is over, then the site goes live. Now, in certain situations, your website may have to accept payment from customers. They may be selling a product or a service. In this case, you will need some kind of a shopping cart, and that has to be installed. You need to connect to some kind of payment gateway, install a merchant account. So there's a host of other tasks that are involved once your site starts selling things. In that case, a new round of development may have to take place. A third party may provide a module that you have to add to your site. A merchant account needs to be set up. A relationship with a financial institution needs to be established. At some point in time, you will realize that your site is either going to depend on some other service, or perhaps your site is providing a service to other consumers. Now we're getting into the realm of web services. You would have to have some knowledge of things like APIs, XML, JSON. The web is becoming quite complex when it comes to the exchange of data, especially structured data, so you have to have knowledge in this area as well. Finally, although not too important, if you want to have your website gain traction on the internet, then it's a good idea to learn about search engine optimization. So as you can see, beyond the basics, beyond the core development areas like the client side, the logic area, and the database, there's a host of other things, other knowledge areas that full stack developer needs to know about. In this video, I'm going to focus on the client-side development and talk about some of the technologies that are applicable to this layer. So let's start with HTML itself. There really isn't a whole lot of help out there for HTML. HTML is simply made up of these various tags, and you have to have knowledge of these tags in order to build a good HTML document. Now, if you search on the internet for HTML snippets, you may get quite a few out there. Items such as navigation or contact us are very typical, so it may be possible to get HTML snippets for these items and simply incorporate it into your web page. There are a lot more snippets for CSS actually, and there's even more for a combination of HTML and CSS. But you might want to consider something like Bootstrap. Bootstrap is actually one huge big repository of snippets. And if you go to the getbootstrap.com website, there are several free and usable components, what they call components. It's the same as snippets. And you can use it on any website. They have components for alerts, for buttons, for menus, forms, pagination. So just about anything that you're building, you can get a component or snippet over there. Bootstrap is actually a treasure trove of components that can be tailored to any given situation. And in fact, I can say the same for JavaScript. There are tons of code out there for JavaScript, mainly because of its popularity and also having been around for a very long time. And there are also frameworks like jQuery. jQuery has made the need for pure JavaScript almost obsolete. jQuery is able to hook into the same element names and IDs that we give to those HTML elements, and we can use that to manipulate those elements. So with jQuery, it's very easy to perform simple animations like hide an element, move it across the page, or hover. And of course, for all of HTML, CSS, and JavaScript, there are browser-based tools like, for example, Chrome Developer Tools and Firebug. With these tools, we can easily check various parts of a web page and see all of the coding that are affecting that part of the web page, or you can actually drill down to each and every individual element. Now, if I may just go back to CSS for a minute, I will say that CSS is just one of those things. It's a markup type of a language, and there's really not much to it. You have to know the syntax, and you have to know the various properties and the values. However, recently, there's something called Sass that came about and have made CSS a little bit easier to use. Sass is considered to be a CSS preprocessor, which means we can now use things like variables, nested rules, and something that they call mixins for general or regular CSS. This makes coding in CSS a little bit simpler and a little bit more efficient. In other words, what they're trying to do is make CSS more like a programming language rather than a markup language. So for example, you can declare a primary color and call it something like PC or something like that. So now whenever you use PC in your CSS code, then that primary color the value of PC will now show up in terms of your in terms of pure CSS. Then there's something called Backbone JS. Backbone attempts to work with data a little bit more directly, and its architecture is based on what you might have heard before, the MVC style, or more specifically, the MV star pattern. So Bootstrap has a collection of models, events, and routers, and it works by encapsulating the data that it received from the server, so there's no direct interaction between Backbone and the server, at least not yet. And it works with that data as it comes forward from the server, and it presents that data to the user or to the user end, the client side, as a collection. Bootstrap is considered to be a SPA, a single page application, or to work with SPAs. And like Bootstrap, there's also AngularJS, which is more view model. With Angular, most of the work of putting the page together is done on the browser, so it sort of like removes the responsibility to the browser. The server simply sends all of the HTML, CSS, and JavaScript that the page needs, and then Angular takes over. In other words, the developer can insert some logic into the page itself that's being built on the fly. Now, React is just another JavaScript library used for building those SPAs, those single-page applications, and also user interface components. React works with the front-end application, and it handles data changes without reloading the page. So React happens to be fast, it's also scalable, and it tends to be simple to use. Now, in terms of JavaScript itself, there is some applications out there, things like JS Hint and JS Lint. Both applications will analyze JavaScript code, and it'll check for any syntax errors. JS Hint tends to be the better of the two, and it comes with an online version as well, and there's also a plugin for Node.js. With the online version, developers can simply cut and paste your code into the window that they provide for you, and the analysis begins almost immediately, and it produces a report in real time. Gulp is usually installed via npm, and it's a workflow management tool. It also helps you with testing. It has only 4 APIs that perform all the work. It can compile all of your JavaScript files into one file for easy download. It also does things like minifying that JavaScript. Usually developers talk about Gulp and Grunt together. Gulp can also run things like unit tests, which I mentioned before. It can analyze your JavaScript code, and it can convert that Sass code that I talked about before into pure CSS. So Gulp and Grunt basically do the same thing, but Gulp is a bit newer and more modern than Grunt. Then there's Mocha and Chai. Mocha is an excellent unit tester for JavaScript, and Chai is what they consider it to be an assertion library. Jasmine is very much the same as Mocha. It's a unit testing tool for JavaScript. So as you can see, just on the front-end development alone, there is a lot of tools out there, and they can be applied to your front-end development in lots of different ways, and helps you manage your code and build better applications. In this video, I'm going to look at some of the front-end CSS frameworks. Now, these frameworks help developers develop websites and web pages really quickly, and they look professional. The idea behind these frameworks is that a developer does not have to have a design element to your portfolio in order to build these sophisticated, beautiful-looking front-end user interfaces. We can simply install a framework and start applying or using the components from that framework. So the first one I'm going to talk about is Semantic UI. It is supposedly easy to use because it uses natural language, or their definition of natural language. The framework has a standard way of presenting or displaying HTML elements, and it's really just a matter of going to their website, choosing which element you want to use or which component you want to use, and apply it to your website. This framework is powered by something called LESS and jQuery together. So for example, if you wanted to create a 3-item menu, you simply declare a div tag and apply the class of UI 3-item menu, just like that. UI 3-item menu, that's what they mean by natural language. And you will get a 3-item menu. Of course, you're going to have to define what each menu should display, of course. Foundation claims to be the first front-end network. In fact, Bootstrap took a lot of their ideas from Foundation. Foundation is built to accommodate mobile apps initially, and then the code itself adjusts to larger viewports. Foundation was actually the first to introduce the 12-column grid concept, which makes it really easy to build the typical 3-column designs that we see so often. Bootstrap is a front-end specific framework with tools for designing websites and web application, and its popularity comes from HTML and CSS-based templates. So they have templates for things like typography, for forms, for buttons, for navigation. You may consider them components if you wish. So with using Bootstrap, in fact, all of these frameworks, developers never really have to worry about whether the site will work on a mobile phone, a tablet, or a desktop. These frameworks handle all of that nitty-gritty stuff for the developer. I'd like to talk now about some other frameworks like Materialize. Materialize is a CSS library, but it's based on Google's material design concept. With this type of concept, what Google does is they define the relationship between space and motion. In other words, there's a lot of human-computer interface design elements woven into the ideas of Materialize. The idea here is to capture on a 2D screen, as best as possible, a real-world tangible item, like a folded piece of paper, for example. If you've ever dragged a file to your waste paper bin or recycle bin in Windows, then you understand the concept here. Materialize has a predefined code or a set of predefined code for HTML elements like buttons and forms and navigation bars. But there's also a JavaScript component that handles activity like clicks and button presses as well. Of course, it's also responsive based on the viewport size. Now, Pure is, as the name suggests, pure CSS. It is one of those frameworks that does not use JavaScript or jQuery. It is really pure CSS. And with Pure, you can easily create responsive buttons and menus and grids and tables and things like that. What's nice about Pure is that it is very small, 3.8 kilobyte at the time of this recording this video. So Pure was designed really with mobile devices in mind. And so their file sizes are really small. And they do have several components though. They have layouts, menus, and all of these can be customized for your specific need. And the last one I want to talk about is Skeleton. And this is really for very small projects. And the developers emphasize this. Skeleton provides styles for just a handful of HTML elements. So things like buttons, tables, and forms are well styled, but they do also have a grid. Now I'll talk about some of the JavaScript frameworks like jQuery, which is probably the most popular JavaScript library that exists. It makes working with the document object model easy and simple. And the power of jQuery really comes from its methods. It has the ability to wrap up several lines of pure JavaScript code into one simple method call. And with so much attention given to jQuery, there's now a plethora of plugins that have been developed for jQuery that will do almost anything that you can normally do with HTML, CSS, and JavaScript. So they can implement special effects and animations. jQuery can also work easy with, or it makes working with Ajax much easier. React is another popular JavaScript library started by Facebook, and React makes it easy to create interactive user interfaces. React has the ability to keep state. So if the user had clicked on a particular color, then that color will remain as long as that session is active. So it has the ability to keep state and also work directly with data. AngularJS began its life at Google. It's another JavaScript framework, and it uses directives to manipulate DOM elements, document object model elements, or HTML elements. AngularJS attempts to simplify both development and the testing of cross-platform mobile applications, and this using the various architectures like Model View Controller and Model View Model architectures. What AngularJS also does is it tries to separate document or DOM manipulation from application logic, and also separate the client side of an application from the server side. So this means that development can continue in parallel, and it allows for the reuse of both the client and server-side components. Vue, or Vue.js, on the other hand, is a progressive type of framework, and it's really intended for those SPAs, those single-page applications. In other words, it can adapt to the skill level of the developer. So it's one of those introductory types of technology. And it's not really backed by any large corporation like Google or Twitter or Facebook. Vue was built by adopting some of the best ideas of some of the other frameworks. Vue uses a templated style of syntax, and it allows you to bind DOM elements to the data that is going to be applied to those elements. So hopefully you get an idea of all of the different front-end frameworks that can be applied to web development and make your life a lot easier as a developer. In this video, we're going to look at web server technology. This is the piece of software that takes your code after you've worked hard on it, take that code and then present it to users, present it to clients. So a web server is an example of the client-server model. It is software that employs the Hypertext Transfer Protocol, HTTP, to serve up the web pages that you have created to your users or the clients. So a computer that uses the web server technology or web server software to serve HTML files, this is a process known as hosting. So that computer might be known as a hosting computer. One of the best known web servers is Apache. It's open source, and after Apache, there's Microsoft's Internet Information Server, IS, and Nginx has made a name for itself recently. Other web servers include Google Web Server and IBM's family of Domino servers. The main function of a web server, of course, is to serve those HTML files to browsers, but its selling point is that it can handle thousands of requests at any second. So apart from handling requests via the HTTP protocol, web servers are supposed to handle things like email and FTP. They can also log the information that is going, or log all of the activity that is happening with that web server. And we can also do things like create virtual directories and allocate different ports to handle different applications. In fact, in some cases, the web server may even be the go between your front-end application and the database behind it. I'm going to talk a little bit about the different types of web servers that are out there, and Apache, like I said, is one of the most important one. It is maintained by the Apache Software Foundation. It is actually one of the oldest web servers out there, first released in 1995, and unlike IIS, Microsoft's IIS, Apache is cross-platform, meaning that it can run on Windows and Linux. And there are quite a few large companies that are using Apache, people like Cisco, IBM, Salesforce, General Electric, and a host of others. And with Apache, developers can add modules as required. So it can be a thin application to begin with, but as time goes on and as your application becomes more sophisticated, then you can add all of these various modules to your web server. So as you can see here, we can include the SSL module for encryption. There's support for IPv6 and for FTP, etc. On the programming side, Apache supports languages like Perl, Lua, and PHP. One major function, though, of any web server is the ability to throttle requests. And this is the ability to decide how fast a request can be handled. Also, there's load balancing. This is when priority is given to certain applications or certain processes, at the expense of others, of course. But you could see where this might be helpful, like maybe around Christmas time. You want to give more bandwidth to certain applications. So that's Apache. And in terms of IIS, well, pretty much the same features as Apache. IIS, or Internet Information Server, is now up to version 10. And it's extremely important within the Microsoft ecosystem. So it has, like I said, it has all the features of Apache, including the ability to add virtual directories, log activity, monitor the performance, and of course allocate ports as necessary. With IIS, though, even though it supports anonymous authentication, you do have the ability to include something called certificate authentication, and you can also integrate with Windows authentication. This means that you've given your users the convenience of single sign-on. As a developer, though, you may be interested in the free version of this software called IIS Express. This is what a lot of developers would use to test code. Nginx, on the other hand, is open source as well, and it's an excellent choice for serving static web pages. So in other words, it's probably not as robust as the others. It is heavily used with microservices, with the microservices type of architecture. Again, due to its small footprint and due to its in-memory capabilities. Nginx is easy to set up and install. It has a load balancer like the others, and it also has content caching capabilities that makes it extremely valuable in microservices. This also means that the developer has the ability to throttle networking services, and certain pages may be served via memory rather than making another hit to the hard drive. It is also event-based, meaning that we can handle more connections with less overhead due to something called context switching. So there you have another layer that you're going to have to need, another layer of knowledge that you're going to have to know if you want to become a full-stack web developer. In this video, I'd like to start a discussion about the third layer, the storage layer or the persistence layer. This is the layer that supports the front end, the logic layers. Now, although these two layers does most of the heavy lifting for any web application, when it comes to storing changes to the data that's involved in the application, then you have to involve some kind of persistence layer. Now, some data never changes, like the days of the week or the names of countries, but other data does change almost on a daily basis. Think of the price of a stock or the temperature during the day. So this type of data has to be persisted. Also, with storage, data becomes stateful. So we can say that on a particular date, there were X number of widgets in bin number 22, let's say. And that value represents the state of inventory of widgets. When the browser closes, that number should persist somewhere, so it can be used in the future. The database layer also adds convenience for your users when they work with your application. So let's now talk about the different types of storage. And the first one first category would be local storage. By local storage, we mean there's no physical database involved. We're just using the browser itself and the memory and the hard drive of the machine, of the client that's connecting to your website. So HTML5 has given developers a gift in being able to store data on the client machine during a session. Think of a session as the start of when someone comes to your website and when they leave your website. Now, I say data as per session, but it doesn't always have to be session. In some cases, the data will persist after the session has ended. So HTML5 local storage makes it possible also to send events and data even between windows. So as long as you're on the same window, on the same domain, you can have multiple windows open and we can pass data between them. Now, before HTML5 local storage came about, there were cookies. And cookies have been around for a long time. They're really just small bits of key value pairs that a web server may pass to your browser when you visit the site. Your browser stores these cookies or messages in a file called cookie.txt. And then sometime in the future, if you go back to that website, then the browser would send that cookie back to the server, and the server knows who you are. Typically, these cookies may store data about your visit, or perhaps something that you like on the website. So obviously, cookies are not robust enough for a very serious application. They can be attacked, and in fact, all you have to do is just open up your browser window and say you want the file erased, and that's the end of the cookie file. Plus, their size is a factor as well, limiting factor, because we can only store up to 4 kilobytes of data. That's not a lot. So HTML5 local storage can be set via JavaScript, and it has a storage capacity of between 2 megabytes and 10 megabytes per domain. And of course, this is a function of the manufacturing process. They can determine that limit. So local storage can be divided up into session storage and local storage. Obviously, for session storage, as long as the window remains open, then that data will remain alive. As soon as the window is closed, the data goes away. Local storage, however, can be read by all windows with the same domain. And most importantly, after the window has been closed as well, so which means the data is persisted. But like I said, when it comes to serious applications, then you want to have a real database, something like a MySQL or SQL Server or Oracle. And probably the most important type of database out there is the relational database. But all of these databases organize data into schemas, reports, tables, views, and other database objects. And so it makes retrieving and storing data a little bit easier and more efficient. So relational databases store data in individual tables, but those tables are linked, and something called SQL or structured query language is used to make that connection between tables. Operational databases are very efficient in handling daily transactions. Think of a site like eBay or AliExpress. These databases may hold personal information, customer data, and inventory values as well. Couchbase and CouchDB are very efficient operational databases. Then there are data warehouses, which store large amounts of data, probably spanning over several years. This type of database is good for analyzing that historical data, looking for trends and patterns and things like that. So only the very large players in this area can handle data warehouses. Now, companies operate all over the world. They operate in several countries, have several manufacturing plants, maybe different branch offices, etc. And so each of these work groups may decide to set up their own database. However, it is possible to take a logical view of all of these individual databases in these different countries, different parts of the world, different branch offices, etc. And when you take a logical view of all of these distributed databases, then this is what is known as a distributed database. So those are the main types of databases that exist. Now, recently, there has been a push or a move towards something called NoSQL. And there's this debate between SQL and NoSQL. SQL or SQL or Structured Query Language has been around since the 1970s, and it is the way that developers or the language that developers use to make connections between tables. So all of the big players like MySQL, Oracle, SQL Server, they all use Structured Query Language in order to make the connection between. In other words, they take raw data and create information out of it. No SQL or NoSQL databases usually mean no tables are used to store the data. They're really more document-based. It also means that they're easy to manage and they provide a higher level of flexibility when it comes to newer data models. So NoSQL is good for unstructured, denormalized data. In a NoSQL database, data is stored as a collection of key value pairs. However, it is not uncommon to see SQL being used. So when you hear the word NoSQL, don't think that it's absolutely no SQL at all. Some SQL may actually exist in order to tie some of these documents together. Perhaps the most popular NoSQL database is MongoDB, but there's also Couchbase and MarkLogic. In this video, I'd like to introduce the Model View Controller pattern. This is a pattern that was first developed to handle desktop applications, but now it's more common with web applications, and it tends to be a little bit conceptual in its nature. The pattern is actually built on the fact that code has purpose. Some code would handle data, other code would handle the look and feel of things, and yet other code would handle some type of functionality. So let's start with the model. The model handles data. It organizes data into objects. So for example, if you're dealing with a shopping cart, then your model will handle things like the items in that cart, the cart itself, the inventory. View code directly interfaces with the user. This is the presentation layer. It makes the application present the model that I just talked about to the user. And it also specifies how your user can interact with that model. As you might expect, the controller is the go-between in all of this. It makes the connection between the model and the view. So it receives some kind of user input and then decides how to proceed with that input. It is the logic behind the application. Now, routing does not really fit into one of the other three parts. It's not a major component, but it is important. Routes decide which controller should handle a request. And it may even perform some logic on the request, for example, to split it apart. Now, when we talk about controllers, just think about functions or methods. So I want to talk now a little bit about the process. How does the process actually work? Well, the browser sends a request for a page to the controller. Remember, the controller is the method or function, and that is going to sit on the server, and it's constantly listening for these requests. As a request comes in, the controller receives the data from the model, from the database, specific to that request, and then sends it back to the browser in terms of a view. So basically, the view is built and then sent back to the browser using the data based on that request. So in theory, these three parts don't really depend on each other, which is the nice thing about this MVC pattern. The controller can send data to just about any view it wants. And so these three parts can be developed independently. So for developers, it means faster development time, easier maintenance, and things like that. So let's walk through now an MVC example. Suppose we're developing an online store selling widgets. The user can view widgets, register on the site, add items to a shopping cart, purchase those items, etc. So we will have a particular controller that will handle all of those widgets related actions, like viewing the widgets, editing those widgets, creating widgets, etc. We will also have a model. For example, we may have a file called widget model PHP, and it will handle data and logic related to items in the shop, in the inventory system. Then we may have a series of views to present that data. For example, a list of widgets or a page to edit widgets, etc. The controller will then listen for requests. For example, it might be a GET request. The user may want to see all of the blue widgets, for example. So the controller will look at that request and the parameters, and then it invokes the corresponding model, asking it to return a list of all of the blue widgets on sale. So the model is responsible for getting all of the information based on that request, apply some logic if necessary, and then return all of the data representing a list of widgets. The controller will then use the appropriate view based on that request again to present that information or present that data to the user. If, for example, the request comes from a mobile phone, then the view that is presented to that device is based on the device's viewport, for example. So the idea behind MVC is that development can take place faster, it's easier testing, and everything is all separated, so the entire website can actually be developed in parallel. In this video, I'd like to talk about representational state transfer, something commonly known as REST. Now, the original architecture of the World Wide Web was centered around HTTP, and it still does today. That's how, or I should say HTTP, facilitates the communication between web servers and web clients, browsers. So HTTP is the protocol that allows a browser to get resources such as HTML documents, and it is the basic idea behind data exchange on the World Wide Web. So clients communicate by sending messages to the server sends back messages, and that's the basic architecture. And we say that that architecture is stateless, because once the message goes to the server, the communication shuts off. Now, Alphabet, the parent company of Google, recently proposed HTTP 2, which they say is supposed to decrease latency. Think of latency as making an international or long-distance call where you kind of have to wait for the caller to respond. That's latency. So what they're saying is that HTTP 2 should provide better compression algorithms, and we should be able to send data to a client even before the request is made. It also will allow things like pipelining, which allows multiple requests and responses on the same socket. Think of a socket as a two-way communication, like a telephone call. And it supports multiplexing, which is a combination of multiple communication channels into one. Now, data in a web application works the same as in a desktop application. Data on the web follows the same CRUD principles, the create, read, update, and delete principles, as when it comes to the persistence of data. So this was the inspiration behind REST. Usually when a client makes a request to the web server, encapsulated in that message is something called a GET, or sometimes it might be a POST request. So this corresponds to the read part of the database, or if there's no database, whatever data the server has to serve. However, designers of the HTTP protocol made requests a lot more complex than this. In other words, we should be able, or we are able, to execute the entire spectrum of CRUD operations using simple URLs. And that's the basis behind REST. Let's take a look now at some of those REST verbs. We've already seen GET, HTTP GET, which simply requests resources from the internet. So a GET request does not change the state of any resource. You're just asking for data to be sent back to the browser. Now, technically, POST is supposed to be used to create a resource on the server. But most developers today use it to send the data to the server in the form of a form. So whenever you fill out those web forms, most likely in that action tag, there would be or action attribute, there would be a POST in there as well. And put is used primarily to update existing resources like a table. If the resource does not exist, then the API can be programmed to create a new resource for you on the server. Delete is exactly like it sounds. It deletes a resource from the server. And the patch can update only the certain fields in a table, but it's not really recommended because it's not really stable. So it's not recommended for important data like financial data. I'd like to talk now about service-oriented architecture. And this is important because of how important the internet has become for the exchange of data. So from around the mid-2000s, service-oriented architecture, sometimes known as SOA, became the norm as it adopted open technologies such as HTTP and XML. But with the advent of REST, the stage was set for microservices as it tended to merge HTTP and CRUD into one simple concept. So service-oriented architecture focuses on how to build an application by integrating distributed, separately maintained, and deployed software components. It is enabled by technologies and standards that make it easier for components to communicate and cooperate over a network, especially an IP network. So what I'm trying to say by this is that SOA has been overtaken by REST. However, there are still a lot of legacy systems out there that depend on this type of architecture. So it may be around for a long time. So now that leads me to microservices, which is the more modern of the different architectures that I've just discussed. A microservice is an application with a very small footprint. It runs in its own process. Notice that, process. It provides singular functionality. So what microservices are is separate applications or processes running together, but combined, they make up an application. And so this is supposed to be a non-monolithic type of application. And one of the reasons why microservices is becoming so popular is that it is easy to scale. It is easy to test, and it is very easy for different parts of your organization to be working on different parts of the system. But the idea is that once they come together, you have a full functioning system. In this video, I'd like to examine those building and testing tools for web developers. I'll start with testing and HTML in particular. And I will say that there's really not much to do in terms of testing your HTML. Basically, the developer must ensure that the code meets the requirements document. However, the developer tools in most modern browsers will catch most of the syntax errors when it comes to coding HTML. Linting is the process of passing your code through software that analyzes the code for specific syntax errors. And there are a few online HTML validators out there that will work with HTML code. Linting, in some cases, can highlight even the bad coding practices. So the code may work, it may render in a browser, but if it's bad coding practice that you're developing, then linting can help in that area. There are also validators for CSS. So testing HTML and CSS together is really just a matter of checking to make sure that the code is well formed and it doesn't contain any syntax errors. That includes things like closing tags, apostrophes, missing semicolons, and those kinds of things. Now, there are some text editors out there like Atom that has excellent features for testing HTML and CSS together. These huge developer IDEs do have testing facilities already built into them. Now, for JavaScript, there's a lot of help out there. There's things like JSLint and JSHint. These are well-known testing tools. But again, the developer tools in browsers like Chrome, Firebug in Firefox, and even in Edge, these tools do have a lot of capability to test JavaScript along with HTML and CSS. Now, cross-browser testing is important because even though all of the modern browsers do conform to the W3C specifications, there might be slight differences. So it's a good idea to cross-browser checking. In terms of automated testing, well, there is, apart from the major IDEs that I mentioned before, there is something out there called Selenium. And Selenium is an open source test automation framework built especially for web applications. Now, I will say that that particular software does require a little bit of programming knowledge. Now, usually after development is complete, developers may need to clean up their code. They may need to work on the finished code and get it ready for transfer into the production server. So they will need to build their code. They will also need to do testing. And a lot of these tasks can be done automatically. So developers can use build tools to take all of your HTML, JavaScript, and CSS, concatenate them, and minify them. build tools also support unit testing. And whilst developers are testing and building their code, they may need to make changes. And some of these build tools can actually trigger a refresh whenever they see a change happening. Build tools can also automatically inject dependencies into your HTML file. And for example, every time you add a JavaScript file, you may need to include that within the bulk of files that needs to be sent to the server. So all of this stuff can be handled automatically for you with build tools. Now, I'd like to take a moment just to show you the web developer tools in Chrome. So here I have a template website that I used for other courses. And as you can see, the CSS is not even being applied here. So if I hit F12 on my keyboard, I'm able to get to those developer tools. And already we see that it's telling me that something is happening. It's not finding a particular file. And it really is this easy to use Chrome developer tools, or in fact, any developer tools in any modern browser. So just to show you how easy this is, I can go to sources, look at my index HTML file. I can even go to elements and look at the file itself. I can move into the head itself. And here I see that SS style was not found. So I did this on purpose. And all I have to do is double click in this area, add my S. And now as you can see, immediately the CSS file has been found. And the HTML document looks a lot more prettier. So developer tools is a true friend when it comes to developing the front end part of your web application. In this exercise, you will give examples of how you will apply the following HTTP verbs: get, delete, and put. Now I'd like you to pause the video and think about your answers. Think about how you will apply these particular verbs in an HTTP URL. Then come back to the video, start the video again to see how I would interpret these particular HTTP verbs. So the first verb that we're going to consider is the get verb. And get is actually passed to just about every URL that we put into our browser. So for example, if you went to skillsoft.com, then the HTTP verb that is passed by default without you probably even knowing it is the get verb. And that simply returns a resource. It could be an HTML document, it could be an image, it could be audio files, it could be video files. So basically, get will return a resource from a URL like the example shown here. The thing is, whenever we enter something like this into the browser, it depends on the API and how that API was programmed on the server side. So in this case here, in our example, we may get back in our browser a list of all of the blue widgets, because that may be how the API was programmed. Now it's possible for you to get a particular widget, but then we would have to add on to this URL a few more parameters. Let's take a look now at delete. Just like the word suggests, delete, the verb delete, will delete a resource from, for example, an inventory. Think of deleting a row in a table. So for example, we could have the exact same URL again, but this time the HTTP verb delete will be sent along with the URL request. So again, a delete will, in this example, delete all of the blue widgets. Again, it all depends on how the API was programmed. But most likely, it will be deleting all of the blue widgets in a collection of widgets. Now we'll look at put, and put might be considered to be the opposite of delete. In this case, we are adding a row to a table. We are adding a new resource to a collection, or we are absolutely creating a brand new resource from scratch. And again, the example shows the exact same URL. However, it is up to the software that we're using to pass along the HTTP verb put. Then the APIs will interpret that put, and in this case, we may add a new blue widget to the collection of widgets that we already have. Now, there are several more HTTP verbs to consider, of course. However, these are some of the main ones that you would be using on an everyday basis. In this demonstration, I'm going to install Node.js on an Ubuntu system. Right now, I'm on the Ubuntu web desktop, and I'm going to open up a terminal by simply clicking on the terminal icon. I'll maximize this window, and well, for this install, the first thing we want to do is make sure that curl is installed. Curl is an application. It's actually a URL transfer library. It's a command line tool, and we use curl for accessing common internet protocols like HTTP, HTTPS, FTP, etc. So let's now go ahead and make sure that curl is installed. So the first command that I'm going to run is a sudo command apt install curl. I'll have to pass in my password, and the Ubuntu system will attempt to install curl. Now obviously I have already installed curl, so it didn't go out and do much. Now that I have curl installed, I'm going to use it to install Node.js. Now I already have the URL in memory, so I'm simply going to paste it into the terminal window. Now notice it's very long and complicated. So once I've got this URL in place and I've got it should be sudo curl, let's hit the enter key, and it's going to go ahead and install Node.js, the latest stable version of Node.js. At this point, I'm going to pause the video while the software is installed, and I'll return to the video once it's completed. So now that the installation is complete, I'm going to issue the clear command, and I'm going to check the versions. So let's do node-v. That should tell me that I've installed Node version 10.10. Oh, this installation of Node would have installed npm as well, Node Package Manager. So let's check that as well, npm v, and we see that it is, or it has been installed. Again, once the installation is complete, we can actually test out or try to start the application. So we can do something like this. Actually, it's sudo node. And once we get a return, like the debugger is listening on this particular port, then we know that our installation was successful. In this demonstration, I'm going to use the CLI, the command line interface, to ask my Node.js server to serve up a file that I have in a directory stored somewhere. So the first thing that I'm going to do is cd into that directory where I have my stored file. So here I have issued the cd command that will take me into the documents and then node files. I hit the enter key at this point where I can get into my node files. Once I'm there, I'll issue the ls command to look at all of the files that I have in that directory. The file that I'm interested in is HTTP server, and I'm going to use gedit to take a look at that file. In fact, we can use gedit to edit the file as well. So let's do gedit, and we will take a look at this file now. When you work with Node.js, you're going to be working with packages. The package that is going to be required for this particular activity is the HTTP package. So that's our first const. It's requiring that we include the HTTP package. The next two consts are simply telling, we're going to be using these two constants to tell our application where to find our file and which port to use. The fourth const is the interesting one. Here we are actually creating an HTTP server. We're going to be calling it as a server, and we're also going to be passing to that constructor method of that object, of that class. We're going to be passing to it a function that is going to handle requests and responses. Basically, we're going to be handling a response in this case. We are simply going to be writing out 200, which is okay, meaning that once you get to this point, you have not experienced an error. The type, of course, is going to be plain text, and the line next to that is what exactly is going to appear in that browser. It's a simple textual line saying hello Skillsoft. Finally, we are going to end this part of the application. The very last line is using that same server object that we created before and calling upon the listen method we'll be passing to that method the local host and 8000. Those are the address and port that we are going to be listening for any activity, any hits for this file. So that's our application. That's our file, our HTTP server.js file. Let's close this up now, and we will be back to the point where we were at that location, where the HTTP server.js file is. So once we're here, we're going to ask the CLI to serve that particular file. So that is as simple as sudo and node along with the name of the file. And that's it. I'll hit the enter key at this point, and it is going to start serving our file. Notice that I did not get any kind of feedback, and that's okay. I could have added a couple more lines in that JS file to give me some feedback, but this is a very simple demonstration. So remember, our file is being served a particular address and a particular port. So all I really have to do now is open up a browser, any browser, and navigate to that port, that location. So go to localhost and the port number. Remember, it's 8000. Hit the enter key, and what we get back is hello Skillsoft. So that's exactly what we had asked the Node.js server to serve. I'm just going to close this up, and back on the terminal window, I'll just issue a Control+C to close that particular service. So hopefully you see how easy it is to serve files using Node.js. In this demonstration, we're going to work with npm packages, Node Packet Manager packages. I'm going to choose a particular package and see how we can apply that in a situation. The package that I've chosen to show as an example is called Chalk. Chalk works with the console output. So we can mark up that console output using Chalk. And we may use that for various error messages and things like that. So the first thing that I'm going to do is make sure that Chalk is not already installed. Now, if I issued a command like npm list G, what I'm going to get back is a very long list of all of the various packages that are installed. That's not what we want. What I want to do instead is npm list Chalk. So I want to make sure that Chalk is not already installed, and it's not. So let's go ahead now and install Chalk. Now notice that I'm in a directory that I have all of my temporary files, the files that I'm working on for these courses. So npm install Chalk is all it would take for me to install this particular package. And as you can see there, it does say that added one package. We'll ignore the warnings and things like that for now. I'm going to issue a clear to get back an NP screen, and I'm going to now do a check for that Chalk. So npm list Chalk, and now we should see that that particular package open up or showing up on the window. So in order to work with Chalk, we're going to need a JavaScript file, and then we will run that file using Node. So let's go ahead now and create a file. I'm going to use touch, and let's call it chalk test.js. Now if I do an ls, I should see chalk test.js, and I do see it. Let's now use gedit to open that file, and so we can start writing our code. Now the first line of code that I'm going to write is a const. So let's use const chalk is equal to require, and then we will require that package that we just installed, which is called Chalk. Once we have that in place, we can go ahead and do something like console.log, and here we can define or use our Chalk object. Let's say we want it to be red, and within those the parameter that I'm going to pass to this red method is, well, let's first of all skip a line with \n and then the word Skillsoft. I'm going to do a \n again. And I believe that's all I need. Let's go ahead and save this file now. Head back over to the terminal window. And I'm going to have to issue a Control-C here. And now that I'm back to the prompt, I can now do something like node and chalk.js. If I hit the Enter key, there you see Skillsoft all decked out in red. Let's do something a little bit more. I'm going to use the up arrow on my keyboard to get back to that gedit command. I'll hit the Enter key, and I am back to my file, my JavaScript file. Well, let's copy the first line, or the line above, and I am going to make some changes to that line. So Skillsoft is going to be in red. And let's see what I'm going to do next. I'm going to remove this \n. And what I'm going to do is use the concatenation character and do another chalk. And let's do blue in this case. And I'm going to pass something else to this, the blue function. And it is going to be something like Skillsoft rocks or something like that. Now I'm going to do another \n here. I'm going to save this file, head back over to the terminal window, Control-C, and I'm going to use my up arrow again on the keyboard to invoke our JavaScript file. And there we see Skillsoft rocks. Of course, I forgot to put a space there. As a matter of fact, we could actually do things like themes. So let's get back into the file again. And what I'm going to do next is sort of declare or define a theme. So I'm going to use a const. Let's say error is equal to chalk.bold.red. So I've just defined a theme. And then I can use that theme. So I'm just going to copy what I had before, paste it. And now instead of just using chalk.red or something like that, I can now say error. So let's go with error. Something like this. I will save those changes. Okay, that's fine for now. Let's head back over to our terminal window. Control-C again. Then I'm going to use my up arrow to run that file. And seems like we have an issue. So I must have forgotten a closing parenthesis. So let's go back into that file again. And let's close that up. Let's save that file. Back on the terminal window. And let's run our file again. And there you see it is bold and it is red. And all I did was use theme, in this case, error. In this way, we will use there are tons of different packages available on the NPM website. So you're definitely encouraged to use them as you need them. In this demonstration, I'm going to create a Node.js server. However, I'm going to use that server to serve up a static HTML web page and show you how that's done. Once again, I'm on Ubuntu and I'm at the command prompt of our terminal window. However, I need to go into the file system first just to show you how those files are structured. So let's maximize my file system window. I'm going to go into documents where my files are for this series of videos. And there's my HTTP server. And I'm going to open that up with gedit, which is part of the Ubuntu installation. So as you can see, I am installing a couple of different packages. The first you've probably seen before in another video. That's our HTTP object that is going to provide the service for us. However, because I am reading a file on our file system, I need the file system object as well. So I'm going to include that package. The next two constants you've seen before, host name and port, simply has or stores the values of our local host and the port that we're going to be serving from. That file system does have a read file method. To that method, I'm going to pass a couple of different things. First is the location of the document that we're going to be using or reading. And secondly, the function itself will have two parameters, the error object, as well as the HTML, sort of like the content holder or the placeholder for all of the content that is going to be read from index.html file. Once we have that in place, we can go ahead and create the server, which we've done before. The create server constructor method will take a function with the request and response parameters. The response.write header this time, if you notice, the content type has changed. Before it was text, plain text. On this occasion, because we are reading HTML, I have decided to change it to text and HTML. Now, once we have our server going, it will write whatever content that was read into the HTML content. Then we will end this part of the code and we will attach the listen method of the server object to the server object itself. Now, before I had listen on a separate line. I've decided to concatenate the listen method to our server object immediately. So I save some space, as well as I can pass now the port and the host name, as well as a Lambda expression. This Lambda expression will send out to the console the fact that we are serving a web page and it's going to be at localhost and the port is going to be 8000. Now, once I have all of this in place, well, actually, before we go on, let's just take a look at the file itself, which is index.html file. I'm going to open that up with gedit. As you can see, it's just a plain old HTML file, nothing fancy about it. Great. Now we have all of this in place. I can head back over to my terminal window. And at this point, because I have everything located at node files, all I really have to do is start up our server. So node and the name of our file. And as you can see, I am now getting feedback, which is great. So I know as a developer that my page is located at localhost and the port is 8000. So all I need to do now is open up a browser and navigate to localhost and give it my port number and hit the enter key. I should see the HTML file that I wanted to serve. So it is this easy to serve static HTML files using Node.js. In this video, we're going to do an examination of MongoDB. MongoDB is part of that NoSQL type of databases. Traditional databases work on the principle of tables, data sets, relationships, and they all connected together with SQL. NoSQL work on the principle of collections and documents. So essentially, there's no schema involved with MongoDB or any of these NoSQL types of databases. MongoDB is backed by a large corporation, but it's also open source, and it works on most platforms. Because MongoDB is document-oriented and it uses JSON-like documents instead of a schema, it is said to be a little bit more intuitive. This type of database, MongoDB, in fact, has a smart distributed system where data is stored and retrieved from strategic locations. This means that availability is a little bit better, workload isolation is possible, scalability is better, and we have the concept of data locality. MongoDB can also be installed in the cloud, in a mainframe, or in a client-server architecture. But wherever it is installed, the performance will be the same, regardless of where it's operating from and on which platform it's operating from. So they essentially promote consistency over availability. In terms of its architecture, well, MongoDB is it has a flexible data model, which means that we can work with data in a natural, intuitive way. This gives us great performance without a lot of work, and we can adapt and make changes very quickly. It's versatile, meaning that it supports a wide variety of data queries. I mentioned before storage, and I'm going to talk about smart storage now, which means that we can insert data on specific devices in specific geographic regions, and we do this for easy administration. In this way, we can control the class of service as well as something called low latency access. MongoDB can grow horizontally through something they call native sharding. We can even run operational and analytical workloads in the same cluster. It also has a sophisticated replication feature, and it has some self-healing recovery features. MongoDB is quite portable. It's touted as the database that runs the same everywhere. It's cloud agnostic, and there's no dependency to any specific vendor. So just like a traditional database, we do have those CRUD operations with MongoDB. So a create or an insert operation will add a new document to a collection. And it'll do that even if the collection does not already exist. And for this, there are two methods available. I have one listed here, the DB collection insert one, but there's another method called the DB collection insert many. We should note that all write operations in MongoDB are atomic, meaning that the change either happened or did not happen. In terms of read operations, well, there's just one main read operation, which is the DB collection find. So as with traditional databases, it is possible to specify query filters and create or criteria within that collection.find method. In terms of changing and updating operations, there are three main methods. I've just listed one here, but there's also update many and a replace one. In MongoDB, update operations target a single collection. Like change operations, all write operations in MongoDB are atomic as well. Developers can also specify criteria and filters and all that good stuff as in a traditional database. Now, in terms of delete, well, of course, we can delete documents from a collection. I have just listed one method here, but there are two more for handling things like single deletes and multiple deletes and that sort of thing. So MongoDB is not very different from traditional databases, but at least we don't have that SQL to worry about. In this demonstration, I'm going to install MongoDB on my Ubuntu 16.0 system. Now, the thing is, I've already installed the software, so what I'm going to be going through now are the steps that are required in order to install the software. So the responses that I'm going to be getting back in my terminal may be different from if I was doing this, doing a fresh install. So the first thing we want to do is import the GPK key from MongoDB apt repository, and we do this in order to test packages prior to installation. Because these commands are so long, what I'm going to be doing a lot is copying and pasting. Of course, you can get all of this information from the MongoDB website. So let's go ahead now and add or import the GPK key. And again, the response that I'm going to be getting back is the fact that it's already there. Nevertheless, that would be step one that you would do if you were doing a complete fresh install. The second option would be adding the MongoDB apt repository URL to our Ubuntu system. Usually, this stores in etc app sources.list.d/mongodb.list. Also, if you were doing this for Ubuntu 18, this particular line would be different. So please refer to the MongoDB website for this. So I'm going to hit the enter key there, and we get our response. Now at this point, it is a good idea to do a sudo apt update just to update our system. I'm going to pause the video while this is working. Okay, so that's done. The next step then would be to install MongoDB itself. So that would be sudo apt install MongoDB org. Hit the enter key. I misspelled apt, so it's A-P-T. Hit the enter key, and we will proceed to install. Again, I'll pause the video. MongoDB is now installed. It is going to run as a service. So I'll issue a clear command here, just so that we can have ourselves a fresh screen. So at this point, it is a good idea to check the version. And we see that we have version 4 installed. Great. So now what we need to do is check our, or at least check the service, start up the service. So sudo Mongo should give us the prompt. Now, if you did get this particular error, it is possible that we did not create a directory to store our databases. So let's go ahead and do that now. So this is the command that you would want to type in at this point. You would make a directory and /data/db. Let's hit the enter key to create that particular folder, that directory. The next command is going to change the ownership of that directory. So chown id-u and the name of your directory. Now let's try that command again. I'm going to use the up arrow on my keyboard to see if I can get back to sudo mongo. Hit the enter key. Let's try sudo mongod instead of just mongo. Hit the enter key, and what we should get back is our service started. But what's going to happen is that the service is going to run in this window. What we need to do is start up a second window and new terminal. And what we could do at this point is attempt to log in again. So in this case, let's do sudo mongo, and that should get us to our prompt. Once we're at that prompt, we can type in just db, hit the enter key, and that should tell us that we are currently in the test database. That's the standard database that comes with all of the MongoDB install. So I'll hit Control-C to get out of that terminal window. And at this point in time, we can stop the service, we can restart it, etc. So that's how we would install MongoDB. In this demonstration, I'm going to create a database, and then I'm going to add a document to that database. So basically, we say that we're adding a collection, and then we're going to add a document to that collection using MongoDB, of course. So let's first of all get into MongoDB. So if you remember, it is sudo mongo. That gets us into the MongoDB prompt. Let's issue a CLS command so that we head back up to the top of the screen. Now I'm going to add a database, and it really is as simple as saying use contacts, hit the enter key. Now I have just created a database called contacts. It is that simple. Now that I'm already in contacts, in order to create a collection, I would issue the command db.create collection and simply pass the name of that collection. So let's go with my contacts. Hit the enter key, and I get an OK, meaning that the collection is now there. So if I were to show collections, I should see my contacts in there. At this point, let's create a record. In this case, we'll say we're adding a document. Now, adding a document is a little bit tricky in that it's kind of difficult to type in the terminal window itself. So what I've done is I've created my contact, the record that I want to insert, or the document. I've created that in Notepad, and I'm simply going to paste it in this terminal window. So let's paste that document, and let's take a look at it. We see that we have a name. What we're looking at is very much like a JSON object in that we have name-value pairs. So we've got a name, email, and cellular phone number. But take a look at ref. Ref is another name that has a value that looks itself like an object. So in other words, we can create objects within objects. That's the freedom that we have using MongoDB. So let's go ahead now and hit the enter key so that we can insert this document. Now that I have that document in there, let's go ahead and find it. So let's issue the find method. So that'll be db and my contacts dot find. It's a function or method. Let's use those parentheses, hit the enter key, and there is our object or our document. Now there is another command, another way to do this, in that we can use this pretty function at the end of our find, and that gives us a better looking, more JSON-like object. Now take a look at the very first line. We never inserted that. This is how MongoDB keeps track of the documents in its collection. It would insert that ID automatically. So that's how easy it is to work with MongoDB. In fact, what I'm going to do now is show you how easy it is to edit this one document that we have. Now again, I have done this in memory because typing in terminal window is a little bit difficult. So in my computer's memory, I've got the change that I want to make. And if we look at this change, it's the update method that I'm using. So I'm using the update method. And if we're going to be updating a record, we have to use set to the field that we want to change. So in other words, we're saying, let's set our cell phone number to be 7899 instead of the 0 that we had before. So let's go ahead now and run this. And we have a right result of 1 updated. So we can look at that record again. So we will find it again. And this time it should show us that record has been changed, that the cell phone number has been changed. So that's how easy it is to work with MongoDB. In this video, we're going to look at some of the features and benefits of using a version control system like Git. So Git is something that you would need to consider if you are going to become a full stack developer. Because as you start a project, that project doesn't just sit there. It actually changes as time. You're going to be making updates, you're going to be making code corrections and things like that. So as your code begins to grow, and if you follow in an agile development methodology, then a version control system is absolutely essential for keeping track of things and, of course, becoming a more efficient developer. So Git is a version control system. It is a distributed system. And what that means is that the entire application is kept locally, and it is only updated with some central server whenever that is required. So distributed systems make it easy to work locally and even offline. And when you need to sync up, then you connect to the central server. It is an open source system, and it is supported by a community, and that makes getting help with Git very easy. In fact, a lot of open source development environments do have plugins for Git. So why should you use Git? Well, like I said before, Git is a repository. It's like a virtual hard drive where a project can be stored. So it stores records and all of the various versions of that software. And of course, you can retrieve any version at any time. Git keeps a record of all changes in every file, and it will go back several years, well, depending on whenever the project started. So Git will know about the creation and deletion of all files, as well as changes to the contents of those files. Now, with all of this tracking going on, it means that each change can be traced. In fact, Git can be incorporated into a project management software, and that's done for easy tracking, of course. So as changes are made, developers are forced to explain them, and this helps with future analysis of the application. Now, as a full stack developer, you might be thinking, well, okay, you're sort of like a lone ranger, you're working by yourself, but Git actually helps when it comes to working with a team. So Git allows team members to work and collaborate on a project. Developers or teams can create branches and work independently on those branches. So they're independent other people that are working on this project. However, at some point in time, those changes have to be merged. Git is also good at ensuring that conflicts do not appear or do not occur during the development process. Git is also very versatile. So since Git is decentralized, releases do not have to wait until some final point. There can be incremental releases. So multiple marketing campaigns can be done rather than just one campaign. The more frequent releases mean better customer feedback and faster updates as well. So a prototype can be sent to a customer almost as soon as the developers complete the code on some branch. So as new features are added to a product, a special branch can be created for that feature only. And of course, this gives the company flexibility in marketing a release. And it is also possible that some features can be left out of this release, but be ready for the next one. So you can see how product management can take advantage of Git. Feature branches also mean that designers have a product to experiment with. Designers can try out changes in a real working copy of the product without the threat of breaking the existing functionality of the system. Customers can report bugs, meaning that code can be fixed faster with Git. Now, as a side benefit, HR, human resources, would rather hire someone with Git on their resume than some other candidate. So, in other words, there's a competitive advantage to the employer to hire someone with Git. So, of course, there are other repositories out there, but Git has become sort of like the de facto product that everyone uses. In this video, I'm going to do an overview of GitHub. We'll take a look at some of the features of GitHub. GitHub is basically a developer's platform or a development platform that supports developer workflow. And just about anybody can host and review code, manage projects, and build software on the website. In a previous video, I talked about Git. So basically, your Git project can be hosted on GitHub. So obviously, GitHub can facilitate collaboration amongst developers. In fact, developers use it to share ideas, to make pull requests, perform reviews, and of course, they learn from each other. The site offers the ability to organize and manage and track projects using tools that focus on specific issues or specific pull requests. In fact, there's easy integration with other software or other platforms like Jira. So I mentioned that there are a lot of tools on GitHub, and it's really too much to go into. But for example, there's a tool called Greenkeeper. So what does Greenkeeper do? Well, it facilitates what's called real-time monitoring of any NPM or Node Project Manager dependencies that were added to your project. So in other words, this software uses a bot. It'll check for any changes and updates to those dependencies, and it will send the developer, or if you're a subscriber to this service, it'll send you an email telling you that something has changed. In this way, you can keep your project up to date. There are several features to GitHub, but let's take a look at some of the more important ones. And definitely collaboration is a big issue. So GitHub has built-in tools that make collaboration and code review useful and beneficial. So in other words, this is like peer review. There are lots of project management tools. Obviously, you want to keep your project in good condition. So these project tools use things like cards and notes and milestones. So for example, a card will document any issues on the project, and it'll also document any pull requests for your project. There's also a notes tool, and that notes tool will document ideas for the project. Some of those ideas may make it on to the next stage, or they may not. The idea is to keep track of them. Milestones will help organize and track the progress within the project. The assignees become owners of pieces of the project, so everybody knows who is working on what part of the project. So hopefully you can see how useful GitHub can be in your own project. But GitHub is not the only platform out there. There's also GitLab. GitLab is a platform for project planning and source management. It handles continuous integration and continuous development. GitLab facilitates concurrent DevOps, which means that they try to eliminate the traditional lifecycle and sort of blend all of those steps into one seamless project, making it easy. GitLab is able to do this by shortening your DevOps cycle time. So what they do is they bridge silos and stages, basically automating tasks that are normally done manually. So there's a more fluid workflow that tries to remove barriers from normally separate activities, like, for example, security testing that used to be a separate issue, but we can blend it all together now using GitLab. There's another platform out there called Bitbucket, and it's very much a repository like GitHub. In fact, Bitbucket can also store Git code. Remember in a previous video I talked about Git. Bitbucket is commonly used with Jira and Trello, which basically are used to track issues in a project. Of course, continuous integration is also built into Bitbucket. So all of these different platforms help developers keep on track and manage their projects more efficiently. And of course, there's the collaboration issue, which is extremely important in these types of platforms. In this exercise, you're going to work with the Node Package Manager. You're going to use npm to install a package called request. You will then create a JavaScript file to implement that request module. In fact, you're going to use the file to capture contents of the Skillsoft's homepage. Once you have that content, you're going to display the content in the terminal window. Now, of course, this exercise may involve some research into the module, the request package, but definitely do some research, complete the exercise, and pause the video while you're doing this. Once you're done with the exercise, you can return to the video and see how I would approach this particular problem. I'm on a Linux machine, and in order to complete this exercise, I'm going to have to go to the folder where I have, the directory in this case, where I have all of the files for this video series. So now that I'm at this directory, I can use sudo npm install and the name of the package, which is request. Hit the enter key. It'll ask me for my password, which I've just entered, and it should install that file for me. Now, it didn't install the package because I already had it installed. However, it did update the package. The idea is that once we have that package installed, now we simply go ahead and create a file in order to use the package. So I'm going to use a file called, let's see, get html.js. So just get HTML, I suppose. I'll hit the enter key and just make sure the file is created. So I'll issue the ls command. And let's see, we've got get html.js there. So I'm going to use gedit to open that file and start writing the code in order to use this request module. Now, I will admit some of this code is a bit complicated. So what I'm going to do is simply copy and paste from code that I already have. So the first thing that we're going to be doing is requesting the request object. The second thing that I've done here is to, of course, request or use the request object to grab the contents from skillsoft.com. Along with that request function, I have to pass an inner function that in itself takes 3 parameters. This is standard. Of course, whatever content that we get will be loaded into the body variable in this case, or parameter. So we will simply issue that out to the console window. And this is all we really need for this request module. I'm going to save everything, and I'll close up my gedit window. I'm back now on the terminal window. So now that we have all of that, all I have to do is call upon my file, hit the enter key, and if everything goes well, we should see the entire content of the Skillsoft website onto our terminal window. So there you go. This is using another module, another package from the npm website. In this demonstration, we're going to install a few things. First, we'll install Express. Express is a Node.js web application framework that contains a lot of features for web and mobile applications. For example, it has several HTTP utility methods and a middleware that help developers create APIs quickly and easily. We will also install Body Parser. Now, Body Parser is a plugin for Express. It's not necessarily for Node. Express is a plugin for Node. You can consider it to be that. So with Body Parser, developers are able to use it in order to capture data that has been posted from an HTML form. So basically, it will parse the HTML document or the form or whatever is being sent to the server application, and we are able to work with the individual parts of that data that has been sent. The last thing that we're going to be doing is installing a REST client for Firefox. And then in my case here, I'm using Firefox along with Ubuntu. What this REST client will do is that it will allow me to test out my application. It allows me to select one of those HTTP methods, those HTTP verbs, and test those verbs out against my API should I go ahead and develop one. So let's start with Express. Now I've already created a directory for my application, and I'm going to cd into that directory now. I hit the Enter key and I'm at Node Files directory. What I want to do now is sudo npm issue an init command. I'll hit the Enter key. It'll ask for my password. So at this point here, it will ask me a few questions. So for example, the package name. I'm just going to hit enter on some of these questions because I just want to accept the default. Now, at this point here, it's noticed that I have an http server.js file in my node files directory. So it's asking me if I want to use that as the entry point. If I did not have a file there, it would suggest index.js or something similar. I'm going to hit enter to accept that. There's no test command. There's no git repository. There are no keywords. If you wish, you can put in your author's name here. And I'm just going to skip through all of this, and it finally wrote out a package.json file for me, and it's asking me if this is okay. So I'm going to hit OK. I'm going to hit the Enter key to accept the changes, and I'm back at the Ubuntu prompt. I'm going to issue a clear command here to head back up to the top of the screen, and now I'm going to do an install of Express. So it's npm install Express, express, and I am going to go with a save. In this case, I'll hit the Enter key, and it's going to install Express for me. And it has already done so. It is kind of quick because I had installed it before and then removed it. Now I'm going to install body parser. So again, it's sudo npm body parser. I'll hit the Enter key. And I believe I misspelled sudo. So it's sudo. It will install body parser for me. Now that I have those two facilities installed, I'm going to head over to my Firefox browser, which I happen to be using on this machine. And I'm going to install the plugin, which is the REST plugin. So the first thing that I'm going to do is head over to this little icon here. And if we go down, we will see add-ons and preferences and that kind of thing. I'm going to click on add-ons. And as you can see, I've already installed the REST client here. However, if you did not do that, then simply search in the search bar here at the top right of the screen, search for whatever you want. So in this case, I'm entering a REST client. I'll hit the Enter key, and it will search for REST client. At this point, all you need to do is click on it, assuming that's the one that you need. And because it's already installed, I only have an option to remove it. Otherwise, you would have an option to install it. So now I have installed everything that I need to create or start creating APIs. In this demonstration, I'm going to build a very simple API. It's an API that's going to handle a POST request. Of course, I'm going to be using Node.js, and as you can see, I'm on an Ubuntu system. I've already navigated to the folder where I have all of my files for this video series. I'm going to issue an ls command just to show you that I have my server file already written. What we're going to be doing is using gedit to check that file. So it's http _. Let's take a look at that file. It has a few things in it. First of all, there's body parser. Body parser is middleware for Express. It basically is going to allow me to take a name value pair, split it up, and then work with each name and each value individually. Of course, I'm using a framework, Express in this case, because Express has all of these various methods that align exactly with the URL verbs. So in this case, I'm writing an API for a POST request. So the Express object allows me to use the POST method. Within that method, I do have my endpoint, and within that endpoint, I am again parsing the body the HTML body that's coming from the browser, and I'm able to now use the individual pieces of that data. I'm doing a couple of things with the data. I'm sending it out to the log. That's just because for demonstration purposes. But the next line is where I'm taking those two values and actually inserting it, and then that entire sentence will be sent back to the client that is requesting this post, which happens to be a plugin for Firefox. But I'll get to that in a moment. But this is as simple as it gets. This is a very simple API. What I have to do now to run this API is head back over to my terminal window. I'm going to issue a Control-C command to close my gedit, and I'm also now going to start up my server. So it's Node. I will get some feedback once I hit the Enter key. It's going to say that it's running on port 8000, which is great. Now what I want to do is head over to my browser and navigate to that particular address. So I'll open up Firefox. Now, Firefox, I am also using a client, a REST client, which I've already installed, and it's located here. If I click on this icon, it opens up my REST client, and I can now use this client to access that address that I showed before. Now, remember, it is a POST API, so that's the first thing that I'm going to do. My method is POST. The address is HTTP. If you remember, it's localhost. There is a port, and my endpoint is WEIGHIN. So before I hit the send button, I want to make sure that my headers are fine. Now I've already encoded a particular header here, which is the content type, and I'm going to just choose that now to make sure that this is the headers that is forwarded with my post request. After that, all I really need to do is insert the name value pairs. So if you remember, it is emp name. My API is expecting that name, and the value is going to be Axel in this case. I'm also going to send the weight, and that is going to be 85 kilograms last time I checked. So I believe I have everything that I need. I'm just going to scroll on here a little bit just to show you that there is a curl is also operational in this client, and the response is going to be back on this tab once I issue the post request. So let's go ahead and send. We do have our client running, so that's great. And now I can go ahead and send the request, and I get some feedback. And if I look down here, I see a 200 OK. So that means we've hit the server. And if I look at the response, it says, "Hello, Axel, your weight is 85 kilograms. Great. So we know that that API is working. I also want to take one quick look at the terminal window again to show that, remember, I had coded this for the information to be sent back to the terminal window, and it has done that. So this is how simple it is to start writing APIs using Node.js, Express, and a couple of other technologies. In this demonstration, we are going to establish or provision a MongoDB database. And the way we're going to do that is by using Node, of course, and we will use this file that you're looking at. And for the first part of this demonstration, we're going to be looking at paying close attention to lines 1 to 13. What this is going to do is, first of all, require MongoDB, which is already installed on my machine. And we're going to be using the default URL on line 4. I'm going to create a database on line 6. And then I'm going to establish an object, the mClient object, using our connection. Once I have that object, I can test the connection and then close that connection on line 12. Now, I need to start up my MongoDB service. So for that, I'm going to head over to a terminal window. I'll maximize that terminal window. And the first thing that I'm going to do is navigate to my folder or directory where I have all of these files. Once I'm there, I'm going to hit the Enter key, and now I can start up my service by issuing the sudo mongod command. I'll hit the Enter key. It will ask me for my password, which I'm entering now. Hit the Enter key, and the service is going to start. Now, I need to open up a second terminal window in order to run the file that I just showed you, which is mapp. So I'm going to navigate to that folder again, directory. And once I'm there, I'm going to use Node to start up my mapp file. So I'll hit the Enter key, And I see a success, meaning that I was able to establish a connection to that service. Now what I want to do is add some records. So I'm going to head back over to my file, my mapp file, and I need to reconfigure this part of the code, lines 11 and 12, in order to be able to run the put documents. Now I already have a function called put documents, and I'm going to use that function to write the 3 records that you see on line 21. Now in order to do that, I have to establish a database object. So for that, what I'm going to do is put a comment on the success message because we don't need it. And I'm going to establish another const. And this time I'm going to use my mClient connection, the DB function of that, and I'm going to pass to it the SSWaits, which I established on line 6. Now I have an object that represents the database itself, not just the connection. Once I have that, I can now copy my put documents, and now I can call put documents, and I'm going to be doing 2 things. I'm going to be passing my database object as well as a callback function. That callback function now will be doing the closing of the file for me. So I'm going to remove this line, put it above or within the callback function, and now I can close that up. Well, first of all, I need these and one of those. And once I have all of this, I can now put documents function. The put documents function is very simple. Again, it will accept the database object as well as the callback function. It will establish a collection called documents. It will insert these 3 records. It will issue a log if we are successful. And finally, it will close the connection. So let's save our file, head back over to the terminal window, and let's run our application again. I'll hit the Enter key, and I see that we've inserted 3 records. Let's try to read those records now. I'll head back over to the mapp.js file. Instead of put documents, I'm going to call the get documents function, and that should be able to read all of my documents for me. Let's save that change, head back over to my terminal window, run the application again, and I see that I have my 3 records. So in this way, we can write various methods to work with the NoSQL database like MongoDB. In this demonstration, we'll take a look at routing using Node and using Express. Later on, I will introduce something called Router, which is part of Express, but it makes creating those routes much easier. What we're looking at on the screen, though, is a basic setup. All I have here is the Express module. I'm creating an object out of that and then using the get method in order to serve just 3 words, in this case, 1 line of text. In order to start this server up, I would have to go to my terminal window and start the server using Node and the name of the file. Once I do that, I get some feedback, and I can now go to my Firefox and just go to HTTP localhost and the port that I'm serving on, which is 8000. If I hit the Enter key at this point in time, I should get root being served because that was the message that I caused the server to serve. Now what we're going to be doing is introducing router. So let's first get an instance of router. So we can do something like let router equal. Notice that I'm using Express and not app, and I'm going to access the router constructor. And once I have a router object, I can now replace app with router. Now I have just one more line to write, and that is I'm going to be using the same app object to let it know to use router. So it takes 2 parameters, default route as well as the router object. And that's all I need. I can save these changes. Now I'll go back to my terminal window. Now I did have the original file being served. Let's do a Control-C to stop that and do another node call to the server file. I'll hit the Enter key. Now we're listing on port 8000 again. If I go back to my local host and refresh the page, notice that nothing happens. I get the same message, and that's fine. It just means that we're using router instead of express. Now, I did say that using router makes creating routes easier. So in fact, I can just copy, well, let's copy the comment as well. I'll copy everything from here, and I'm going to paste it underneath. And instead of just the default, I'm going to go to, let's say, About Us. So I've just created another route, and I'm saying instead of root being served, I'm saying About Us is now being served. Now I'll save those changes. Again, I'm going to go back to my terminal window. I'll stop the original service and start it back again. Now, if I went back to my Firefox and I do a / here, About Us, hit the Enter key, now we see we get a different message. Now it's About Us being served. So that's how easy it is to just create new routes. Now I'm going to create yet another route, but show you how we can pass parameters. So let's just say we had a page called products or a route called products, but I wanted to get the product ID. Then I can do something like this. I can say, in this case, it's a parameter, so I use the colon. Product ID is what I'm looking for. Now all I have to do is change my send method to say something like you're viewing product number. And then I'm going to concatenate the fact that we do have a product number to work with. So I'm just going to copy and paste the product ID here. And I'll save all of these changes. The route is products. So if I head back over here and I go to products, and let's say I wanted to view product number 3000, hit the Enter key. Now, I don't get exactly what I was looking for, and that's because I need to change something else here. So it's not just product ID, it's actually request object, and then params, then product ID. So let's save these changes. Let's stop the service and start it back. Now, when I go back here, go to product 3000, now it says you're viewing product number 3000. So the idea here, of course, is that we would have a product page that matches product ID 3000, and the viewer would be seeing that. So that's how easy it is to use routes and to use router to create routes. In this demonstration, we're going to create a MongoDB database, and we will connect it to our API. What we're looking at on the screen is Node.js server file, and between lines, let's say 2 and 7, we've seen some of this code before. So for example, I'm using the express as well as the body parser packages. However, on line number 9, we have not seen this, and what this is doing is it's separating out my database stuff into a different file. And this happens when your application becomes large. So let's take a look at that file. I'm going to head over to my empwaits.js. Once again, I have both of these files opened in gedit, and as you can see, I'm also using Mongoose in my database file. Mongoose is an object data modeling tool or library for MongoDB. It simply makes MongoDB easier to work with. Line number 3 is a connection to the MongoDB database. It's called SSWaits in this case. I have not created that as yet, but it will be created once the file is run. And between lines 4 and 7, we're creating a schema. We're collecting 2 pieces of data, employee's name and the employee's weight. Once we have all of this in place, we can then export the entire structure so that it can be used by the server file. And that's being done on line number 8. So back on the server file, at line number 9, we are requiring that particular JavaScript file, and we're creating an object out of the schema that we defined in the empwaits file. Once we have that, I'm also using a router package because it makes routing very easily. Between lines 13 and 23, we are getting the information from the HTML form, we are then saving that to the database. So lines 14 and 15 will get those values posted. Lines 16 and 17 will apply those values to the database object. And then on line 18 is where we're saving those values to the database. So the save function of the database object, the save method, I should say, is also taking an anonymous function which will generate an error if there is one. So if there's an error, we're going to let the browser know. Other than that, on line 21, we're simply using one of the values that was posted and letting the user know that the record was created. On line 25, we're letting the application know that it should use router for routing purposes. And the rest of it is stuff that we've seen before, the port and that sort of thing. So in order for me to start all of this up, first of all, I have to start up the MongoDB itself. So for that, I'm going to open up a terminal window. I'm going to navigate, which I have in my history. I'm going to be using the up arrow key to head over to where all of my files are located. Then I'm going to issue sudo mongod, which will start up the server. Great. So I can now minimize this window because I no longer need it, but I need to have that database running in order for me to perform the next step. So I'm going to open up my browser this time. Well, I'm going to first of all go to my REST client, which I demonstrated in a previous demonstration. And what we need to do is choose post in terms of our methods. Then our address is going to be localhost, and the port is 8000. And if you remember, let's check it, address is going to be putwait. So let's copy this and paste it on here. Now what I need to do is issue or send to that address some values. So let's go with emp name. It's going to be Axel. And the emp weight is going to be something like, let's say, 88 kilograms. Let's make sure we have a header. I'm going to go with the form URL encoded. And if I hit the send button at this point, I should get back some information. Now, we did get some information saying that the request error without details. Now, that's because I probably did not start up my service. So let's go to a new terminal. I'll navigate to my directory location again and start up our http://js file. So now that we're listening, now we can get to this address. So if I hit send again, I should get a response that everything's okay, and we've created Axel. So how do we verify that Axel has been created? Well, first of all, I'm going to issue a Control-C on my terminal window, and I am going to start up MongoDB. So let's go with sudo mongo, hit the enter key, enter my password, and issue a CLS here. To get to the top of the screen, I'll maximize the window. Now, what I'm going to do is use sswaits, which is the database. Then from there, we can do something like show collections. I see weights in there. So now I can issue another command, db.weights, and try to find all of the records in this database. So if I hit the enter key, we see that Axel has been entered and 88 is the weight. So we know that our API is working all the way through the database. In this demonstration, we're going to expand on an API we created in a previous session, in a previous demonstration. On that occasion, what I did was I created one single route called putweights, and I used that to store two values. I have since removed all of the records from that database, and we're going to start fresh again. Now, I have my database service running, my MongoDB service running, and I have already started up my Node.js file. So what I'm going to do is I'm going to insert a new record. This time we're going to go with Mary. And because I have everything running already, actually, I don't have everything running. So let's start up our Node server again. And if I click on send here, I have my post selected. If I click on send, I'm going into this particular route, and I have my values. So I click on send. I should get back the fact that primary record has been created. Now what we have to do is expand our API to account for the fact that we can now see that record rather than just going through the MongoDB CLI. So it's quite a bit of code. So what I did, I copied it, and now I'm going to paste that code in here. It's like a separate function. Again, it's router.get. We're going to provide a new route, but this time we're going to apply the find function to our wait object. Notice that it's the wait in terms of the file that we are accessing, the wait with an uppercase W, not the lowercase. So with our new route in place, what I can do now is save this file, head back over to my terminal window. Let's close the current session and start up a new one. Now that we're listening, I can head back over to my Firefox. I'll change my post to a get, and I'll change my put waits route to get waits. If I click on send, I should see the record that I just created. Great. So now what we can do is expand our API again. This time we're going to add another route to delete all of the records. So again, I'm going to copy and paste. And with our new route, what we're going to be calling upon is the delete many method. I'm passing it an empty object, meaning that I want everything to be deleted. Other than that, I could have inserted into the curly braces an exact ID of or some kind of criteria in terms of which records I wanted to have deleted. Now, there's also an anonymous function that's going to run at the same time, and that will return two objects, an error object as well as a result object. Notice that I'm returning the result in its entirety, meaning I'm returning the, well, actually, the result is formatted in JSON, and I'm returning the entire object to the browser. Now, with that in place, I'm going to save the changes, head back over to my terminal window. Let's stop the service with Control-C and start it back again with Node. And now that our service is running, I can go back to Firefox, get back into the REST client in this case. This time, instead of get waits, I'm going to delete waits. So let's go with delete waits. It's a get request. I'll hit on send, and I should get back the JSON object that I mentioned before, meaning that one record has been deleted. Let's see. If I try to get waits again, I should get back an empty object. So let's send that. And what I get back, let's see here. Maybe I spelled it incorrectly. Get waits. So get waits, click on send. I should get back an empty object, meaning that we have deleted all of the records in that file. So let's head back over to our editor again, our gedit. And as you can see now, I have 3 routes, and they're doing 3 different things here. So in this way, we can expand our API, for example, get a specific record or delete a specific record. And in this case, we can have a full functioning API. In this demonstration, I'm going to discuss package.json. Package.json is used to manage Node.js application modules. However, it is also used to manage dependencies for your application, I mean. Package.json actually makes Node.js applications modular. So what I'm going to do now is create a folder. So that's as simple as sudo make directory and the name of my folder or directory. Let's call it node files. I'll hit the enter key, and now I should have that folder created. Let's find out. Let's issue an ls command, and we see node files there. So let's navigate now to node files. And once I'm there, I'll issue another ls to make sure there's nothing there. However, I want to give permission for myself in this directory. So I'm going to issue the Linux command sudo chown -r, and admin2 is my username on this directory, and I'm going to give it access to the entire directory. So I'll hit the enter key at this point, and I should have access. Now, what I want to do is create my package.json file. And in order to do that, now I could do it manually if I wanted to, but let's go with npm init. I'll hit the enter key, and it's going to ask me a few questions. For example, it's asking me what is the package name. So I'm okay with Node. By the way, it will make suggestions. Like in this case, it's suggesting that our package be called Node files. And I'm okay with that. I'm going to hit the enter key. It's going to suggest a version for me. I'll hit the enter key again to accept the default 1.0.0. The description, this could be my video files, for example. I'll hit the enter key to accept that. Now, it's suggesting that I do an entry point of index.js. This is the first file that Node is going to run when you issue the command node and then the name of your file. Now, throughout the series, I've been using http:/server.js. So I'm going to overwrite the index.js in this case by entering my own the name of the file that I want to use. So I hit the enter key. I don't have any tests to be running on this application, so I'll hit the enter key to accept the default. There is no Git repository either, so I'll hit the enter key there again. Keywords is what other people will use to find your application. So because this is just a demonstration, I'm not going to enter any keywords here. I'll hit the enter key, and the author is going to be myself. Once I do that, I'll hit the enter key again. I'll accept the default license. There are quite a few different licenses you can research and figure out which one you want to use. But in this case, ISC is fine. So I'll hit the enter key there. And there is my file. There is my package.json file. I'm going to issue or type yes to accept what I'm seeing on the screen. I'll hit the enter key. And it seems that my package.json is created. Let's do an ls to see if it's there. It is there. And what we can do is use gedit to take a look at it. So gedit JSON, and there is the file. Now, let's just say that I wanted to add dependency here. So for example, I wanted to install React. So I can use my npm to install React. I'll hit the enter key to accept those defaults, and it will install React for me. Now, if I take a look at the JSON object again, or the JSON package, the package.json file, I'll use my up arrow to use gedit. I'll hit the enter key. Now let's see what has changed. Look at lines 11 to 12. That was not there before. Because I installed React, the package.json file has changed to indicate that I'm now using a dependency. So every time we add a new package, the package.json file will change appropriately. So in this way, we can keep track of everything, or all of the dependencies and all of the modules that we're using in our application. In this demonstration, we're going to set up our environment to run unit tests for our Node.js applications. Now, I'm starting out with a completely blank folder directory. It's Node files. However, if I issue an ls command here, you'll see that there's nothing in here. The first thing I want to do then is run npm init so that I can have a JSON file available. So I'll just accept all of the default values they provide for me, and in the end, I will accept what I've been given. And let's run an ls again to make sure that I have my package.json file. I'll issue a clear command here, so we start at the top of the screen. Now, Node.js does come with quite a lot of testing functionality. However, we're going to be using a couple of different packages that tends to be a little bit easier when it comes to running unit tests, at least for JavaScript files, and it should be for Node as well. So what I'm going to do is install two different packages. Well, actually, before I do that, let's take a look at our package.json file. So again, just open up my file system. There's my Node files directory. If I double click on it, we should see the package.json file, which remember I just got because I ran npm init. I'm going to right click on the package.json file. I'm going to open it up with gedit. And if you notice, it's a very simple file. I remember I accepted all of the default values. I'm going to leave that there for now. I am going to now do an npm install. And of course, I'll save this. And I'm going to install Mocha as well as Chai. I'll hit the enter key, and it's going to install these packages for me. Now, Mocha is going to look inside of a folder called test, and whatever JavaScript files it sees there, it's going to assume that those files have test functionality in them, and it's going to try to run those tests. So what I have to do now is make a directory called test, and within that folder, I'm going to create another file called test.js. So let's go with touch. The folder is test, and the file that I want to create is test.js. Hit the enter key, and what I'm going to do now is open up my file system again. I'm going to make sure I have that test folder. If I double click on it, I have my test.js file, which I'm now going to open up with gedit. Now, before I begin filling out what I need to fill out in test.js, I'm going to head back over to my file system. I'm going to roll back to the application folder itself, and I'm going to create another file in here that I'm going to insert a function on. I'm going to use that function to test the functionality of that function. So now I'm on the root folder in my terminal window. So let's do a touch. I'm going to call my file, let's see, adding. As you can imagine, it's going to be a very simple file. Once I have that, I'm going to head back over to my file system. My adding is there. I'll open that up with gedit. And I have some code that I'm going to paste in here. So let's paste a simple function that's called addUpNumbers. As you can see, it takes 2 parameters, and it returns the sum of both of them. Let's export that so it can be used in test. Now for test, I'm going to again paste some code because it's quite a lot of code. Let's just analyze it a little bit. So we are expecting chai. We are going to let addUpNumbers, a variable, be requiring of the adding.js file, which, as you remember, has just one function in it. We'll be using describe, which is a method of chai. We're going to pass that adding.numbers as a parameter as well as a callback function. Also, we're using it. So we are, again, it is part of chai. So in other words, we're saying that it should add 2 numbers, and those numbers should be equal. So we are actually going to do something here. We're going to let x and y be 2 different numbers, and we are going to sum them within the it method. We will also allow the function to accept those same 2 numbers and store that in sum2. So basically, expect, which is part of chai again, will assume that the sum2 is equal to sum1. And if that's okay, then our test should pass. Let's save all of these files. And our package.json, let's notice the package.json has changed because we installed a couple of different packages. So notice what's going to happen in this area. If I reload, notice it says that it's now depending on Mocha and chai. Now, if we leave this as it is, our package.json is going to assume that Node is handling the tests for us. We don't want that to happen. We want to have Mocha handle the testing for us. So I'll just change that, make that one simple change in my package.json. I'll save the file, and I believe we have everything that we need now to run this test. So let's head back over to our terminal, and all I really need now to do is execute npm and test. I don't have to give it any path. I don't have to give it any special instructions. It's simply npm test, hit the enter key, and there is our passing grade. So it has found out that our function is working properly and our test has passed. So it is this easy to start writing or unit tests for your Node applications. In this video, we are going to take a look or explore some of the architectural features as well as some of the components of what is now called the mean stack. The mean stack has become very popular because all you really need to know is just one language, and that's JavaScript. It's a web application framework that runs on Node, and as you know, Node is built with JavaScript. It also features MongoDB, which is a NoSQL database, and Express.js. All of these technologies use JavaScript as the main language. It's also free and open source, and there is, of course, AngularJS at the front end. Let's now take a look at how the process works. So a client or a browser will probably make a request to some URL, some resource, And the first thing that happens is that Angular will accept that request and then pass it on to Node. Node will then pass that request on to Express. Express will process the request and send it off to the database if necessary. MongoDB then comes into the picture. It will provide the data, and the Express is going to return all of that data and HTML back to AngularJS. So the process is very straightforward. Let's take a look now at some of the tools that are available for the mean stack. The first thing that we'll talk about is Git. Git is a code repository, and it allows developers to collaborate and keep track of any changes to their code. It is extremely useful when it comes to the mean stack. Then there's Node.js itself, as well as the NPM, or Node Package Manager. And Node Package Manager is what helps keep the application up to date by installing and adding packages that may be needed from time to time. So all of this is simplified for you using Node Package Manager. MongoDB, of course, will persist any data that you have, and it does this mainly using JSON objects. Then there's Bower, which manages front-end packages. It works closely with Git, and it allows the developer to package only certain files that the developer wants and leave out certain other files. It can help with specific versions of jQuery. And because of the way it works, it helps reducing page load. Then there's Gulp, which helps to automate the development process. Now, these are just a few of the tools within the mean stack. There are a lot more than this out there. Now let's take a look at the overall architecture, which I had explained in a previous slide, but basically this is the way it operates. So we've got AngularJS, which helps with things like spas, which is a single page application. And together with Express, they handle all of the front end work. That's then passed over to Node and Express as well in the back end, which then communicate with the database to get all of the data. So as you can see, working with a stack like the mean stack, it makes development time a little bit faster, a little bit more efficient. And then, of course, all of these technologies are very lean technologies. They use only the resources that they require. So I would strongly recommend the mean stack when it comes to developing web applications. In this video, I'd like to take a look at cloud environments and see how some of the features can benefit a small organization or a startup organization. First of all, we can reduce the initial infrastructure expenses by moving to the cloud. And what I mean by that is that, well, because of the number of clients, number of tenants that a cloud service can have, it reduces the total cost of ownership. And it reduces, well, of course, even going to the cloud reduces things like server expenses, network expenses, and even expenses in terms of training. With the cloud, scalability is not so much of an issue. There's no boundary when it comes to subscriptions. You simply change the subscription and you move on. Also, in terms of your content, they may be distributed all over the globe, so you really don't need to worry about downtime. Downtime is almost zero when you move to the cloud. Let's now look at some of the various types of cloud environments we have. There's the public cloud, of course, and the service provider provisions resources for multiple public tenants. So there's the Enterprise A, Enterprise B, Enterprise C, etc., and they all kind of share the same, physical equipment. However, they're all separated logically. So even though, yes, there are some risks in this situation, it's nothing to be really concerned about. The benefit of this type of environment, though, is that you're billed in terms of what you use. Also, you're billed in terms of your pay as you go. So if you wanted to stop your subscription for a couple of months, let's say, and start it back again, then you don't need to worry about that couple of months that you're down. In this way, organizations can then just focus on the operating day-to-day expenses. They don't need to worry about those capital expenses that I mentioned before, things like servers and training and hardware and networking. So I think this would benefit most startup organizations, most small organizations. However, if you were large enough and you could afford it, then you have a private cloud going. This is where a single organization and resources on the cloud is tailored for that single organization only. So it is still cloud computing, but you don't run the risk of sharing anything with anybody else. Now, it does require some, a little bit more knowledge in terms of your staff. So there might be some expenses when it comes to training your staff. Also, apart from the operating expenses, you may have some capital expenses as well. So overall, though, it is still cheaper to work with a cloud environment rather than build your own IT department. Then there is something called the community cloud. And this is where organizations get together and decide to form a cloud service, and somebody's going to host this service. So for example, University A as well as University B decided to establish a cloud service, and they use it mainly for collaboration and things like that. It is still just as elastic as a private cloud. And really, after you've set up the cloud environment, you really only need to worry about the operating expenses. So as you can imagine, there is a combination, something called the hybrid cloud, where organizations' use of both public and private clouds are possible. So in this environment, you kind of have the best of both worlds. You can, have your regulated or sensitive data that's going to be maintained by the private cloud, where you're not sharing anything. But there might be other stuff that you really don't worry about too much. So you might want to, have that on a public cloud. Now, apart from having the best of both worlds, you also have the benefit of both control as well as flexibility. Now, there are some challenges in terms of governing this type of hybrid situation, but, in the end, it is still cheaper than building your own IT department. So as a full stack developer, you would definitely want to consider the cloud at some point in time, especially if you're working for an organization that can't handle the capital expenditure of equipment and networking and training and that sort of thing. In this exercise, you will build an API that will use the following node packages. So file system, express, and router. You will then use the read file method of the file system to read an index.html page, which you will build and have a special or simple message on it. Use the get method of the router object to create a default path. Then you will use the write method of the default response object to serve up that HTML page that you read using the file system. You will then use the use method of express to coerce express into using router's routing methodology instead of express's routing methodology. You may now pause the video and attempt to develop this application, but definitely return to the video to see how I would develop a solution for this exercise. So we will first of all develop the server file. And let's first of all do the requirements for our exercise. So we're supposed to be using things like fs, which is the file system, express, and router. Let's code those first. So we're going to be needing express, as well as we'll create an object out of express. We'll also need router and the file system. We will also need a port to serve this on. And now we can start building our route to the home page. So first of all, we're going to use router as an object and the get method, which takes two parameters. The first is the path to wherever we need to go. In this case, it's the home page, or the default path, I should say. The second will be a function that's going to handle things like the request and the response in terms of whether this was a successful request. Now, within this function, we are going to use the file system to do a read file. Of course, we're going to be reading the index.html file, which I'll show in a second. The second parameter of the read file function or method is actually another function. So that function will handle things like errors, as well as it will handle the content of our HTML page. So let's insert a line to, first of all, read the HTML and send it off to the browser on line 11. Now, once we have all of this, we can go ahead and use the, remember the exercise asked us to use router. So I'm asking the Express application to use router as the default routing mechanism. And from that point on, we can just go back to using app again to listen on the port that we had programmed. And the final line on line number 18 is just a console message saying that we're listening. So that's it. That's what we need to write or to code in order to serve a web page. Let's take a look now at the file structure. So we've got our server file and we have our index.html, which I'll open up just to show that it's a very simple HTML file. Now, if I go to our terminal window, I can now use this terminal window to start up our http_server file. So that's a node and the name of the file. That will tell us that we're listening on port 8000. I can then use my Firefox browser to head over to that address. And I believe I already have it here. And that should actually show me the web page. There's my web page. So now we have completed the exercise.
In this video, I'll present how to differentiate between relational and non-relational databases and recognize their basic structure. So let's start with the basics of representing data. When we're talking about representing data, our first instinct is often to think about data represented in columns and rows, records of data in a row-oriented tabular form. So in formal terms, we're talking about set theory and relational algebra, where the relational name in the relational database comes from. So in the tabular icon I have here, you have a blue row across the top indicating the column header name, so the names of the columns, and the lighter cells to be the data, where each row is a record in data and each column is a particular data item. Now let's talk about interacting with data. So given some sets and relational algebras, how do we describe our interactions with the data? For that, we need to consider the following categories. Well, the first one might be obvious since I'm building up to the structured query language, or SQL for short. So we need to think about how those queries are structured. We'll need a way of performing our set operations to get particular subsets of data, which we call queries. We need to think about how the data is defined. So the way we define the structure of our tables, the labels of the columns and their data types, data manipulation, the way we insert, update, and delete data, and data control, the way we grant or limit access to the data. Now let's talk about the relational language. So in relational databases, in database management tools, we interact with our databases using the operational categories I described on the previous slide, which we call SQL, for structured query language. This isn't just for a single table of rows and columns, but for many tables linked together using this language. The relational in the name means we're relating the data, connecting it via common identifying columns. So what keywords make up the syntax of our structured query language, or SQL? What we're going to see are the following verbs: create, select, insert, update, and delete. And they're almost self-explanatory. For create, we're talking about creating databases, creating tables, indexes, and other elements of how our data is defined. For select, we're talking about querying or asking the data to give us some subset according to particular columns and rows with conditional logic. For insert, we're talking about adding data to our database. Update is modifying or changing existing data, and delete is to remove records from our database. Now, there is an alternative to relational databases, which we call non-relational data, or NoSQL. So I've described some elements of relational databases, but what about these non-relational databases? They do exist and are quite popular for particular applications. There are a number of characteristics that differentiate them from relational data. So there are different database types covered under the generic term NoSQL, including column-oriented database management systems, document stores like MongoDB, key value stores and caches, and data structure collections. So many of these approaches favor speed and availability and flexibility over consistency and referential integrity. So they're not guaranteed to be atomic nor transactional. Some may permit some of these operations. In the document approach, each entity might optionally have sub-entities and sub-collections, which adds its own complexity on how the data is stored and retrieved. Most non-relational data stores do have a concept of eventual consistency, even if a read after write is not immediately recorded and returned, but this may help with horizontal scaling in some applications. But it depends on the problem you're trying to solve. So having SQL in a relational database system, a standards-compliant interface, and a long track record, I'd argue that in most cases, it's still the safer option to use SQL unless there are some unique or particular needs for the non-SQL data storage approach. And that concludes this presentation on database types. In this video, I'll present how to identify situations when a relational database should be used in FSD development. So in full-stack development, we're focused on a layered system with front-end and back-end layers. But those layers can be broken down even further. On the back-end, we can have our web server, which often acts as a reverse proxy for a web application, which in turn interacts with data, often in caches and on disk. The data persistence element is the database. In our case, and in this course, the relational database. In a full-stack application, our code is querying the database to store and retrieve records in it. We may even have a layer between our application and the database. This data interface is either a SQL library of sorts, which translates the SQL into commands executed on the database management system, or the data interface is what we call an ORM, or Object Relational Mapping. So the web app, because of the ORM, may need to execute SQL directly, but carrying out SQL-like functions using the code the app is written in. Then the ORM takes care of building the SQL strings to pass it on to the database. In either case, we need to understand what SQL is being executed. Now we also have transactions. So SQL statements can be transactional. We're not limited to single SQL statements at a time. We can create a series of SQL operations that are linked together in a transaction. So we can start a transaction and begin a series of SQL operations. So what we do is signal a transaction start, then perform a number of queries, such as inserts, updates, deletes, which add, modify, or remove records in our tables. And we can have select statements in there too, but the power of the transactions comes at the end. After we've performed a series of operations, suppose one of the queries along the way fails. In that case, we can roll back or undo the entire transaction. Every insert, update, or delete all get undone. Or we perform a commit operation, which writes the entire series of statements to the database. So this is a very powerful tool we have in most relational databases. Now, another important aspect of relational databases is the relationships. So this is the relations between the entities, the connected tables. We also need to describe how tables are connected. We need to ensure the integrity of our data so that connections between tables are handled appropriately. The idea is that we don't want to orphan any records, which connects data to another table that may no longer exist. So if you have one record in one table referring to another in another table, you want to make sure that these connections don't get broken. So referential integrity is often enforced by cascading deletes. So if you delete one record, any record that it refers to or that it depends on also gets deleted. Or you can prevent the deletes until the record no longer refers to or is connected to data in other tables. So these are some of the main considerations for using relational data in FSD. And that concludes this presentation. In this video, I'll present the role that SQL plays and describe some SQL characteristics when using a relational database in full-stack development. In FSD, we generally talk in multiple layers. The client, which is often the web browser, the server, which is our application code, and the data, our data persistence layer, which is SQL or NoSQL. So we talk in multiple layers with client-server, front-end, back-end, and in many applications, we think of it as a stack. So you're a full-stack developer, where you use the browser, a server application, and a database. In this course, we're focusing on relational databases in SQL code. We're talking about the data layer of the backend, connected to the server and separate from the client or browser. So what does the code look like? Well, let's start by looking at how a table is defined in a relational database. It's schema. So how do we define a table in SQL? Well, with the create table command. So here I have create table employee. So inside of the parentheses, I define the columns of our employee table. So in the first column, I have ID. So I'm going to call this ID for identifier. Its type is going to be an integer. So we're going to identify the employees by a number, by an integer. We can enumerate this, say, from 1 and upwards. So the first employee is employee ID number 1, number 2, number 3. But these are going to be unique per employee. And in terms of SQL, we set this to be the primary key. So this is the key that identifies the employee. And if any other tables in our database refer to this employee, they often refer to the employee's ID number. We can have another field like name, and this could be a text column. So we have the column, so its name, its type, and some extending parameters or characteristics of that column. So in the first column, the name was ID, the type integer, and the extending parameter or characteristic was primary key. In the next field, name has a text type, so it's text or strings, and then it's unique. Now, this might not be the best characteristic to put on this column because you could have multiple employees with the same name. We wanted to enforce that names must be unique, that there can only be a name in our employee table once, and we can never hire anyone with the same name again. We could put on the unique column. Now, in this example, it's not a practical consideration to put a unique field, but it is an option, a characteristic that we can apply to a column where appropriate. And then we have a department ID, which is an integer, and it's specified to be not null. So we can't have an employee without a department. And now it's a department identifier, an ID. Now this might often signal that we have a department table somewhere with IDs and department names that this references. And the last column is age, which is specified to be an integer. Now, age is not a typical column that we normally have. We typically set a birth date and have a date and figure out the age based on the current date if we needed that information. But all the same, this is how we define a schema using SQL. So when we create a number of these tables, and we want to have them interact, there's a formal way of defining this called normalizing data, with what is typically called normal forms. Now, without getting caught up in the formalism of the idea, the goal of normalized data is to define tables with the following characteristics. We want to use simple data types. So each column has a type, such as an integer or a decimal number, or a Boolean, or date times, or strings. There are no complex objects. We have keyed rows, like in the previous slide where we defined a primary key, where it's a unique identifier which is often used as an index into that particular record. And finally, we have independent tables. So the tables are linked based on their keys, their primary keys quite often, and we avoid any sort of complex dependency on multiple keys, and we avoid circular dependencies. So if we have table A that connects to table B, which has a reference to table C, we don't have C referencing back to table A and forming a loop. With normalizing data, we avoid these concerns. The other way we describe relationships between tables in SQL, where we have tables linking to each other in various ways. So we think of this relationship in terms of their cardinality. The first one is a one-to-one relationship. So this is so that each record in one table, we have one record it references or it can refer to in a second table. So there's a one-to-one link. So only one record in the first table, which could also link to other tables, but that one-to-one initial relationship defines the cardinality. We can also have a one-to-many cardinality so that the second table can have multiple records linking back to the first. So there's a one entry in one table is referred to with multiple entries in a second table. And finally, we have the many-to-many relationship. So many rows match up with many rows in a second table. And in that case, we often use a linking table in between the two reference tables so that we can describe the relationships between the two entities. And that concludes this presentation on SQL and relational databases for FSD. In this video, I'll present how to describe the difference between DDL, DML, and other categories of SQL statements, and identify some of the more common commands for each category. Now, it's important to recognize the initialisms or acronyms, as many articles and documents pertaining to SQL and relational database use these. So these are the four categories of the SQL language. So we have the DDL, the data definition language, the DML, the data manipulation language, DCL, the data control language, and TCL, the transaction control language. So we spend the majority of our time working with the DDL and DML, but we also need to be aware of all 4 of these categories because they will come up. So let's look at the first one, the data definition language, or DDL. So these are the create, alter, drop statements that pertain to databases, tables, indexes, and other entities within a database. We also have other ones like truncate, comment, and rename, but they don't come up quite as often. In the data manipulation language, this is very important. We have the select. So if we want to select information from our data, so this is the actual pulling information from the database. In our select statements, we have joins and we have conditional logic, groupings, aggregate functions, a lot of anything to pull information out of our database and make sense of it. And of course, we have the insert statements to add data to our database. So we insert records into it. We update it. So we take an existing record or existing set of records and update their values. And finally, to delete records from the database. So these all make up part of the data manipulation language, or DML. Then we have the DCL, the data control language. So this is everything to do with access control. Primarily the grant function, where we grant access rights. So we give access to certain tables or certain statements. So this is how we give access to a particular user to have access to perform actions on the database. And we can limit what actions, whether we give the entire DML, we might allow a particular user to have full access to DML functions like select and insert and update and delete, but no DDL functions. So they can't create databases or create tables within the database. And we can revoke access. So if we grant too many permissions, we can always go back and pull back on some of the permissions. So we remove access. And then finally, we have the transaction control language. So the primary ones are commit, rollback, save point, and set transaction. So what happens is we start a transaction, and as we go through the transaction, we can have save points. And when we reach the end, we can either do a commit if the transaction was successful, or if the results fail, or if there's some particular query, some statement from our DML like select or insert that fails, we can always roll back and undo the series of commands that we just executed. So it's not committed until the final end of the transaction where we commit the transaction. And that concludes this presentation on categories of the SQL language. In this video, I'll present some of the required knowledge you should have in SQL as an FSD developer. So for the full stack developer, the first thing is security. So in terms of your database management system, the DBMS, you need to keep the system up to date, patched, including the underlying operating system. Then access to the database needs to be managed with user accounts and access permission. So your backend application needs a user account particular for that application, and it should not have all of the privileges. So it shouldn't be able to create and drop databases and tables depending on the application. So each DBMS manages this a little bit differently, but they all have this capability. So your backend application will need a user account particular to that application. So it's not a general user account, and it should never be an administrative or a root account. So it shouldn't have all the privileges. Each DBMS manages this a little bit differently, but they all have this capability. So in typical applications, your web app user should not be able to create, alter, or drop databases and tables in your system. So most access is for the select, insert, update, and delete, with other permissions being granted sparingly and only in special circumstances. The next thing you need to know is query complexity. So as a full stack developer, you need to understand this, and you need to know how long queries take to run. Are there any long-running queries that could be improved? Are they too complex? Are there issues in indexing or lack thereof? In many DBMSs, there's an explain keyword that can be prepended to most DML statements, like your select, insert, update, and deletes, that will show how the SQL engine performs on the query and the execution plan it takes to carry out the queries on your database. So using this information, it often becomes clear what can be improved and how a query can be made to run faster. The next is to know your DBMS. So each one has its own particular syntax. Many are standards compliant, or at least mostly compliant. SQL is an ISO standard. It's a standard language with regular updates. But each database management system will have its own custom methods or even custom extensions and data types that go beyond the standard. So you should know those custom methods. And each has its own way of configuring. For the full stack developer, you should get to know how to deploy a new database management system quickly and install it with the correct configuration. And the last item I'll mention, which is very important in terms of required SQL knowledge for the full stack developer, is backups and replication. Quite often, we're not dealing with just a single database instance. We often use multiple databases or replicated databases. We need to test our backups. Backing up is a strict requirement for any software or any data you're working with on a computer, but even more so for databases. So you don't want to even think about operating without a backup. And moreover, you need to actually run the restore procedure to make sure you can restore the backup to working order. So you'll do this in a staging environment just to make sure that the backups can be recovered from. So errors in this process can be sometimes scary. I've seen corrupted backups fail after the primary fails, and luckily only minor data loss occurred in these instances, but it could have been much worse. So being able to recover from these errors is essential, and make sure your backups are recoverable, and you should automate the process to test this recovery if you can. And that concludes this presentation on required SQL knowledge for the FSD developer. In this video, I'll present some of the best practices one should use when working with SQL code as the FSD developer. So the first one is to avoid string substitution. So you don't want to be creating strings manually that concatenate some string together as SQL that you pass along to the database. And I'll explain why in the next slide. So instead of using string substitution, you avoid this by using parameterized queries, which most database interfaces for most languages that you would use FSD for, they have parameterized queries and you should use them. Use a consistent style in writing your code. Use explicit column names like in your select clauses instead of a select star. You should write the names you're going to use. And finally, use an ORM, an object relational mapping. So let's get into a little bit of detail regarding these SQL best practices. So the first one, to avoid string substitution. But why? Well, string substitution and concatenation directly in the language you're working in, if you're building up a SQL query, you open yourself up to SQL injection vulnerabilities. So let's say you have a string in your code that has select star from employee where name equals some variable name. So we're concatenating using the plus sign the variable str name. Now, what if this str name contains or has the string or 1 equals 1? Then you have the ability to change the query to change its logic. So instead of selecting a name where it's a particular name, you set it to or 1 equals 1. So this makes the clause always true. So it will not just select the employee that has a particular name, but it will retrieve all of the employees. Now, the attacks in this way can get quite clever. That's why it's important to avoid this kind of string substitution. Now, quite often the semicolon is used as a delimiter between queries, between multiple queries in a statement. And if you're able to inject a semicolon into a statement to change it, to append a different statement onto it, then it gets very dangerous and you could open up access to everything and your database can be compromised. So it's important to avoid this sort of string substitution when building queries. Now, the way of getting around this is to use parameterized queries. So this allows the SQL engine in whatever language you're working in to handle the parameters for you. So you can build a string, a select statement, you set it to a variable like this str SQL equals select star from employee where name equals %s. Now in some languages, the syntax is slightly different, but the idea is the %s is a variable to be substituted so that the SQL engine will take your variable and put it into the statement in a safe way that avoids the possibility of a SQL injection. So in this case, we might have a construct like a cursor that manages each statement, each session with our database. And we do something like cursor.execute. We give it the SQL string, and then we give it the parameters we'd like to substitute. So in this case, str SQL and name are the argument, and it will handle the substitution for us in a safe way. The other thing we'd like to do is use a consistent style. So we want to be consistent with our column naming. So you either want to use underscores or uppercase letters to signify words and not mix and match these metaphors. Another thing I do with column naming, I quite often write out the entire column name. So I might have a column that is for the first name, and I'll name it first_name instead of using an abbreviation like fname. So when I'm typing out the column names when I'm writing a query, I don't have to think about what the column's named. I just write out the entire words. If I have to stop and think about what abbreviation I use, quite often it's slower than actually just writing out the words. And I stick to other things like _ID to signify identifier columns. And there's other conventions you can use, but when you pick one, stick to it for all of your tables and all of your database naming. But the important thing is to just be consistent with your column naming. You want to use indentation for multi-line queries, so make sure you use a consistent indentation for your code, and it makes it much easier to read. And if you have complex query, make sure they're annotated so you have some comments describing in plain English what the query is doing. So if somebody else has to understand what the query is doing, especially for complex queries, they can read your comment and read your annotations, and they'll understand what's going on. Or even for yourself personally, when you write a complex query, you put it aside for a few months and come back to it. You don't want to have to figure out what the query is doing all over again. So you write down the details about what the query is doing at the time you create it. And another best practice is to use explicit column names. So what you want to avoid is writing things like select star from employee, where you just select all of the columns from the employee. Or if you insert into employee, you just specify the values you'd like to insert without specifying the column names. Now, the alternative to this, to use explicit column names, is to actually write in the column. So select name, email from employee, because we only need those columns. We don't need all of the other ones. And if we want to insert values, we do an insert into employee. And then in parentheses, we specify the exact names of the columns we're inserting in the order that we're inserting them. So there's no confusion about what's going on and what each parameter is. So it's much easier to read when we see this, and it helps us avoid unexpected errors. And my final bit of advice for best practices is to use an ORM, an object relational mapping. So you want to map, say, an object in Python to a table in a database. Well, you construct a Python object and you read the information, say, using a select statement into your object. Now, you don't want to have to write the statement out every time, write the full SQL string, and then write all of the assignments to each variable in your object. Using an ORM, a lot of this is handled for us, and it keeps us from writing a lot of repetitive code. Now, you don't want to do this for all of your SQL, but for most of the simple inserts and selects and updates and deletes, it's much easier to use an ORM. When you get into complex queries and transactional queries, you can still fall back and write the SQL code out by hand, and often it's more efficient to do so, but for the simple stuff, stick to the ORM. And that concludes this presentation on SQL best practices for FSD. In this video, I'll demonstrate how to install and configure the Postgres relational database system for use in FSD development. So because my operating system is Ubuntu, I can use apt to install Postgres and the required libraries. So for this, I do a sudo apt install of PostgreSQL and libpq-dev. So SQL Alchemy will require libpq-dev when we install it using pip. So I'll hit enter. I'll authenticate for sudo, and I'll install the required libraries for Postgres. Now in this case, it installs PostgreSQL version 10, and that's okay. Now that it's been installed, to test it, we can do a sudo su and switch over to the Postgres user. So this is installed when we install Postgres. And now we can run psql --version just to make sure it's there and what version we're running. So in this case, we're using PostgreSQL version 10.10. So Postgres comes with a create DB command to create a database. So I'll type create DB, and I'll call my test database DemoDB. And then the database is created. Now, if I want to delete it, I call drop DB of DemoDB. But I want to keep that database because I'm going to use that in this video and for future videos. So I'm going to create the DemoDB database, and I'm going to create a user called demo user. So I'll use the command create user, demo_user. And again, there's also a drop user command if I want to drop the user. So once it's created, we have a database and a user. I'm going to go into PSQL. So I'll just type the command, and it gives me a Postgres prompt that I can use to run commands. Now we can run SQL commands on our databases. Now if I type select, now since I'm not working with a database with any information in it, there's no data, no tables or records, I can just do selects on simple arithmetic or other simple statements like select 1 plus 1. And that returns 2. I can also do select current_date. That will return the current date. And I can use any other handy functions or arithmetic operations that don't require a database. Now there are a few other handy commands inside of this Postgres prompt, like the display command, so \d. And if I do du, it will show me the users. So I see my demo user that's been created. And of course, there's the super user Postgres user that comes by default. If I type \l, so that here are the databases installed currently. So there's the DemoDB that I've created. There's a Postgres database and a template 0 and a template 1. So only the DemoDB are the ones I've created, but the others come by default. Now, one thing we didn't do with demo user, we didn't set a password. So if I type \password here and then demo_user, we can enter a password for this user. So now this user has a password. And another thing we need to do is grant privileges for this user. So I'll do grant all privileges on database DemoDB to demo_user, and then end it with a semicolon. So I've granted the privileges to this user to control this database. Now I've done a grant all, which is not typically recommended in all circumstances. But after you've first installed Postgres, if you're sure that your Postgres server is behind a firewall or it's cut off from the rest of the world and won't be used in production, so this is just for testing purposes with no real private data, then using grant all is generally okay to start. Now if I'd like to see what's in my DemoDB, I can do a \l of DemoDB, and it will show some information about DemoDB. And in the access privileges, it shows the super user Postgres, and the demo user is listed as one of its users with access privileges. And you can see by default, the encoding type, the character encoding type for the database is UTF-8. And now our Postgres server is installed and configured and ready for FSD development. And that concludes this demonstration of configuring Postgres. In this video, I'll demonstrate how to work with SQL Alchemy to connect to a relational database from Python. Now, since we're working with Python, I want to set up a virtual environment so we can install the required libraries that we need when working with Python and SQL. So in this case, I'll use Python 3 -m venv. So we're going to create a venv virtual environment called env SQL. And now I can enable this using source env SQL /bin/activate. And now prepended to my prompt is env SQL. So we're now working in this environment. And now I'm going to switch from this terminal window over to Emacs, my editor, and open up the requirements.txt file in this current folder in Home Steve Documents SQL. So in requirements.txt, I have the packages needed to connect to SQL Alchemy, plus some other libraries that I'm going to use in future videos. So the first one is PSYCOPG2 or PsychoPG2. So this is the underlying package used to connect directly to Postgres. And on line 1, I have this PsychoPG2 greater than or equal to 2.8.3. So I want the latest version, at least greater than the 2.8.3 version. On line 2, I have SQL Alchemy, and I want that to be greater than or equal to 1.3.8. Python-.env. So I'm going to use a .file, a .env file, to store the connection information, the database, the server, and the username and password in this .file, so that we can separate the credentials to connect to the database from the actual code. So I want this one to be greater than or equal to 0.8.2. And then I'm going to install Alembic, which I won't use in this video, but I will use in the video titled Change Management. And I want this one greater than or equal to 1.1.0. So I'll switch back to the terminal window, and now I can run pip install -r requirements.txt. Now, although there might be some partial errors listed, the libraries have been successfully installed. So I'll clear the terminal window for now, and I'm going to go into a folder 09, where I have the code for the current video. Now I'll do an ls-la so we can see the .file in this directory. So we have two files, connect.py and .env. So let's start with the .env file so we can see the credentials that we need to connect to the database. So I'll use Emacs to go into the .env file. And this has three variables: Postgres_user, all in uppercase, equals demo user. And then Postgres password is equal to the password that I set, and PostgresDB is equal to DemoDB. So these are the credentials that I set in the video titled Configuring Postgres. Now I'll go back. So now I'll go into connect.py and open up the Python file I'm using to connect to the Postgres database. So on line 1, I import OS. So this is going to be to read the environment variable. Then from .env, I import load.env. So this is going to load the .env file. And then from SQL Alchemy, I import create engine. So now I load .env, and I set verbose equal to true. Then I set what's called the URI to our database. So I have on line 7, db URI equals the string PostgreSQL : // and then I have in braces a 0. So this is the notation for our Python formatting, our variable substitution into a Python string, and it's at localhost, so it's running on the local server, :5432, the default port number for Postgres / and then in braces I have 2. So in this parameterized string, the first parameter is the user, the second is the password, and the third parameterized item in the string is the database name. And then I do a .format with os.environ, and in square braces indexing the Postgres user. Then the second argument is the os.environ of Postgres password, and the third os.environ of PostgresDB. Now I have a little comment here. So if you're using SQL Alchemy as your ORM to a Flask application, Flask SQL Alchemy expects the SQL Alchemy _database _URI, all in uppercase, as the URI to connect to the database. So if I want to use this code in a project using Flask SQL Alchemy, I can just set this string to the db _URI string. So this variable needs to be set in that case, because Flask SQL Alchemy will expect it and look for it. So we'll skip over that, and now on line 17, I set engine equal to create engine of db URI, and I set echo equal to true. It's a good practice to set echo equal to true when you're testing so that you can see what queries are being run against your database. And then on line 19, I just print engine, which will give us some information about the connection. And when we run the code, we'll be able to see that it's working. So now I'll switch back to the terminal window, and I'll run Python of connect.py. And it gives me some information about the engine. So it says engine PostgreSQL : / demo user. And instead of displaying the string of the password, it just displays a triple asterisk at localhost : /5432 / demodb. So it appears that we've connected correctly, and that concludes this demonstration of connecting to a database using SQL Alchemy. In this video, I'll demonstrate how to create DDL statements using SQL to create database tables using SQL Alchemy. So at the moment, I have a file open called ddldemo.py. So this contains the code, the Python code that we're going to use SQL Alchemy to create DDL statements. So this is very much similar to the video titled Connecting to a Database Using SQL Alchemy, at least the first part. The changes begin on line 3 and 4 in the imports. We need a few more libraries imported. So on line 3 from SQL Alchemy, I import create engine, metadata, table, column, integer, and string. And on line 4 from SQL Alchemy.schema, I import sequence. Now I'll skip to line 19. So on line 19, I have meta equals metadata. So this is going to hold the metadata that contains the DDL information. And on line 21, I create my first table called user. So I set users equal to table, and then I give the argument the string user, the table name, meta, which holds the information for our DDL creation. And then I define a column of ID, so that's the column name, the type integer, and then the parameter sequence, and I'm going to call the sequence user ID SEQ. And this is a primary key, so I set primary key equal to true, and then I add a second column called email, which is of type string. So that defines the user table. I'm also going to create an item table. So on line 26, I have items equals table with the string item, the table name, the meta variable, then a column with ID, which is identical to the column in user, the ID column, but in this case, I call it for item ID sequence. Because we're using Postgres, these sequences are going to be turned into the serial type in Postgres to create an incrementing value, an auto-incrementing value. So each new ID is going to get the next item in the sequence. So it'll start with 1 and then 2, 3, 4, and it'll count up from there as we add items to our table. And this is a primary key, which is also set to true. Then I have another column called description of type string and a user ID column with type integer. So this user ID is going to be referencing our ID in the user table. So the item will belong to a particular user. And then on line 32, I call meta.createAll with engine. So it's going to create and perform the DDL statements using the SQL engine, in this case, our engine connecting to a Postgres database. Now I'll switch over to the terminal window and I'll run a clear. And so we're in this folder 10, which contains our ddldemo.py. So I'll run Python of ddldemo.py. Now since we set the echo equal true, it echoes all of the information, all of what's been run. And if we scroll up, we can see the points where it's reached the create statements, so create table user and create table item. So in our Python code, we use the syntax appropriate for SQL Alchemy, but under the hood, it uses the actual create table syntax, the actual SQL, and runs that on the database. So it carries out the DDL in the SQL language itself. So now we should verify that these have actually been added to our database. So I'll switch users. So I'll do a sudo su -postgres. And we'll switch to our Postgres user, and I'll run PSQL on DemoDB. And now I can do a \d, and that will list the tables and sequences that were created in our database. So it says list of relations. It gives us the item, and it tells us it's a table. The item ID SEQ, the sequence is of type sequence. The user is a table, and user ID sequence as well. Now, if I do a select, say select star from user, it won't return anything. Now, in this case, we have to be very careful because there's a difference between the user table, a built-in table to Postgres, which tells us there's a user Postgres. So user is not the greatest table name to use when we're using Postgres because we'll have to put user in double quotes to make sure we can differentiate it between the user that's built in and the user in our current table. And that concludes this demonstration of working with DDL statements. In this video, I'll demonstrate how to create DML statements using SQL Alchemy to add a record to a relational database. So this is similar to the video titled Connecting to a Database Using SQL Alchemy, but I've modified a few imports and changed the code below after I connect to the database so that we can carry out the DML. So on line 3, I have from SQL Alchemy, I import create engine, column, integer, and string. On line 4, from SQLAlchemy.orm, I import session maker. Then from SQLAlchemy.ext.declarative, I import the declarative base. So we can define an object, a class, that we can insert into the database using SQL Alchemy. And then from SQLAlchemy.schema, I import sequence, because one of our fields is a sequence type. So now I'll scroll down to line 21, and I'll create the session. So session equals session maker, and bind equals engine. So I'm binding it or associating it with the current database engine that connects to Postgres. Then I set base equal to declarative base, and now I can define my class. So on line 24, I have class user, which subclass is from base. So base is in parentheses followed by the colon, and then I define the body of my class user, where I need to set the table name, so it's a double underscore, then followed by table name, and then a double underscore suffix as well, and I set that equal to the string user, the table I'm inserting into. So now we define the two columns. So on line 27, I have ID equals column with integer sequence of the user's ID sequence, and the primary key is equal to true. So this is the same structure we use in the video titled Working with DDL Statements. And then I define the email column, email equals column of type string. And then I create a session. So session equals session on line 31. Then on line 33, we create the user, where I set the variable user equal to the user with the email equals joe@example.com. So now we have our object, which we can use the session to add to our database. So on line 35, I have session.add user. And now before we actually perform the insert, we need to commit this transaction. So the session is a basic transaction like we'd seen in the video titled DDL and DML statements. And now I do a session.commit, and that finishes our program. Now I'll switch over to a terminal window, and we'll run the code. So Python of dml-demo.py. And since we set echo equals true for the engine, it shows all of the statements that are run, all of the SQL that's run by SQL Alchemy. And if we go up a few lines, we see begin, the insert statement, insert into user, the values that are inserted, and the commit message. Now I'll switch user, so I'll do a sudo su hyphen Postgres. And now I'll do PSQL on demo DB. And now if I do a \d, I can see the tables, and I'll do a select star from user in double quotes, followed by a semicolon. And now there are two records in this one. There's one that I added previously with ID 1 and jane@example.com, and the one we just added with ID 2 for joe@example.com. You'll notice if I go back to the code, on line 33, when I create user, I specify the email, but I don't specify an ID. I leave that empty because it's a sequence type. The database takes care of setting that ID for us when it gets inserted. So it takes the largest ID and adds 1 to it. And that concludes this demonstration of working with DML statements. In this video, I'll demonstrate how to use Alembic to manage a database revision. So I'm in this current folder in Documents SQL/12, and in it there's an Alembic folder and an alembic.ini, which I've created using Alembic init. So let's switch over to Emacs, where we can see the contents of these files. So I'll start with alembic.ini. So the code in this file is all pre-generated by Alembic init. Now if I scroll down to line 38, there's the SQL Alchemy.url parameter. So this setting will set the database URI. But in my case, I don't want to set it here because I want to read the information from the environment variable. And Alembic provides a mechanism for doing so, but I have to do it in the env.py file inside of the Alembic folder, which is why I've commented out line 38. So I'll close this file. I'll go into the Alembic folder. Before I do that, you'll notice that there's a .env file. So that contains the Postgres user, password, and database that the Alembic is going to read to carry out its actions. So I'll go into Alembic, into env.py, and at the beginning I've added some code between lines 1 and 9 that was contained in previous videos, like the one titled Configuring PostgreSQL. So I import the OS from .env, I import load.env, so we load the dot file so that we can read the user, password, and database settings. And then I set the DB URI like I did in the previous video. Now down on line 26, there is a config.setMain option with the SQL Alchemy.url. So I need to set this so Alembic knows the URI for the database. So I set this to db_URI. So now that Alembic can find our database, we can close our file, go to the terminal window, and now we can create a revision. And in this case, we run Alembic revision -m. So this is the message to describe our revision. So I'm going to add a birth date column to user. So this generates a file which we can go into and set the upgrade and downgrade procedures for this revision. So I'll go back to Emacs, I'll go into the versions folder, and I'll open up this file that was auto-generated. So it provides an auto-generated revision file, but we need to populate the upgrade and downgrade methods. So I'm going to set the upgrade function to have an OP, so this is our alembic.add_column. It's a function provided by Alembic, and we specify the table, in this case user, then SA SQL Alchemy.column of birth date. And this is of type date time, so SA.datetime. And then I close my parentheses. So that's how we upgrade our database, by adding a column to it. But we should also provide a downgrade procedure. So it's always good to be able to roll back database changes in case there's a problem. So in the downgrade method, I call op.drop column with table user and column birth_date. Now I'll save this file, go back to the terminal window, and now I can run Alembic upgrade head. And this will actually carry out this DDL, this change to the database using Alembic. Now I already have this other terminal window open with the Postgres user logged in. So I'll do PSQL of our demo DB that we're working with. And now if I check the contents of this, there's a new table called Alembic version. So Alembic can track what version this database is. And in our user table, so I'll do \d of user, it shows that there's a birth date column, which is of type timestamp without time zone. So that's the default for the date time provided by SQL Alchemy. Now for the sake of completeness, let's go back to the other terminal window and run the downgrade. So in this case, we can go Alembic downgrade, and now we need to specify the number of steps we'd like to downgrade. So we'll use a negative, so a -1. And this will downgrade to the previous version, so it'll run the downgrade method. Now, if I go back to Postgres and run \d user, it has removed the birth date column. And that concludes this demonstration of SQL change management. In this exercise, you'll connect to a SQL database from Python using SQL Alchemy. Then create a table from Python, insert a record into the created table, and then verify the record was inserted by querying the database from PSQL. Now you can pause the video and perform the exercise, and when you've completed it, come back to the video to see what I did. So in my exercise directory, I have two files that I'm working with, .env and exercise.py. In .env, I have a Postgres user, a password, and a Postgres database called exercise.db that I've created for this exercise. So I'll close the .env file and open the exercise.py file. So on line 1, I import OS. Then from .env, I import load.env to load the .env file with the user password and database settings. Then from SQL Alchemy, I import create engine, metadata, table, column, integer, and string, so we can connect to the database and then create a table from Python. It'll also help us insert a record into the created table. Then from SQLAlchemy.orm, I import session maker. Then from SQLAlchemy.ext.declarative, I import declarative base. And then from SQLAlchemy.schema, I import sequence because one of our columns is going to be an ID column. Then on line 8, I load .env to load the settings with verbose equals true. Then on line 10, I create the DB URI to be set to PostgreSQL : / with the parameter for user : the parameter for password at localhost : 5432 / the third parameter, or the parameter at index 2. So this is a Python string with a dot format, so we can do a substitution of these parameters with the os.environ of Postgres user, Postgres password, and Postgres DB. Now we can connect to the database using the create engine. So on line 15, I have engine equals create engine of DB URI, and I set echo equals true, so we can see the output when we run the code. So that connects to the database and finishes the first step of the exercise. Now let's go on to create a table from Python. So I set meta equal to metadata, and then on line 18, I create a table called exercise, so exercise string, the meta variable that I pass the table, and then I create a column called ID. It's of type integer, and it's a sequence which I've called exercise _ ID seq for sequence, comma, primary key equals true. And then I create a column description, which is of type string. And now I finish off this step to create a table from Python by calling meta.createAll with engine as its argument. So it creates it on the database we're connected to through the engine. And now the next step is to insert a record into the created table. So on line 25, I create a base equal declarative base, and then I define a class exercise of type base with a table name set to exercise. And then on line 29, I have ID equal column with integer sequence of exercise ID seq that's going to be created inside of Postgres, and a primary key equals true. And then I set the description like I have above in a similar definition equal to column of type string. And now I can create a session equals session maker where I bind it to our engine, and then I start the session, which is session equals session with the parentheses following. So it creates a session object. And now I can create the exercise equal to the exercise class with description equal to hello exercise. Then I call session.add with exercise and session.commit to add the record to the table. So this will insert it into the created table and finish off that step of the exercise. Now I'll go to the terminal window inside of this folder and run Python of exercise.py. And now I can switch over to another terminal window where I'm logged in as Postgres, and I can type PSQL of exercise DB, the database we're using, and I'll type \D. Now if I do a select star from exercise, I can finish the last step of the exercise to verify that the record was inserted by querying the database from PSQL, as I'm doing here. Now I've mistyped exercise, so I'll do select star from exercise, and we get our record with ID 1, and the description is hello exercise. And that concludes this exercise on the SQL Essentials for the FSD developer.
In this video, we're going to talk about security planning and communicating. Now, at the core of any company is their data. Business is built around data, and data is the most valuable resource. Most companies store their data in databases, putting the need for database security as a top priority. Database security extends beyond the need to reduce the attack surface, also encompassing protecting the data from accidental loss or corruption. To ensure consistent adherence to security practices, checklists should be compiled. Physical access control is a fundamental requirement for all locations where data is housed. This should be implemented by restricting access to the facilities where the data is housed through locked doors and authentication mechanisms. The only users who should have access to the servers should be key holders who have their identity confirmed. And personnel should be trained to identify malicious behaviors and have mitigation and action plans in place for reacting to a breach. The plan should be for physical and digital events. A checklist should be produced so that the installation and configuration of databases in the organization is consistent and secure. And security across the network is as important as securing the data at rest. Man-in-the-middle attacks or network sniffers could be utilized to either compile data or get the credentials used to access the database. Now, some components that make up a checklist for securing a database are the following. So install only the necessary components. Installing too many unused options and features expands the attack surface exposed to unwanted intruders. Lock and expire default user accounts. The default accounts are easily guessed at, and an access can be achieved with elevated user privileges that are difficult to track and identify. You want to change the default user passwords. So if the locked accounts got unlocked through requirement or by accident, they should still be difficult to access by having non-standard passwords. And practice the principles of least privilege. Users should only have the minimum amount of access that they require to perform their job. Now, installing and configuring a database using the default options exposes a large risk for the organization. There are industry standard configurations available for all major database providers, and these should be followed and understood by the database administrator to provide maximum data security. So the database access checklist should include the following. So access controls through an authentication service or directory and disallowing remote authentication. Restricting access to the operating system and then securing the security folder or the folder structure and data at rest. Restricting network access and ensuring data is secured in transit. And applying security patches available at the time and on any other security products that layer on the database. Now, the network security checklist should be used as a guide for the following. So, enabling and configuring SSL to secure data in transit. Securing the listener and restricting its privileges in event of compromise. Securing client connections and authentication to the database over the network. And ensuring network protection is effective through the use of firewalls, restricting physical access, and encrypting traffic. Now, some concerns that should be considered when working to prevent data loss are the following. So, SQL injection attacks that are unknowingly presented through application front ends, leaving the database administrator responsible for data that has been breached due to a lack of testing by developers. Security testing not being undertaken before the application is deployed, leaving code and data vulnerable to external parties. Poor or no encryption through the use of outdated ciphers. And weak security software like antivirus, firewalls, network protection monitoring solutions, and VPN tunnels. backups being accessed and data stolen through lack of security or archives, and failure to validate these SQL queries and scrub them before they hit the database presents opportunities for malicious actors to do harm to the organization without having to work to gain access to the back end. And there are many reasons for data breaches, and each comes with its own mitigation techniques and tools, but starting with checklists to ensure baseline requirements are met helps organizations to avoid embarrassing mistakes and to keep sensitive information secure. In this video, we're going to discuss DB log analysis. So logs are created by the database for many reasons. They can be used to track transactions, for troubleshooting issues, or for forensic evidence analysis after a security event. Although logs are stored locally by default, a log collection and analysis tool should be employed to provide deeper insight into the log data. The collection tool should be monitoring the application and system logs, as well as those from the database to give a complete picture of the flow of events. It should provide active monitoring, alerting when triggers and thresholds are met. Passive log collection does not help to mitigate issues as they occur. Access control monitoring will help with audit trails to determine who has had access to the system when an incident occurs. Log management tools provide a range of functions to mitigate and track activities across the database, and deploying them is a constant exercise in fine-tuning and improvement. Now, there are many cases where log analysis is necessary. So compliance with either company policies or industry regulations such as financial or healthcare standards. Incident response when there is a data breach or potential for threat. Troubleshooting errors in an application, analyzing user behavior to improve application functionality and streamline the user experience, and forensic investigation when an incident has been discovered and the threat vector has not been determined. So effective log analysis is a complicated process, but there are best practices to ensure it is implemented effectively. So understanding the patterns in your usage and how to recognize irregularities. Normalize logs so they follow the same format for easy querying and reading. Tag and classify logs from the data sources and use keywords and categories to keep similar or related logs together. Collate the logs together from all sources to map a user's flow through the system. Firewall, application, server, and database logs together can provide the whole picture of an event. And artificial ignorance is using machine learning to identify which logs are just chatter or routine and which logs are pertinent to tracking an unusual or unexpected event. Now, there are a multitude of logging engines on the market, but some examples of the market leaders are the following. So first we have Graylog, which is available in both community-supported and commercially supported versions. It scales well, being able to employ load balancers in the backend to collect logs from many different data sources. Then we have Nagios, is most commonly used by organizations for monitoring their local networks. It works with Windows, Linux, and Unix, and provides extra functions for automation and geographic mapping to understand the flow of data through your servers. Then we have the Elastic Stack, or ELK Stack, as it's sometimes known. And it's a combination of three tools. You have Elasticsearch, which is a tool for combing through and querying large data sets. Kibana, which is a visualization tool used to analyze and report on the log data and events. And Logstash, which is the pipeline that retains and collates the logs into one usable database. We have Logalize, which differs from other solutions in that it uses SOAP methods for feeding logs into the analyzer. It provides all the functions a system administrator could need in one interface, including reporting, analysis, correlation, and auditing. And then finally we have FluentD, is a complete open source application for log collection. It does not provide analysis or front-end capabilities, but is the middle layer for gathering logs from multiple types and sources and parsing them to provide a single log format that is collected in one location. It is extensible through the use of plugins and uses industry standard JSON format documents for log storage. So poor log tracking and database management makes tracking issues and incident response ineffective and time-consuming. Properly managing log collection and using analysis tools is critical to effective security response in an organization. In this video, we're going to discuss OWASP security standard benefits. Now, the Open Web Application Security Project, or OWASP, is a non-project organization that attempts to improve the security of any web-enabled software application. They provide guidance and tools to set and harden applications to reduce the likelihood of an attack. So their documentation helps developers, security professionals, and system administrators to understand common security issues. They gather data and document and publish information about the most common security concerns and provide guides on how to identify and fix or mitigate them. The OWASP Top 10 is a document released periodically that encapsulates the 10 most common critical web app security risks. It is not a single tool for resolving issues, but instead acts as an awareness instrument that organizations can use to raise their security posture through identifying where risks, say, lie and working to resolve them. So the top 10 vulnerabilities go like this. First, we have weakness in injection style attacks. So injection attacks can happen through SQL, NoSQL, LDAP, and other routes. This is when an attacker sends a command to an interpreter, which then executes an unwanted command or allows access to data. Authentication and session management is often not managed properly, resulting in session hijacks or allowing attackers a path to gain the user's credentials. Sensitive data may be accidentally exposed through an application or an API, leaving it open to hackers. This can result in financial or healthcare information being used maliciously. XML processor engines can be used by a hacker to view files on the application server or to interact with backend and related systems that the application accesses. Server-side request forgery can be performed through this kind of attack, giving the hacker the ability to compromise the underlying infrastructure. So levels of access and users' rights need to be monitored, controlled, and audited frequently to stop privilege creep. Unauthorized users should give themselves elevated privileges or hijack accounts that have unauthorized functionality. Application configuration items that are left misconfigured or unconfigured leave an open paths for attacks. These are often items like verbose logging, printing error messages with sensitive information, or storage being left open to outside access. And cross-site scripting, or XSS attacks, are where a malicious user injects scripts that execute in the browser of a user of a trusted website. They can be used to hijack sessions, install applications, or deface sites. Now, when distributed applications move data between services, they serialize the information, which is converting it from a binary to an ASCII string. When the data is received, it is deserialized back into binary. To move the data securely, it should be accompanied by a cryptographic signature to enable integrity checks. If a signature is not configured, it leaves the system open to hackers injecting their own payloads into the application. Using libraries and frameworks with known security vulnerabilities can leave the whole system open to attacks, as these components run with the same privileges as the application. And properly using logging and monitoring is essential to identifying attacks when they happen, how far they have spread, and what effects they have. Insufficient measures taken to implement tools to provide these functions can leave an organization vulnerable to ongoing attacks or data breaches. Now, there are some essential steps that an organization or developer can take to help their applications and ensure they're secured against the OWASP Top 10 recommendations. So the first one is to perform an application security testing regularly during both the development and maintenance phases. Use multi-factor authentication to avoid user accounts being compromised. Crypt all data in transit and at rest. Perform static application security testing to discover configuration issues and dependencies that may be vulnerable. Penetration testing will help to expose vulnerabilities in the non-functional access controls of the application. And dynamic application security testing will root out problems with APIs and exposed functions, and ensure that developers are trained in understanding, identifying, and mitigating cross-site scripting vulnerabilities. Use application security tools to test serialization and deserialization inside the application's communication stack. Software composition analysis will identify components that may have architectural or known coding vulnerabilities. The security personnel undertaking penetration testing should be thinking like an attacker, working to circumvent alerting and logging tools and stay undetected. So OWASP published documentation can help organizations to keep their digital footprint secure through education and awareness, helping to avoid costly mistakes that could have been prevented through, say, just due diligence. These steps should be reviewed and referenced frequently to ensure a good security posture is ongoing. In this video, we're going to discuss CI/CD security integration. So the continuous integration, continuous delivery model is a way of working that puts emphasis on small changes that are released frequently. Continuous integration is a process where changes are made, tested, and committed to a branch by one person. Continuous delivery will take the code and push it to production, potentially multiple times per week. Security testing should be built into the continuous integration process by testing code as it is completed. So this brings multiple benefits, including improving code integrity, leading to more secure software. And changes are tested immediately instead of waiting until they have been committed and then backwards engineering to find where issues have come from. Automated builds and security testing scale with the project and team as development efforts increase. Now, attempting to automate security into the CI/CD pipeline comes with a set of challenges that need to be measured and resolved before implementation. So you're going to have many security tools available, but most are manual or lack the ability to fully integrate into the build pipeline. They should continue through all phases of testing seamlessly and break the build and alert on issues, updating the defect tracking system and metrics as they go. Most tools pass these functions back to a user, breaking the automation. Now, different teams with different work methods and different tools lead to spread that is inconsistent. Individual developers will write tests that function differently, and there may be debate on when, what, and how to test. The inconsistent approach can lead to significant issues with effective integration of security tools into the CI/CD pipeline. So security testing processes can take considerable time, especially if they are not optimized. So understanding the tools and taking the time to correctly configure and optimize them will save considerable time in the testing and release process. And false positives can lead a developer to waste time on chasing down errors that don't exist. The developer needs to understand the application, the security tool, and the security test results to identify where false positives are presented and where they come from. So compliance with external regulatory bodies can force organizations into work practices or using tools that are not quite sustainable or suitable for ensuring that their application is functional rather than secure. So this will require analysis and work processes built to encompass rather than push against the regulations and guidelines. While there are challenges that come with implementing security testing into the CI/CD pipeline, there are also some guidelines to follow to aid in implementation. So often security information like secrets and passwords are embedded into code. A good test suite should incorporate code analysis to determine if there are secrets present before the code is released. And when security testing is implemented, it usually performs the test and then provides a report with the results, forcing a break the build process, which is something the developers use to resolve the issues before the build can be completed. While automation brings its benefits, manual testing should still be included as part of an effective testing regimen. Attack or active attacks like red team exercises, where a team of security professionals purposely initiates an attack on a system to test its defenses, should be planned and performed frequently to identify both technical and process vulnerabilities. And bug bounty programs have been proven to be effective, with external security researchers and enthusiasts adding their tools and techniques for securing applications. But these tasks need to be undertaken with caution and have strict rules of engagement defined. Now, static code analysis testing is one of the most frequently automated methods of security testing used. So static code analysis security testing, or SAST, finds vulnerabilities in code by applying known architectural patterns and logic rules to code as it is written. When choosing a SAST scanner, ensure it is compatible with your programming language. Many scanners are marketed as being universal but require third-party plugins or only work on outdated frameworks. Now, a downside to SAST scanners is a tendency to report on false positives, so the team reviewing the report needs to have a deep understanding of the code and the scanning to filter them out. Dynamic Analysis Security Testing, or DAST, tests an application after it's been compiled and is running. So DAST tools usually are run externally to emulate what an attacker would be able to reach. They can also search for vulnerabilities on subsystems by crawling applications and hitting all exposed points. When choosing a DAST tool, try to avoid one that has a dependency on a specific development language to provide you with a maximum flexibility in this video. We're going to discuss FSD database platforms. Now, there are numerous items to consider when choosing a database platform to leverage for an application. Aside from developer preferences and skill sets, there are technical items that should be evaluated as well. SQL and NoSQL databases each have their own strengths and weaknesses. SQL is a common programming and querying language that is widely used and provides the ability to execute complex queries. However, it limits the way data is stored and requires a schema to be defined upfront, meaning it lacks versatility, and if planning is not undertaken, locks you into inefficient databases. NoSQL is much more flexible with dynamic schemas, putting the schema definition back on the application. It is a document-driven, meaning syntax is easy and predictable, and the databases can each be unique. Now, SQL is scalable by adding more resources to a single server to handle additional load. NoSQL has the ability to shard, which is adding more server nodes presenting the data. This makes NoSQL the preferred option for large data sets or data that frequently changes. Now, SQL uses relational tables for data storage and retrieval, where NoSQL uses key value pairs, document-based or graph-based databases. So SQL databases are better suited for structured, transactional that can be stored in rows, and NoSQL is well suited to unstructured data. Now, in Brewer's theorem, distributed systems must sacrifice one of the following in order to achieve the other two: consistency, availability, or partitioning. So ACID is a set of properties that a database must adhere to in order to guarantee the reliability of a transaction. A distributed system that intends to adhere to ACID compliance must also adhere to Brewer's gap theorem. Now, customer support is very common from vendors of SQL systems like Microsoft SQL Server or Oracle Database. However, support for NoSQL engines tends to be more from the community or third-party implementers, leaving significant risks in event of errors or liability. So some examples of NoSQL systems are MongoDB, perhaps the most popular document-driven database engine available. It is offered as a local install or native cloud offering called MongoDB Atlas. We have Apache Cassandra, which is a distributed database system designed to handle large amounts of unstructured data, many points in a highly available build-out. We have Apache HBase. It's a Java distributed database that runs as part of the Hadoop stack on top of HDFS to provide functions that replicate those of Google's Big Table. Now, the most commonly found SQL databases are MySQL, which is owned by Oracle but is released as a free and open source project. It is popular as a backend for web-based applications like blogs and forums. Oracle Database, which is an industry standard for enterprise-level databases, and uses its own modified version of the SQL language for extra functionality. We have Microsoft SQL Server, which is commonly found in small to medium-sized businesses. It doesn't support the scalability that Oracle does, but has excellent tooling for optimization and BI analysis. And then you have PostgreSQL, which is a free and open source database management system that is highly portable, working on many operating systems and platforms, and is a hybrid of a SQL and NoSQL implementation. It offers excellent ACID compliance and uses pure SQL. So most mainstream cloud vendors offer database services in the cloud, removing the need for the client to host their own infrastructure, especially for organizations focused on cloud and web developments. So Amazon Web Services provide relational and non-relational and data warehousing functions for petabyte scale deployments. They also provide services for migrating databases to minimize downtime. Microsoft offers SQL Server on Azure with automated scaling, built-in security, and support for all their standard management tools like SQL Server Management Studio and SQL Server Reporting Studio. Microsoft also offers Azure Document DB, a NoSQL database that supports JSON and JavaScript. Now, Big Table is a distributed NoSQL database offered on the Google Cloud Platform. It is marketed as being limitless and offers extremely fast writes. It integrates with other Google services and works well as a backend for machine learning or pattern monitoring efforts. Cloud SQL by Google is a fully managed deployment of either MySQL or PostgreSQL hosted on Google Cloud Platform. Oracle offers their database in the cloud, managing all of the overhead and allowing for scaling as necessary. Now, there are many options available for any size organization deciding between database types and hosting methods, but consideration should be given to each not only with regards to the type and usage, but also the security around them. Not all cloud providers are the same, with different certifications and security stances and standards, and different geographic locations that may influence the security of the data stored there. In this video, we're going to talk about MySQL database. So MySQL comes in two offerings: Community Edition, which is free and open source, or Enterprise Edition, which comes with support from Oracle, but at a cost. So I'm going to start this video off by running the installer for MySQL. So I have the MSI here for version 8. Just go ahead and get this running. Click Run. Now, when running the installer, we're going to be presented here in a moment with the different setup types. So we have developer default, server only, client only, full, and custom. Now, with security in mind, we're going to click on custom because we want to control every aspect of the installation. So I'm going to click on custom and go ahead and click on next. Now, the installer comes with a filter which allows us to reduce the number of available items to only those relevant to our requirements. So I can click on the filter text box here and I get a drop-down menu. So I can go ahead and type in free text, or I can manipulate the categories. So right now I have it set for MySQL servers. If I clicked all software and filtered, this list of available products would expand. If I go back here and again click on just MySQL servers and then filter, it reduces the list to just the MySQL server, but notice we have a lot of versions here. So the maturity, I want to mention this here. This drop-down lets you select from the pre-release version, the current GA, or other releases. Now, pre-releases should never be used in production as they could have undiscovered security and usability issues. So what we want to have here is just the current general availability. Now the architecture allows you to determine whether you want to install it as a 32-bit or 64-bit. So for my purpose, I'm just going to click off 64-bit and then filter. All right, I'm going to re-expand these nodes here. So the current version of MySQL is version 8. The installer lets you choose any previously released version up to the current. So there are often legacy reasons for previous versions, but due diligence should be undertaken to identify any versions that may have had significant security issues. For example, MySQL 5.1 before 5.1.68 had a known buffer overflow issue that was rated 7.5 in the CVE severity score. So I'm going to select Microsoft or MS MySQL Server 8 So MySQL Server 8.0.18. This is the very latest version. And I'm going to hit the arrow because this is the version that I want to have installed. I should mention only version of each major release can be installed, but they can be installed side by side. So you could add, say, installation of 5.7 to the same server, but not another instance of version 8, for example. I'm going to go ahead and click on Next, and then execute here. And it'll go through the installation. And when the installation is successful, we'll be able to click Next to go to the configuration page. Okay, so we'll do that. Ready to configure. Next. Okay. So the first option is whether to run this server as a standalone or in a cluster. For now, or for this demo here, I'm going to just leave it as standalone and click Next. So in the config type dropdown, we're going to have three different options here. We're going to have development computer, which will minimize the amount of memory that MySQL uses. Server computer, which will set MySQL to use a medium amount of memory. And dedicated, which is going to allocate the maximum amount of available memory to MySQL. So the connectivity area is where you configure, right down here. This is the area where you configure the ports that the server will listen on and can configure the installer to automatically open the Windows firewall ports. Security best practices would dictate that you should not have the database listening on the default port. Instead, it should be randomized to add a layer of security through obscurity. There's also a box to enable configuration items for logging and advanced options. So we're going to click on the box, Show Advanced and Logging Options, just by doing that. And we're going to proceed here now. So here we're asked to choose which authentication method the database should use. The default method should always be used unless a legacy application demands otherwise. So it offers SHA-256 encryption through the libmysql client driver. All right, so we're just going to leave it as that. Go ahead and click Next. Now we're asked to provide a root password and create user accounts. So I'm going to generate a complex password here and then paste it in. Go here, paste that. Now the root password should be extremely secure and stored in a safe place, like a password manager. There should be almost no occasion to use this account. Instead, all administration should be undertaken through a named user account for auditing and security reasons. Now I'm going to click on the button Add User. So you must specify a username and password and choose a role and select which hosts the account is on. This could be distributed in a cluster or just on a single install. Expand this here. So role-based access control helps to define a user's abilities by the role they perform. So a backup admin does not require any insight into the database or the ability to run scripts against it, but they do require the ability to put the database into backup mode and to mark it as backed up. DB admin role gives a user the same permission as the root account. So I'm going to select that role. All right, and just to move this process along, I've just gone ahead and filled in the rest of the information. I'm going to click OK, and then click on Next. So now we have the option to set the MySQL database to start and run as a Windows service. You can give it a name for your reference, and you can either leave the default to use the standard service account, or you can specify your own local account to run the service as depending on your security requirements. I'm just going to go ahead and click on Next. Now, best practice for a database server is to separate the logs out into directories on another disk. In a virtualized environment, this is not to increase performance as it would be historically, but it is to keep data separate in event of attack or inaccessibility. This allows you to configure log management tools to retrieve the data without having to give them access to a drive that contains live data. I'll go ahead and click on Next. This page is used for configuring the priorities of replicated servers in a fault-tolerant domain. All right, so go ahead and move on. All right, so we have all our configuration steps. I'm going to click on Execute now. So now the installer will run, install, and configure the MySQL server based on the requirements that we selected during the configuration. The enterprise version of MySQL also includes a built-in firewall for the database for users with additional security requirements. And MySQL is a powerful database server that comes with advanced security features, as well as configuration items to ensure the organization is adopting a good security posture to secure its data. In this video, we're going to discuss MS SQL Server. So Microsoft SQL Server is a relational database management system that provides database, business intelligence, and analytics functions. Database stores the organization's information, making them prime targets for malicious activity. And being a target means that they should be secured and kept away from external access where possible. So the first step is to reduce the footprint of the database and related components that attackers could use to breach the system. So for this demo, I already have Microsoft SQL Server 2017 Express installed. What I'm going to do now is just open up SQL Server 2017, and it's going to open up the Installation Center just to talk about a couple things really quick. I'm going to click the Installation tab here, because this is where you come to modify or create a new installation. Now, a database server should only serve the database components. Often, SQL Server Reporting Service or the Management Studio tools, which you see here on top of each other, will be installed on the same server. This increases the attack surface. It means that if a malicious user gains access to the server, they can use the tools already installed to attack the database. SQL Server Reporting Services also includes web servers that will inadvertently expose the server to the network and potentially the internet. All right, let's take a look now at the configuration manager. I'm going to pop down here into my start menu, find my SQL Server 2017 node, and open up configuration manager. Now, the first thing I'm going to do is click on the first box here, which is SQL Server Services. And this is what's actually running here as services. Notice the SQL Server browser service, and now this responds to requests for SQL Server resources and directs the client to the correct port. So disabling the browser service will stop the redirects, keeping the server obscured from unwanted connection attempts. Now, changing the default ports can help with security through obscurity. So speaking of changing the ports, I'm going to look down here to expand SQL Native Client 11.0 configuration. And under Client Protocols, I'm going to open up TCP IP. So the default ports are known, meaning that holes could be exploited or Trojans written that use port 1433. If the port is not in use, automated attacks can be stopped before they even execute. It is not necessary for both name pipes and TCP IP to be used for client connections. So determine which ones are going to be used and disable the other. So user accounts and authentication in SQL Server should be managed to reduce the likelihood of an attacker getting access to the default accounts. This is the name pipes here I was referring to, so that can be disabled just with the drop down, just as simple as that. Just going to jump into the Management Studio now, just to talk about a couple things here. I have it open. So let me just connect here to the local database. Now the SA account is the default administrative account that ships with all SQL Server databases. It is extremely powerful, and its use is well known. So leaving this account in its default state is a significant risk. I'm going to expand databases, or the security node here, sorry, and find SA and talk a little bit about this. So this account should be renamed to something non-default, and the password should be changed to something very secure and then stored in a password manager. All users should get unique accounts created, and you should avoid assigning users the server admin server role as well. So if I look at my server roles, this is the server admin role that I'm referring to. Be very cautious of any of these roles that you assign, because some of them, like even sysadmin, are very, very powerful. Close that. Minimize that. Open up my system databases here. So I'm going to expand my master database. Just want to take a look at the roles here really quick. There we go. So by default, all databases have a guest account for access. Let me just see if I can move this over a little bit more. There we go. Okay. So what you want to do is disable this guest access. This should be disabled on all system databases except for MSDB, which ensure that users with the public server role assigned are not able to access those databases. So SQL Server is a robust database engine with good security out of the box, but still has some standard configuration items that when addressed can increase the security around the data, which is considered to be the most valuable asset most organizations have. In this video, we're going to discuss PostgreSQL. So PostgreSQL is an open source hybrid object relational database system. It is ACID compliant, scalable, extensible, and works on all major OS platforms while using SQL language even for document storage. So the first step to securing any database is limiting the connections to it. So Postgres has a configuration file called pghbaconfig that acts as a firewall, limiting connections and their authentication. So I'm going to open up this file here now. I'm going to edit this in Notepad++ so it's easy to see. Okay, and we're just going to scroll to the bottom here. So it reads as a set of records. The type is how the connection happens. So host is a TCP IP socket that could be plain, or we have SSL. Host SSL forces it to have SSL encryption, and host no SSL would be a plain TCP IP connection. The database can be specified to limit connections from applications to only the database they use. Users can be kept in a separate file, or groups can be used, or you can add a comma-separated list. The address is the originating connection. So for example, from an app or from the DBA's workstation. And finally, the authentication method can be used as one of numerous types, including LDAP, radius, cert, or a local password. The file is read from top to bottom, meaning that as soon as the rule is found that matches the request, it will be processed, and the file will stop being referenced. So to strengthen the blocking rules, a generic rule to block all incoming traffic should be added to the bottom of the list, rejecting all incoming requests that there are no specific rules for. Now, more configuration options can be used to harden the installation, and they can be found in the postgresql.config file. Just going to close this here. Okay, and I'm going to open up this one, which is the next file we're going to talk about. And I'm just going to go to line 57 here, all the way up. All right, here's where we get into the connection string starting on line 57. So the listing address can be set to stop it from listing for incoming connections from unsecured networks. And the port can be changed to not be the default one, which would leave it open to Trojans or exploits from attackers who know the platform they are attacking. SSL settings and certificates for encrypting communications are also configured in this file. This goes down a little bit to line 98 where we get into SSL. Okay, so options like the SSL ciphers and minimum versions can be configured here. Resource options should be configured to handle denial of service attacks or significant traffic spikes that would inadvertently cause an outage. Go down to 116 here, which is the resource usage. Now, items like buffer size and working memory need to be understood to be configured sufficiently. The defaults will provide a functional database, but tuning can be applied to increase performance and load handling. All right, let me go down to line 414 here in my file. There we go, reporting and logging section. So logging is a significant part of security, both for triggering alerts on events and for forensic examination after a security event has happened. So Postgres has strong logging functions and options and has an extension for session auditing called PG Audit. Now, Postgres also supports row-level security, where tables can have security policies applied that limits access to the data stored in a row on a per-user basis. In this video, we're going to discuss MongoDB. So MongoDB is a document-based distributed NoSQL database system that stores data in JSON-like documents while still complying to ACID standards. It is available for an on-prem deployment or in the cloud through the MongoDB Atlas service. So MongoDB Atlas provides pre-configured database services deployed on Amazon Web Services, Microsoft Azure, or a Google Cloud Platform, depending on your requirements. The database clusters are managed through the web portal and provide a minimum of 3 nodes for scaling the size and number of nodes to meet your requirements. Now, security to the database is managed through the web portal, and this is where we're going to put the emphasis of this video. So to start off here, I've logged into my MongoDB account. So just go to www.mongodb.com and log in, and you'll land on a landing page much like this. So I'm going to click on Database Access in the left-hand navigation under the Security tab. As you can see here, the first node that is selected is MongoDB Users, and I have one test user. There's also a MongoDB Roles just to the right of MongoDB Users. So I'm going to go ahead and click on that. And roles can be used to give fine-grained permissions to specific users or groups of users. All right, so I can begin by adding a new custom role, for example. So I'm just going to click on this. It's going to want to know a custom role name. I'll just call this Collection Admin. There we go. And role permissions can be assigned per database, per collection, or globally. All right, so if I come down here and hit this drop down, I have these wide array of options. All right, now I'm just going to expand collection actions for a moment. There we go. And we're going to just take a closer look here. So the permissions are very granular, ensuring that users only get the permissions they require to do their job. Auditing should be performed periodically to ensure that scope creep is not taking effect and users are able to do more than they should. All right, so I'm going to create a database here. We'll give it a database name of SS Demo, something like that. And collection name, we'll just call this Collection Demo. And I think that should be good there. So now that we have given the role the permission it needs, we can save the role and assign it to the user. So I'm going to click on Add Custom Role. And there we can see all of its available permissions here. And again, we can now give that over to the user. So I'm just going to go back to Database Access. And let's go ahead and actually add a new user just so I can show you how that works. We'll do this. All right, so I'm going to assign a username here and apply that selected custom role that we called collection admin here. So now it's selected. All right, so I'm going to give this user a name, call this SS user, and we'll do something, you know what, we'll auto-generate a password to make sure it's secure. You can always see what the password looks like just by clicking the show. Generate one more. All right, so we have the custom role here. Go ahead and add this new user. And now they appear right here, SS user, and they have the role assigned. So MongoDB supports two types of user authentication out of the box. So SCRAM or SCRAM, which is a challenge response mechanism that checks a username and password combination, or a X509 certificate for passwordless authentication. So you can basically have your choice between the two. I'm just going to show you where that is really quick here. If I click back on Add New User, I was setting a password here as you saw in the last one, but if I click Certificate, here's where I get alternate means of assigning an X509 certificate as I mentioned. Okay, let's close this box here. And on the left-hand side under security as well, then we have network access. So by default, all network connections are blocked. So the IP address of the client connecting to the cluster will need to be whitelisted. I'm going to click on peering here, which is the second section. All right, so if I click on that, peering is a feature that allows you to connect your virtual networks in your own cloud subscription on AWS, Azure, or Google Cloud Platform with the VPC created on MongoDB Atlas. This helps to reduce traffic going across the internet and limits connections to your internal virtual networks. And finally, I'm going to click on the private endpoints here. So MongoDB takes this one step further with AWS, enabling the ability to extend an AWS private link to the MongoDB cluster, ensuring data is controlled and providing access to an on-prem deployments as well. Last thing we're going to look at under the security tab on the left-hand side is Advanced, which is the third and final link. Now there are some other security options available to lock your MongoDB cluster down, like enabling LDAP authentication and authorization using your own keys for encrypting the database at rest, and enabling auditing services to track user access. In this video, we're going to discuss Apache Cassandra. So Apache Cassandra is a free and open source NoSQL database management system that is used primarily to handle large amounts of data distributed across multiple servers, offering high availability and asynchronous replication across data centers. So installing Cassandra requires the Java runtime environment and Python to be installed locally. And if the installation is on Windows, it requires the Apache Thrift framework executable and for PowerShell's script execution policy to be configured to allow unrestricted execution. All right, so what I'm going to do now, just going to do this through the command prompt. Just going to open this up. And let's just go here. So we'll say program files, Apache, bin, and then I'm going to run Cassandra.bat. Oh, second. Just Cassandra without the run. There we go. Now, with Cassandra running the background, you can interact with it through the Cassandra CLI, which is called CQLSH. So what I'm going to do, I'm going to open up a second command prompt here to interact with this. So let me do that while that's running. So I'm going to just do another one here, second command prompt. Okay, so put this one over here, kind of, because it's running Cassandra here in the background. And I'll work with this command prompt now. So same idea here. I'm just going to go to that same directory. There we go. And then Apache, there we go, cd bin. Now this time I'm going to run CQLSH. Now with no prompt for authentication, we can determine that no authentication mechanism is currently in place for this instance. By default, Cassandra has security disabled. Authentication is enabled through the configuration file, which is a YAML file in the Cassandra folder. So I'm going to use Notepad++ because it's easiest to show in there. So I'm just going to come to the background here. This is where the Cassandra files are. So I'm just going to open up the configuration directory, and I'm going to look for the Cassandra YAML file, which is right here in the list. I'm going to open that in Notepad++, and then we'll discuss it. So there are three main areas of security concern that need to be configured in Cassandra before it should be used. First, you have user and client authentication. Then you have authorization to control permissions. And finally, encryption for traffic between the client and the servers and between the nodes. So to start this off, I'm just going to scroll down to roughly line 103. Here it is right here. Just highlighting it. So authentication is pluggable and comes with two options. Allow all authenticator that removes authentication, or password authenticator that stores usernames and passwords in a table. And down here on line 112, which I'm now highlighting, again, authorization is pluggable as well, and it ships with two settings. Allow all authorizer will not perform any permission checks and must be used if the allow all authenticator is configured, which we saw the setting above. Now, Cassandra authorizer implements a fully management functionality of permissions within Cassandra, which is also stored in the system tables. I'm going to scroll down pretty far now into the file, all the way down to line 1031. There we go. Almost there. Here we go. Right in this section, which I'm now highlighting. So secure communication is managed in two separate configuration paths, one for inter-node communication and one for client node communication. The JVM defaults are used when encryption is enabled but can be overridden in the Cassandra YAML file. Compliance settings for frameworks like FIPS can be configured at the JVM level, and standard Java methods are used for creating and using key stores. So out of the box, Cassandra does not provide a secure environment. However, making a few configuration changes can drastically improve the security stance of the product. In this video, we're going to discuss MS Azure SQL databases. So Microsoft Azure is a cloud computing platform providing self-serve infrastructure to customers. These services include VMs, app services, databases, and others. Amongst other offerings, Azure has native SQL database and SQL data warehouse services. So deploying a database is done through the portal or through the Azure shell. So in this demo, we'll do through the portal. So I'm already logged in to portal.azure.com, and I can scroll down on my left-hand navigation and find SQL databases. You can always search for it as well. All right, so once I come here, I want to now create a new one. So I'm going to just go ahead and click on Add, and it'll go to work here and give me my configuration panel. All right, so first thing is I need to select my subscription, which is pay as you go. And then next is the resource group. And the resource group acts like a folder, keeping all the components of your deployment in one logical compartment. So I'm going to go ahead and select one here. I'll just call it FSD here. I'll pick this one. Now, database name here. I'm going to just create one called SS Demo. And I'm going to pick a server now. So I'll go ahead and do that. I might have to create a new one here. Yep, because none exists, so I'll go ahead and create a new one. All right, so the server name, I'll just call this SS Demo SRV. And the server admin login, I'll call this my test name there. Now we're going to need a very strong password here, so let me copy and paste one in that will be really hard to crack here. I'll just do that. And then there we go there. So these passwords match. And the location, I'll just do East US because that's the closest location to myself. There we go. All right, so now I'm going to click OK on this step, and it's going to go off now and create that server. And now see the server setting here. It's brand new, SS Demo SRV. Now I have this available so that I can select it. So now I'm going to go ahead and click on Next. And it takes me to the Networking tab. So connectivity is the first point of security for a database. You have three options. You have no access, which allows to create connectivity methods after deployment, public endpoint, which gives your database a public IP, or private endpoint, which connects it to your virtual private connection. All right, so just going to go ahead and click on Next to go to additional settings. So the data source can be specified, allowing you to start with a database that is from a backup, or you can populate it with a sample data for testing purposes, or it can just be empty. So advanced data security is an additional component here. I'm just going to scroll down here so you can see that. I'm just going to highlight it. So this is an additional service from Microsoft that provides functionality for securing the data and the database. It identifies and classifies sensitive data, alerts you to and mitigates vulnerabilities, and detects potential malicious activities. Go ahead here now and go to tags. Now, tags from a security perspective, probably not that relevant for this discussion, so I'm just going to move right on through here. Go to Review and Create, and do a quick scan here. Everything looks good. And I'm going to click the Create, and it will now do its validation and begin deploying this database. So it says my deployment is now underway. This can just take a few minutes to get deployed. Okay, so our deployment is now complete. I'm going to click on Go to Resource. And once we get here, we're going to be really interested in the advanced data security here. So in that center column, underneath Overview Activity Logs, just keep scrolling down until you get to the Advanced Data Security, which is just the first node under the Security section. I'm going to go ahead and click on that. Okay. So the data discovery and classification pane provides you with insight into the contents of the database that may be considered to be sensitive data. It will highlight rows and tables that appear to contain strings like passwords or secrets that would be exposed to a query of the data. The vulnerability assessment pane requires you to initiate a scan, but will discover where there are configuration issues that could lead to, say, data being compromised. Just going to scroll over a little bit here so you can see that. So I can just click that and initiate that. And the advanced threat protection pane gives a feed of any security alerts, like repeated attempts at accessing default accounts or malformed SQL queries that could be indicators of a SQL injection attack. And back on the left-hand navigation here, the last item here is transparent data encryption. Just going to go ahead and click on that and just mention a few key things here. Transparent data encryption protects the data in SQL databases and data warehouses on Azure by encrypting the data at rest, and then decrypting it on the fly outside of the application. So by default, it is enabled on all new databases in Azure. So TDE encrypts the database using symmetric keys provided by a service managed certificate, or you can bring your own key and use it through Azure Key Vault. Azure also provides services for data masking through policies and rules that mask data to the end user. For example, a credit card number stored in the database would only display the last 4 digits if queried. 2 nodes above this is the auditing node, again still underneath the security section. Auditing can be enabled, tracking database events and writing them to a target in a storage account or in a log analytics workspace. This can be used for compliance to regulatory bodies or for analysis to understand activity against the database. Databases residing in Azure can be secured in many ways, including limiting access, auditing events, automated vulnerability scanning, and data obscuring. These control methods help to offload security tasks from database administrators who retain on-prem deployments and require the input from multiple teams to achieve the same security stance. In this video, we're going to talk about Google Cloud MySQL databases. So Google Cloud Platform is Google's public offering, allowing self-service for customers looking to build out a wide range of infrastructure and platform items from VMs to containers, file storage, and databases. Cloud SQL instances are deployments of MySQL, PostgreSQL, or Microsoft SQL Server that are fully managed in the cloud. For most deployments, the default settings are secure, but in some instances, a customer may have a requirement to manage their own encryption keys for compliance or regulated data protection. Google provides a service for customer-managed cryptographic keys used with their Cloud SQL instances, ensuring that when any API calls are made, it uses your key and not the one managed by Google when the database is deployed. Now, it's very important to note that this is different to customer-supplied encryption keys, which are not supported. Customer-managed encryption keys are generated and deployed using the key management service within Google Cloud. So deploying Cloud SQL can be done through the Google Cloud Platform or GCP platform or through the command line utilities. So I'm logged into the Google Cloud Platform here. So if I look at my left-hand pane and I scroll down, I can find SQL here. Let me just scroll down through here. And here it is here, SQL. So I'm going to go ahead and click that. And again, this is under the storage section. So this is storage here, and this is where I find SQL. So let's go ahead and open that up. And we're going to be presented here with a default screen. And this default screen gives me 2 options: create an instance or migrate existing data. I'm going to go ahead and create an instance, so I'm going to choose the first one. Now I need to choose the database engine that I'm interested in. I'm going to choose MySQL, which is the first one, but I have, again, the 2 other options here. So choose MySQL. Now the instance ID is a permanent name assigned to the database, and the root password should be complex, long, and kept securely. Google provides a generator for the password to save you from finding one. So for my instance ID, I'm just going to type in ssdemo. And for the password, I will generate a password just by clicking that. Now, the region and zone are specific to your uses and deployment preferences. So this version, or the version of MySQL in use, may vary depending on your application requirements. All right, so I have US Central 1, there's East, West, and so forth. And within each region, you have zones. And of course, they give you control over the database version. So I have the 5.7, which is the latest they're offering. I'm going to click on Show Configuration Options. And we'll scroll down a little bit here so we can study this. So the first note here, connectivity. So connectivity can be done through, let's expand it here, can be done through a virtual private connection or through a public IP. Exposing a database through a public IP is a significant security risk. So by default, all external networks are blocked and will require authorization to connect to the database, or Cloud SQL proxy can be used to broker communication between the SQL instance and external applications. Now, alternatively, using VPC requires the Compute Engine API and Service Networking API to be enabled. All right, so we're going to scroll down here and expand machine type and storage, which is the next option. So the machine type is the underlying VM that the database will run on. You should size this by choosing enough memory to hold your largest data set or largest table. The type of drive it uses can affect the performance of the database and can be enabled with automatic increasing if there is a chance of the data increasing rapidly. Okay, so it's going to now expand auto backups and high availability. So backups, it's going to scroll up a little bit here. Backups can be automated, removing the need for user intervention. Time windows can be chosen, but not exact times. And if you require point-in-time recovery, you can enable binary logging. High availability allows you as an organization to achieve one of the three key pillars of security: availability of data. This option will automatically fail over the database to another zone in the region if there is an outage. And database flags can be added at deployment time, but any modification to the flags later will automatically restart the database instance. All right, we're going to skip flags and come right down to maintenance. So maintenance windows typically happen every few months and are managed by Google. However, it does restart your database, so it can cause brief outages. You can choose a specific day you want the restart to happen, and if you have multiple database instances in the same project, you can choose a relative time for these activities to occur. Labels can be added to organize your database instances to align with your organization, such as by billing department or by application. All right, with all that now done here, I'm going to hit the create button. So when the database has been created, you can connect to it from your client application. And Cloud SQL Proxy requires a local client and secure communication with TLS 1.2 and at least 128-bit AES using SSL security certificates to verify identifies. I'm going to repeat that last sentence. Cloud SQL Proxy requires a local client and secures communication with TLS 1.2 and at least 128-bit AES using SSL certificates to verify identities. In this course, we've examined secure database development, including security planning methods, common security and data breach concerns, as well as the best practices for logging and monitoring data security breaches. And we did this by exploring things like security planning methods and common database security and breach concerns, best practices for using DB logs to analyze for security and data breaches. We looked at the OWASP security standard benefits, CI/CD security integration, and FSD database platforms including MySQL, MS SQL Server, PostgreSQL, MongoDB, Apache Cassandra, MS Azure SQL Database, and Google Cloud MySQL. So in our next course, we'll move on to explore advanced database security and database development with an FSD mindset, including options for data platforms and advanced security.